Well, hello. Can someone hear me or see me? Hey, I'm sure you can. And this is our first minutes of our event, and I'm so happy to welcome everyone here. Yeah, I see my team on the backstage. I see everybody is okay, and we're going to start our Node.js Global Summit 2024 by Geekle. Yeah, can you imagine that? It's 2024. There's still no flying cars over there. We don't have this, artificial intelligence. We have something that reminds us about. It has to come like in few years, but Node.js is here for a while, and it's one of the most important technologies in the world. And I'm so happy, and it's an honor for us to run this event where developers from all around the world, top influencers and the die-hard coders come together and share their insights, practical takeouts of some challenging times, some issues, some findings. And I'm inviting here my team, and here's Sia. Hi, Sia is a community manager who helped us to create this event, who communicated to every speaker, who helped like all these logistics and everything. Hi, Sia, how are you?
Hi, I'm great. Thank you. Thank you for inviting me to the stage. Thank you for the introduction. It was an absolute pleasure to bring together this event, and I'm happy to host it today. So yeah, happy to start.
And
Hi, Paul.
thank you. Let's have it. And hey, Paul, how are you? You're feeling not that good today, but thank you for joining us anyway. How are you, man?
I'm feeling okay. I'm feeling great because we finally here with this Node.js Global Summit, and with Global Summit for Node.js 24, and I'm happy that this event it has some amazing speakers. It has some amazing topics, and we're gonna have some amazing panel discussions. Yeah, so grateful to be part of this community. Grateful to actually help this this community, this technology to grow. And it's sometimes it's pretty humbling to see the impact that this community had on the technology throughout the year. Lots of great people talked about some new technologies, some new findings in Node, and so
thank
cool
you.
to be here.
Thank you, Paul. Yeah. Okay, Sia, it's your time. Tell us more about this event. What to expect, actually? How you design, how you build this event, all these blogs, speakers, Q&As. You know what I mean.
So let's reflect on the statistics surrounding the event. We have over 1,100 registrations. Our community has really came together to explore the latest news, trends, innovations for Node.js, and we are honored to welcome outstanding lineup of speakers, including 10 experts for Junior Day and 14 more for Senior One. And they will share their insight on total of 23 captivating topics. And for junior audience today, we have 8 hours of content. It includes 4 blocks of presentations, 4 Q&A sessions, and a live panel discussion about Node.js trends and predictions. And that's what waits for us. And I guess I do have something to say about the topics. You are on mute right now?
Yeah. Sorry about that. Yeah, I want to give some brief overview of these topics. What is actually going to be about. We will hear today about flawless tests, test runner. Like we're gonna hear lots of information and insights about tests today. Of course, microservices also something new coming up there. We need to hear some updates here. Code brilliance and fintech digital platforms. So that should be interesting and intriguing too. But the next one is something I really admire. I don't remember who is actually author of this, but using TypeScript without TypeScript. I love this naming. And also, we'll have few more topics about TypeScript. So TypeScript is the thing today, and it's growing. So we need to follow on that. Then we'll have something interesting, creative journey to reimagine the web with TensorFlow.js, Node.js, and JavaScript. So it's about technological changes and shifts overall on the web. Yeah, and tests with TypeScript again, and test coverage again. So yeah, lots of TypeScript, lots of tests, and something interesting with technological changes for this year. So yeah, that's what we have to expect for this day. And we also have some upcoming events. Who is gonna tell us about upcoming events?
Yeah, I guess as usually, the upcoming events, that's my part. And yeah, and I now just noticed that I have an orange background, and I'm like, okay, no, it's not Java, it's Node. So I have to switch my background to the green one with the octagons. Yeah, and yeah, so we are as usually our event is the 2-day event. So in case if you didn't have chance to or you forgot maybe about our second day about the senior track, so we have some special discounts for the senior track today. So you can get yourself a senior track ticket for tomorrow, and you can use the Node.js Live discount code to get it. Also, we are having a Flutter event next week, so maybe someone in your team is doing the mobile part of your development, and you're doing the cross-platform development. So yeah, definitely check it out. And we also have a special discount for that. And also, one of the biggest communities, one of the great communities that we help to run is our software architecture community. So we're having a preparation for our Worldwide Software Architecture Summit 24 ongoing right now. So maybe we have someone among the audience. Maybe someone is currently holding the role of CTO, or might be software architect or solution architect, and you would like to participate in this event. We have a CFP forum open, so check out the CFP forum on our website, and also you can grab yourself a ticket while it's still on sale, while we still have the early bird price. And also there is a discount code. I believe we're gonna have a discount code for that one as well, and we'll post it in the chat. Yeah, so definitely have a look on those events. And also we are, as usual, we have our standard JS and TypeScript events. So yeah, have a look at our website, and yeah, those are still early bird price. So that's a great opportunity to grab yourself a deal.
Thank you, Paul, for inviting us there. Thank you for helping Geekle promote our products. And now is my favorite actually part of this intro, is when everyone writes in comments in chat, I'm not sure which the side you have this chat. Where are you from, guys? Yeah, where are you from? What country? What city? I don't know. If you're home, right? I'm home on vacation or whatever. Because back days, I remember that our first Node.js Global Summit, it was 24 hours long, because our concept was like, we don't want to discriminate any nation, any country. So we want to deliver this event to everyone around the globe. So every developer in even farthest villages of I don't know, Ukraine, Nepal, United States, I don't know, Brazil or Australia, maybe could jump in and spend some hours with fellows with this, Node.js movement, and it was super exhausting but super great. I remember those like feedbacks. Hey, people, it's just something incredible. It's now quite common to go to online events and communicate this way, but not that days. It was like first days of COVID quarantine, and it was disaster. Anyway, thank you for being with us. Thank you for writing in comments where you're from. I'm in Nice, France, and I see Greenville, USA. I see Macedonia. I see Ukraine. Slava Ukraini. Indonesia, Macedonia, Greece, Denmark, Argentina, Macedonia again, Nice. I mean, are you in Nice or? No, it's nice. Okay. Indonesia, Sweden, Italy. Yeah, it's real international community. Syria, international community here, and I'm so happy. Okay, what's next? What should we also mention about this event? Probably I should.
Questions in the chat.
So,
this is one of the most important things. Questions.
Yeah. Go on.
Wider questions. Yeah. So one of the most important things, one of the coolest things that we do during our events, that's what we get. That's the feedback that we get, is when you have specific questions about the topic that was presented. So basically, take like a couple of minutes of your time and write your questions in the chat, and we will make sure to ask the questions in the chat. And this is one of the great things, how you can communicate, and this is basically how you can check yourself if you were following. And for me, it's a great way of disciplining myself, like to actually write the questions. And this is what we call proactive listening, and it helps a lot. So ask your questions, and maybe just maybe I have a couple of tickets for the tomorrow event, and I'll manage it with our tech team. So maybe we'll have some winners, and we'll give away like maybe 2-3 tickets for the best questions that you will ask in the chat.
I would say not maybe. Why maybe? Let's grant someone. Mauritius, and also I see Imperia Italy. Yeah, it's quite close to me. Hello there. Viva la Macedonia, of course. India for the first time in this chat. Hey, from India. And keep going, people. Keep saying where you're from. It really excites us that we're not just 3 of us here in this stream, and we have people from all around the world. Okay, what else? Sia, should we mention something else, or we will go straight to our first speaker, and we'll get it started?
I guess we made a great introduction, and we are ready to start the first block.
Let's do it. So the stage is yours. Probably you know what to do. We'll probably disappear with Paul for now. Again, thank you for coming here. Thanks for Venezuela, by the way. Thank you for Romania. Sorry, I cannot stop reading this. Israel, and hello again from India. Thank you to every speaker who comes here to share your energy, to share your passion, to share your insights. Thank you for everybody who supports us in this or that way. Thank you very much, and let's listen to this beautiful content.
Thank you. Thank you for the introduction, guys. And let's start the first block with our first speaker, who is Gadi Raymond, tech leader in Wix. He has more than 10 years of experience in web development, always eager to learn and share his knowledge, passionate about architecture, system design, testing, microservices, and DevOps. So welcome to the stage, Gadi.
Hello, I'm very excited to be here at the Geekle Global Summit, Node.js. My name is Gadi Raymond, and this is the complete guide for writing flawless tests. So a little bit about myself before we start. I'm a tech lead at Wix.com for over 2 years. I'm a full stack developer for more than 10 years now. I'm mainly focusing on backend, Node.js. On the client side, I also do React. And in the last few years, I'm working in the infrastructure world, more DevOps and CI/CD and etc. And I really love testing. And this is the reason I'm doing this talk here. I love writing tests. I love to see how I can improve my test. And I love to see how it improves my code and my team's code as well. So today we're going to cover a few things. First of all, we'll do like introduction about the different kind of test types. We'll go over what is flawless test. What do I mean by writing flawless tests? And I will show you an example of test, a very naive example. And together we will refactor it and see how we can improve our testing skills. And also I'll give you a few tips. So let's start. Unit test. Unit tests are the most basic test there is. They are testing our building blocks. Like it could be a function, could be any sort of logic that we want to test. It could be also a like UI component. And unit test basically should be simple. Integration tests are wider than unit test. In the backend world, it could be REST API endpoint that we're testing. In the UI, it could be like a complex component with multiple components inside. But integration tests involve a few moving parts. It could be third-party APIs or internal APIs, DB, message queues, etc. End-to-end test, E2E test, are testing our entire flow. If you think about web development, most of the time E2E will require like opening a browser and interacting with the browser. This involves our client code and our backend code. And also it simulates how the user uses our product. The basic structure of unit testing is AAA. The first A is for arrange. The second A is for act. And the third A is for assert. Arrange is getting the data, act is calling the system under test, and assert is for verifying the data. This is an example with the AAA. So the first A is arrange. We have like a function here with each call add numbers. We have number A and number B, which adds them together, very basic one. The arrange part is to assign A and B. The act part is to call add numbers. And the assert part is to verify that the result is 7. So unit tests have AAA and they are super fast. They should be testing a simple unit. And if you have something external to it, which has like a side effect, you should mock it. And we have plenty of mocking libraries in the JavaScript world, like Jest have a built-in mocking system, Sign-on, Knock, MSW, etc. Many libraries. Integration tests have also the AAA structure. They should be fast, not super fast, but again, fast. When using integration tests, like I said before, you have like moving parts like DB or external dependencies. Try to avoid mocks. Every time you're doing mock, is something that you are not testing. So if you avoid mocks, the coverage is much bigger. It have only also fixture and teardown. So let's say you have like a DB. If you want to run local DB on your machine, this is something that you need to do in a fixture and like insert data to this DB. And teardown is like resetting the DB and clearing it after the test. Let's see examples of it. This is a test that should return bad requests for invalid email. So the arrange part is to get the data I need to send in the API, the name and the email. And here I'm using a super test here. This is the request, and using post to this API with the data. This is the act part, and the assert part is expect a bad request for 100. And this is the fixture and teardown. Like if before each test, like I want to insert some item to the DB, and after each test I want to reset and clear it. This is very useful in integration tests. E2E tests are much slower because they require the interaction maybe with the browser and the client and the server. It has no mocks because we want to simulate production as much as possible. For that reason, they tend to be flaky. So because we have a lot of moving parts, we have a lot of external dependencies, it could be flaky. It's something that's really hard to write E2E test that is not flaky. It have to simulate the client and our user perspective. You have to think in their hat and think about how you interact with the system, so we can cover the most crucial parts. So I get the question a lot, how much test to write? So like every good question, the answer it always depends. It depends. So, but I can give you a few thumb rules. Like the first one is less E2E because they are very, very slow, cost a lot, very flaky. So you should test only your critical flows. Prefer more integrations with wide coverage over units because you can test much more code with less tests, always a good thing. And unit test only your critical business logic, the one that is very critical to you, and you want to test a lot of edge cases, which will be harder in integration tests. So what do I mean by flawless tests? The main part of our talk. So my definition of flawless tests is test that is easy to read and understand. Like any other code that we are writing, we want that our teammates will be able to read it and understand it and help us debug it. Or maybe think about the day that you will leave your project or your team, and you want others to take care of the code and to understand it. You need to be maintainable. Think about it, if the test breaks a lot and it's really, really hard to maintain it, it's not a good test. Easy to debug when test fails. This is something that happens all the time. You need to think about how much easy will be to debug and understand why this test failed, or where is the code that I need to investigate. Less bugs. We want basically to write tests that our code will have less bugs, and improve the code quality of our team. This is like the main goal. This is something that I really enjoy seeing. You can accomplish it by TDD, which I'm not going to cover in this talk, but basically, even if your test is well structured and flawless, basically it will improve your code quality. So how? Let's see how. Let's say we have a get product with shipping function. It could be also an endpoint in our server. It gets a product ID and a user ID. So the first line here is like we have some sort of DB I don't care which DB it is. It could be Mongo, MySQL. It's not relevant here. But the DB can have like a function called getProduct, which gets product ID and returns the product. And then we have a user service, which take the user ID and get us the user. The reason that we want this user is because we call the shipping service with the user address and calculate the shipping costs. And then we will return the product and the shipping cost. So we have here three dependencies, right? The first one is the DB, the second one is the user service, and the third one is the shipping service. So how we can write good tests? So the first thing that I notice, and this is the first thing that is really easy to fix, like the title of your test. So many times I see titles like describe test, describe product, describe HTTP GET, which is very, very general. And when our test fails, or when we want to look on tests, it's really, really helpful to see a meaningful name here in the describe. So to describe the GET product with shipping, if we will have like describe with the name of the function or the HTTP endpoint, will be easier for us to track it. And also the it. So basically, when you write a test, it should return 200. Doesn't say too much, right? It should pass, it should return 500, it should throw an error, very general descriptions. So we want our description to be as specific as possible, but not too long. So this is like a good practice. I like this pattern that it should and when. So it should return product with shipping for a valid product ID and user ID. It should return bad request when product ID is not sent. It should return not found when product ID is not found. So if this test fail, I'm sure that I have some sort of a bug in the not found area, right? So maybe when I'm calling the DB and getting the product ID, maybe I have a bug there. It focuses us to be more to understand where and why the test failed. Another thing that we need to consider is focus on one thing. So look at this test, for example, not a good one. It should do all CRUD operations. So this do create a resource and checking the response and do put, and then put get, then imagine it will have get and delete. So it have many operations here. And if this test fail, it will be really hard to track where it fails. I have to go on the stack trace and try to figure it out. And also have maybe your dependency, like let's say the get fails after the create. So I'm not sure if my bug is in the get or maybe the create wasn't good. So it's really hard to focus on where is the bug here. If you focus on one thing, like in this example, would be easier. And you can see here, I'm doing a post, and then I'm verifying it with accept. See here, I have to expect, and this is good. I know in a lot of places they say only to do one expect, but as long as you verify one thing, and the one thing here is the response of the create, this is okay. So if you want to write the test for our function, so it should return product with shipping cost and a given valid product ID and user ID. Let's see here. This is the arrange part that we need to do. This is like the naive solution of writing the test. This is user ID, and this is the product, and this is the mock user, and then shipping cost. And then I have to take care of the DB connection here, and then insert into the DB the test product, then getting the product ID. And here I'm using Jest to mock a function called get user, and using Jest to mock the function called get shipping cost. And then I'm doing the act, which calling the HTTP endpoint with product ID and user ID. And then the third part will be to validate that the response is like I expect. So very long test and a lot of boilerplate. So how can we improve it? So the first thing you can do is like follow the dry pattern. Don't repeat yourself. So we can extract the logic to functions, like the logic of adding and inserting a product to the DB. We can create a new product function. The logic of mock the user and mock the shipping cost. We can extract them to functions. And also in the third part, we can use like the shipping cost and the test product that we defined earlier. This is how we don't repeat ourselves. So this is good. This is a good progress, but it can be even better. So I'd like to introduce you that driving pattern. The driver pattern is something that's very useful in Wix. We use it a lot in Wix. So this is how a test looks with the driver pattern. So as you can see here, driver is an object, a class that has given, when, and get. So the arrange part is given a user with user ID, given a product with test product, and given a shipping cost with a shipping cost. The act part is when I call get product with shipping, and the third part is like to get what I expected. As you can see, the driver pattern implementation, like you can have like before all, before each, after all, after each, if you want to do also features and tear downs, and you have like given, when, and get. Let's see the implementation. So the implementation of given. So given a user with the user ID, I just create the mock data, the mock user, and use Jest to mock the get user function. Also in the product, I'm getting a product, then I'm inserting into the DB, saving the product, saving the product ID, shipping cost again, mocking the shipping cost function, and saving the cost. In the when get product with shipping, again, I'm calling the HTTP endpoint using Axios here with product ID and user ID and returning the response. And in the get, I'm returning the product with shipping that I saved earlier with the product ID, the product, and the shipping cost. So look at it again, now that you understand the implementation. Like in this driver pattern, we hide all the implementation details, like the DB, using the HTTP client of Axios, using the Jest mocks. And it really simplify our test. The test is very, very readable, as you can see here. Everyone can understand what I'm arranging, what I'm acting, what I'm asserting. Really helpful. And I introduced it to my team, this driver pattern. And like this is the comment I got in the first PR where I introduced it. Some teammate of mine wrote, wow, especially the driver solution are just a masterpiece. It was the first time in my life when reviewing the test. It was just a pleasure. Thank you. So as you can see here, my teammates even loved it more, and we're using it across my team. And all our tests now have like the driver pattern, which is really helpful. Another thing that we like in Wix is test kits. In Wix, every service has test kit, and every like DB or message queue, and even UI components have test kits. So test kits help you testing the code. So let's say the user, and it helps you even handling mock data. So let's say user service is packaged by another, the service by another team, not our team, but they expose test kit for us to use. So instead of like using hard-coded JSON of the mock data, it's really helpful to have like a type. And here we use like a builder pattern. As you can see here, a user with ID, with name, with address, and then build it. So this is the builder pattern here. And it's helpful because it has types. And if the user service change some of the type or adding more fields, it will they will update the test kit also. So us as clients can use it also. So in the given part here, I use the test kit, and my code is more, it has types, which is a big advantage. Another thing that test kits help us with is don't repeat yourself, try. So let's say we have the DB test kit, so we can share like this between tests, between teams, and not all of us need to write the same logic of inserting things to the DB, of resetting the DB. We can use it all across. We can have also like a message queue test kit, which will be like in-memory message queue just for our test. It's really great. So more tips that I like to follow, and my team also follows. If you found a bug, add test before and solved it. This is really helpful for increasing the test coverage of edge cases that we didn't think about. Consider removing flaky tests. A lot of time, you spend a lot of time of trying to fix flaky tests, or maybe rerun your CI multiple times. And flaky test just doesn't give you the confidence that you want. So maybe consider removing them if they are not worth it. Running tests in CI, it's very important. Basically, you can have a lot of tests, but if you're not running them on CI and enforcing it in CI, it doesn't mean anything, right? So running in CI is very, very crucial. And also to have code coverage threshold. So let's say you have like 80% code coverage, and someone wants to write a lot of code and don't add tests. So we lower the code coverage, and by having a threshold, it will fail the build. So it's like enforcing people to write tests. So I really like it. So let's sum things up. So this is the summary. I introduced you to unit integration and E2E test. We talk about their differences and use cases. We talked about flawless tests. So flawless tests is a readable test that have readable description. Focus on one thing is very important thing that we want to have in our test. I show you an example of a naive test, and we refactor it with RAI, don't repeat yourself. And then I introduce you to the driver pattern, which is really, really powerful here. And I really like it. We saw how the driver pattern refactor our code, and our test is very, very readable and easy to understand. We talk about test kit, how it helps us with handling mock data. It gives us types, which is a major advantage, and how it help us with don't repeat ourselves with like the DB test kit and the message queue test kit. So this is it. Thank you very much. It's been a pleasure.
Thank you, Gadi, for bringing up this topic for us. And let's move to the next presentation. Lucas Santos, Senior Software Engineer from Klarna, will tell us what's new on Node.js Test Runner and why is it game-changing. He's a Brazilian programmer, content creator, and professional trainer. He has been working with web applications for over a decade, especially with JavaScript and TypeScript. Also a Google developer expert, Microsoft MVP, and Docker captain who has been talking about technology nationally and internationally for many, many years. So welcome, Lucas. The spotlight is on you.
Hello, everybody. today we're going to be talking about Node and tests, right? All together, everything in one single place. I'm going to present you the new things about the Node.js test runner, which is not actually very new, but it's something that we are still not using quite a lot. Okay, so first of all, who am I? My name is Lucas Santos. I am a senior software engineer here at Klarna in Sweden. I'm originally from Brazil, so I'm in quite, cold place. But I am content producer. I do a lot of code and a lot of content in my YouTube channels, in my social networks in general, some in Portuguese, some in English. I have a lot of articles. If you want to read any of them, just reach out to me in one of these social networks here down below. So basically it's twitter.lsantos.dev, any social network.lsantos.dev, okay? I'm also one of the Google developer experts for web technologies, Microsoft MVP for developer technologies, and Docker Captain. So these are mostly the content that I create. And today I'm going to talk about Node and tests, okay? So to start, what is my objective here? First things first, my goal with this presentation. I want you to forget Jest completely, right? Jest is the most common one, is the most used test runner that we have today. But do I hate Jest? No, not at all. We use it a lot in Klarna. But I had my fair share of trying to, create boilerplate code and my fair share of problems with Jest. And I think there is an easier way, and I think there is something better. It's time to try something new. Jest has been, old for a while. And it's just this, basically. It's quite that simple. So please let me know if I convinced you in my social. So reach out to me, and if I convinced you, drop me a line. I'm going to be super, super, hyper glad that I am convinced you to, use Node.js test runner. But how I'm going to do this? I'm going to do this by show you something that is possibly better. But why possibly better, right? Just because the test runner is still being improved actively, right? It's something that we're still working on it. And well, you can already use it. It's stable in the Node 20. So you need to be in Node 20 at least to use it in a stable version, but it's stable, it's production ready, you can use it. We have already used it in Klarna for a while. I used it in all my projects, my new projects. So the first thing that I want to bring to our attention in this is what is actually bad about the current test runners. Why what we have today isn't enough? Right? Why do we keep looking for something new? Why do we have so many of them? Well, first of all, the first thing, they are very difficult to configure, especially if you're configuring them for TypeScript. And configure things like runners like Jest is a pain, especially those Jest config files, Jest config.js, Jest config.json. There's so many things, so many options, things that were added over time. So it's a very old system. So it keeps growing over time. It does it all. It transforms, it parses, it moves, it asserts, it hoists everything. It has an importer, it has a loader. It has basically everything. It's just too many things. That's just Jest, right? There's others. There are others. There are, smaller. Those things actually make them really slow. Right? You cannot have all these features and expect something to be fast. So in Klarna, we do have tests that take at least 10 seconds just to start up, just to configure, to run all the environment and everything, to configure the environment. So it's slow. It's not easy. And I have a concept that's called YAL. So YAL, it's yet another library, right? So it's yet another library on top of a project. Runners should be a thing from your runtime. Your runtime should actually provide you with a runner like Dino does for Dino test, and we have Bun with Bun test and a bunch of things. But they shouldn't be an extra library that you just add on top of your, your project and you have to take care of. Remember that each library that you add on top of your project is an external code that you don't own and you don't maintain, but you still rely on. Right? So it's an important thing to remember. And also test runners, they seem not to be interested in cooperate with each other because none of them actually work together. So you cannot port one thing to another. They all have completely different configurations. Most of them are really not, talking to each other in any sort of way. So they make sure that you will only be able to use them as the test runner and nothing else. That makes your life very difficult if you want to switch from one to the other. And most of them are really opinionated, so they are really not extensible. Some of them are too extensible. There's just not a middle ground. You are either too opinionated or you're either not opinionated at all, and you have to configure like 5,000 lines in a boilerplate every time you have to run a test. So yeah, it's quite difficult. And if you want TypeScript, but if you don't want to use like Jest, well, good luck, because TypeScript is the nemesis of most test runners. They're particularly hard to configure when you want to transpile TypeScript to JavaScript on the fly, or if you want to actually write your code in TypeScript, your test in TypeScript as well. Mostly because you either have to download another library, so yet another library to parse and transform and move things around. But in general, this shouldn't be the case because Node supports transpiling on the fly by default. It's native. You don't actually have to do it, right? So the final thing is that there's just so many of them. Like, it's overwhelming. It's too much. So here enters the Node.js test runner, right? So the Node.js test runner is not that new. I would say it's a new thing, but it's not. It's really not that new. It came up in April 15, 2022, as you can see here in the PR here on the top, by a guy, a very nice guy called Colin, right? So Colin is basically one of the main maintainers of the test runner since then. So it's a very, very, very interesting project. Later on, one of my colleagues at Microsoft, actually one of my former colleagues at Microsoft, Vasim, he added the support for the top parser. This was in November, like 6 months later, right? So it was super, super cool that they were adding the top parsers on the whole thing. And then it was soon made stable. Basically, I think this was in February last year. So basically, they made it stable on the Node 20 release. And then it's quite usable. It's actually pretty usable. You can use it. I've used it a lot of times. But why is it different from other things? And why am I so, fiercely advocating for this? Well, first and foremost, let me take this out of the screen. First and foremost is built-in. It's no YAL, right? So no, you add another library. You don't have extra libraries. You can actually only use the test runner with built-in libraries. You don't need to install anything else. Even if you want to run TypeScript, well, obviously you have to install TypeScript, but then you can also run it without installing like anything else in your system, right? It is pretty fast, like pretty damn fast. And it's, sometimes people compare one thing to the other because you have other test runners with caches and stuff like this. And yes, then Node test becomes a bit slower because it doesn't have caching techniques. Well, it's about 1 year old. So yeah, but it's still pretty fast. I'm going to show you some benchmarks of this. Not benchmarks, but I'm going to show you some running tests of this one. There's no need to configuration. So it basically integrates with Node. It's part of Node. So it's integrating seamlessly with Node every time. And you can use native assertions or any other assertion library. You don't need to import or install anything if you don't want to. Jest uses, I think there's shy or expect, but Node, you don't need to do it. You can use Node assert. Jest, you can also use assert if you want. It outputs a TAP, which is test anything protocol. And it's a protocol to, test anything. So you can integrate with other runners or even other parsers. So basically you can read your code and integrate with code coverage tools and things like that. So this is not actually very, different from the other ones because some of them also do the same. But this one is native and you can implement it naturally. So you can always use up-to-date Node features. If you're using Node, you will always make sure that everything that version of Node includes it's in your code as well. So it's consistent across every project. So imagine if you have like a monorepo with 5,000 small projects, it's basically consistency. You don't have external libraries, external stuff. There's no polyfills needed if you want to do things. So, you don't have to babble things up. You don't have to ES build. You don't have to webpack. You don't have to do anything. Basically, you can just do your tests the way you want them to do. The experimental support for the code coverage and other reporters is still there. So the Node test, I'm going to do this. There's a whole slide about this, but Node test runner supports both code coverage and different test reporters. So you can actually put on anything that you want. Let's talk about this later on. But it also supports TypeScript out of the box. So the only thing you need to do is to install TypeScript or a parser, whatever you want to do, SWC or TSC, TSX. You can choose it and use it as of importers, which was called loaders back then. So I'm going to also show this in the end. So stay around. And I'm going to show this to you. So getting started, you don't need anything to get started. Just like import the Node test package. You can just import as test. You can also import this, the Node assert library if you want to, but if you don't want to use assert, then you're good to go. So the first thing we're going to do here, I'm going to define that like index.js file with a sum function. It's a very simple function. I'm not here to show you complex use cases of the test runner, but then the next thing we can just create our tests. And the Node test also supports the describe and it feature. So you can import them as describe or it. So you can describe the test, it's the test, but you can also use it general thing. So as you can see, pretty straightforward. This is the whole file, but let's break it down, right? So if you want to write a test, what you do, like you can just import it as a describe or a it, then you import your assertion library, then you import your function, right? Then you just describe the test like you used to do. Like there's nothing new that I'm telling you here. You probably seen this if you did tests at least once with Jest. This is the default thing that you have seen at all times, right? There's nothing new. You can use the test function if you don't want to use describe. You can just like do test and you just put like sum. Sometimes people do a different thing. Like I used to do this a lot. If you change this import here to instead of being test, being describe, then this becomes describe, and then this will still have to be t, and then will be t test. It can be it as well, so you have to can change it here, like in t instead of t, you put it, and then it becomes a describe it syntax ish, right? It also supports function async function, so both of the subtests and the functions also can be async. So you can also do this. So it's pretty much that. The assertions that we use, let me take this out. The assertions that we use are taken care of by the assert library, but this is built in. I usually like to use it, but I agree, I can reckon that it's not the best lib out there because it's not very easy to read and it's not very easy to, make sense of stuff. So sometimes I can use others like Shy. So Shy also does the same thing. The only thing that it needs to do is that the assertion library needs to throw, right? So you need to throw something, and this is going to be picked up by the test runner. So you can use whatever assertion library you want. But the important thing here that I want to show you is that the assertion is not actually tied to the runner, right? In Jest, for instance, you have the assertion library, you have the mocking library, everything is inside the runner itself, which is good if you want to just install and run it, but it's also bad if you just want to run a test and you don't want to do anything else. So if you want to, remove external libraries, of course you can edit, you probably can remove them. I don't know, I never did it. But the thing is, if you want to, it's not opinionated on that fact. You can actually install any assertion library that you want. You can also install other mocking libraries, despite the Node test runner it has some mocking. I'm going to show you this, but the assertions are not tied to the runner itself. So you can do different things with less code. But how do you run this code, right? It's easy. It's even easier, right? So you just it has a built-in test flag. So you can just use node --test, and then you pass on your test file, right? And then boom, it runs and gives you a top output, right? A TAP output. You can see that it's quite fast here. It took 49 milliseconds to run. It's also a very simple test, but the test itself took 0.13 milliseconds. So it took about 40 milliseconds to start up. Or I haven't measured it yet, but it took some time to start up as well. But also it supports things like canceling tests, aborting tests early if you want via abort signals, for instance. It can be skipped, so you can have test.skip or test.only in the functions that you can skip the tests. You have to-do tests, so if you want to just add a placeholder test, you can to-do it. There's improvements in this coming up, because right now it's very difficult to pass a range of files unless you have a glob in it. So sometimes you can just use the output of a glob function to, send the test file names to this, but it's being worked on more, a better feature for this, right? The next thing I want to show you is the mock, right? So mocking is one of the most important parts of a test, because you can actually, well, to be honest, is one of the best features that Jest has, for instance, because you can have the mocks inside, and Jest mocks are pretty amazing. But also it's based on Sinon's mocks, and Node has them too, which is also based on Sinon, as I'm going to show you in the source. So the idea is that mocking, it supports mocking natively a few functions. You can have like context.mock.function, which is basically Jest function. You can mock a getter, a setter, or a method, right? It still doesn't support mocking of complete modules like Jest does, or even adding mocks inside mocks and stuff like this. So it also adds, for now, it supports mocking two more complex structures, but module mocking is coming in the future. I'm going to show you this soon enough. So the two more complex structures that I want to show you is one, timers. So this has been added by a very good friend of mine, Eric. I don't know if you know them, but he added this mock timers API to the test runner. The idea of the mock timers is to mock things like set timeout and set interval, or set immediate, things like this. So for instance, what we need to do, like we're importing things from like Node assert, describe it, and stuff like this. Then we call the callback here. We just created a function, just no jest. In this, we enable the timers. So when we enable the timers, we say, hey, I want to enable these timers, and I want these APIs. That the APIs that I want to enable the timers for is just set timeout. Everything else is not going to be mocked, just set timeout. And then I'm just going to create a timeout of a function that's just like a mock function for this timestamp. And then I'm going to assert if this function is actually being called. As you can see, this is going to run, like if you run this code, this is going to be correct, because it's not called yet. When you mock a timer, you are actually stopping the time, right? So you need to advance the time manually, like we did here. Like we tick the clock forward 99999 seconds, and then this will call the timer. This will trigger the set timeout, and then if we check if the function has been called, that's true, and then we can just reset. When we reset, we're going to remove everything from. We're going to unmock everything, actually. We're going to replace the set timeout function with the original function, right? You can also import mock directly from Node test. So instead of just like using context mock, you can just import mock from the top here, and you can use mock timers. But this is just like easier thing if you just don't want to. You just use the context from the test, right? Another one that is another complex structure that is able to mock is, I think, one of the nicest ones is dates. By me, actually. I added this support in October 23 last year, and it was a very big novella of adding it. As you can see, we have like almost 200 messages in that conversation. But I built on top of Eric's solution on set timers to mock the date object. And the date object is, at least for me in Klarna, because we deal with a lot of time-sensitive functions, one of the things that I mock most in Jest. Using the fake timers. And this implementation that I use heavily builds on top of the fake timers functions from Sinon. So basically, some of them are actually copies of the actual code tied up and modified to work in the Node environment. I'm leaving the link in here. In the end of the talk, you have the links for this talk, and you can, this is completely interactive, so you can click here if you want. Well, this is how you actually mock the dates. It's the same thing. The only thing that you have to change is that instead of enabling the set timeout API, you enable the date API. So when you enable the date API, it's going to replace your date object with a mocked date object that starts in 0, which is the Unix epoch, right? So 1970, 101. And the idea is that you can just run from there. So basically, you're controlling the time now. And then you can tick this from some seconds or some milliseconds forward, and or you can also use the set date or set time to actually set a specific date, a specific timestamp that you want this date to be in. And then you can now assert that this date that we're out now is this specifically timestamp, is the specific timestamp that we're using. And then in the end, you can always reset everything. And well, we use this a lot in Klarna, especially because we have time sensitive functions that like, 15 days, 7 days, things like this, cron jobs that run. So it's something that we use heavily, mocking. Actually, we use in Jest, but we are migrating this to be used in Node. Mocking dates is available in Node 21. And timers, the previous API has been completely overhauled, but the new change, this API that I'm showing you, it's Node 21.6, right? So if you want to try it out, Node 21 has it. I think that has been backported to Node 20 as well, but I'm not sure. Next up, it's code coverage, right? So next up, the Node test also supports test coverage. It's experimental yet, but you just need to enable it on the experimental test coverage flag. This will use V8's built-in coverage tool, right? So this is experimental, use with caution, but everything that I've seen so far, every time that I use it, was pretty much nice. Like it wasn't very a big problem for us. So there's not much you need to worry about in here. But it uses natively the V8 function. So you need Node to be at least on version 20 to be able to use the test coverage function. So the only thing that's going to change here, we just run it with a experimental test coverage flag, and then it's going to run our test like normally. And then in the end, we're going to have a result, and then we have a coverage report. This coverage report, as you can see here in the lines, there is no coverage for line 3 and 4 of that function that we have. So basically, as you would expect, all the rest of the functions that we have here is they are completely covered, right? So I am still struggling with this. Okay, so when we look at these lines 3 and 4, we have the only line that we actually haven't covered on purpose, which is the throw line. It's the only line that we haven't covered. So the coverage function works normally, right? You can also change the test reporter. So if you're using another test reporter, another coverage tool that only understands like JUnit or LCOV or even text or dot reporters, you can use this. So you can just like change the flag test reporter. This is going to both change the reporter for the standard out, and also you can send this to a destination file, like you can see in the test reporter destination. So it's going to get you a LCOV.info file that you can import on any coverage tool that supports it. But the test runner actually supports spec.tap, LCOV, and JUnit reporters. So 5 reporters, right, natively built in. But also the biggest thing that we're going to talk about is my favorite thing, because that's the technology I love the most, which is TypeScript, right? So TypeScript is supported in Node natively. This is like a parenthesis that I'm going to open here. I'm not sure if you all knew this, but it's possible to run TypeScript code natively in Node if you use something that's called importers. It's been called loaders back then, but you can compile TS code on the fly. These loaders are functions that execute before module is loaded, right? So when you do a import or a require in a function, Node is going to call these loaders. And then these loaders receive the whole text of the file, and then you can do whatever you want with those code, right? They can be used to transform the modules before it's imported. They can be used to transform stuff, remove code. This is a lot of things, like we have Babel loaders that allow you to use things that were not in the Node.js. TypeScript uses a few loaders as well. Jest uses loaders for hoisting stuff. So you have a bunch of stuff that uses loaders that you can do it, sometimes even too much. This means you can actually transpile TypeScript on the fly. And some common importers that we use for TypeScript is TS Node, it's the most common one. TSX, which is new, which is the one I prefer. We have ESBuild as well. But let's take our previous example. The only thing that I did was to add typings basically here in those 2 functions that we have. So I added a number here and here. That's the only thing that I did, nothing else. And then we can just install TSX, obviously, because we need to compile the TypeScript code. Then we just use it. The file, we just run this file with node import -- import equals TSX, and then the file that we want to run. And boom, we have magic going on. The TypeScript file is actually going to be executed natively in Node. So this is magic, right? But if I told you that we can actually use the same thing with the test runner, right? So we can do the same import extension with the test file, the test.js. Let's just change the name of the file from JS to TS, and we are writing TypeScript, let's say. And then we can just run it with the import flag. And then boom, it runs exactly the same. It is going to parse the code. It is going to do a console.log. It's going to do exactly the same thing. Now look at this thing and tell me, look at the Jest config.js that you have with 50 lines, and you've been maintaining this as a boilerplate for like 3 years, and tell me if this is not just like a bliss in your life right now, right? So some other support features from Node, aborting tests via abort signals, skipping tests with skip. To do, we have an only also as well. If you want only one test to run, we have lifecycle hooks like before, after each, for each one of those. We can filter names via regular expressions. This is still being improved. We have the external watch mode, which is experimental. And funny enough, for the future, Colin that I mentioned, one of the main contributors of the test runner, he has a wish list for 2024 on the Node test runner, right? So have improved filtering, module mocking. But module mocking is one thing that I told you that's coming soon. So this is how he wants it to look. There is a few other things. I think I would change one thing or two here, but it's a very interesting proposal. We have improved filtering, like the one that I said, test name pattern and test only, because those two functions actually they require the test runner to know all the tests are going to be executed, right? So you have to parse everything before. Maybe more reporters. This is just me saying, but there is talks about more reporters. Snapshot testing. Snapshot testing is something that is also here in the Node. It was briefly in the Node test runner before. It was added and removed because of problems with the underlying implementation of the persistence mechanism, so it was not considered to be production ready. The next one is source map support, like you can see here. This is some wish list, like it can be things that is going to be coming later on, but it's not something that will be there, right? So sometimes it can be one of these more than they as well. More mocks like performance. This one I am personally taking and I want to work on this. So if you guys want to help, please do let me know. But the objective is to actually mock everything, to be able to mock everything in the test runner. And the end, my future for Node.js is the definite fall of Jest. Well, this is a hope, but I'm just kidding, right? So get involved. This test run is still in active development. You can get involved. Documentation is always a good place to start. You can contribute to the code if you want, maybe making Colin happy with his wish list, maybe, or just use it, give a feedback to us, and it's going to be awesome to have more people using it. And start shifting your projects to it, and help the community grow and ditch old tools. Maybe it's for something better, something more native, right? So thank you so much, and well. As I said before, these are all my socials. If you want to reach out to me, if you want to do whatever, please let me know. And this, if you want to, see, let me take my screen here. But if you want to, look at this, this presentation again, these are the links that you have, the keyword code and everything else. And it's going to be on my website, right? So thanks so much for having me. Thanks so much for watching this, and see you soon.
Thank you, Lucas, for delivering this talk to us. And let's jump right into the Q&A session. We have Lucas and Gadi backstage with us. Hi, guys.
Hello.
Hello.
Nice to meet you. How are you?
I'm okay. Thank you for having me here.
I'm good. Thank you for having me also. Nice to be here.
Nice to meet you. Glad to hear that. So how we proceed, we have some questions from the chat. If you have something to add, even though this question wasn't addressed to you, please feel free to share your thoughts. Let's make it interactive discussion. So let's start with the first question. What are some of the common pitfalls to avoid when testing asynchronous operations?
Yeah, so a very good question. Testing asynchronous operations is very challenging. You have like a external dependency. You don't know where this asynchronously things will happen. So in the Node.js world, probably asynchronously operation you mean by using some message queues. Could be Kafka, could be SQS, etc. And you can mock them. And very easy pattern to mock them is like to have like in-memory message queue. From my talk in Wix here, we have like a test kit, and we even mock the message queue. We use Kafka here, so we mock it. But the basic implementation is like to publish some message and consume it. So it could be in memory. It's very, very easy to mock it. Doesn't require a lot of code. And it will test, simulate the thing that you need to test very good, in my opinion. And without external dependencies of the message queue. Because you need to rely on the message queue. You don't need to test the message queue. You can rely that the message queue is working as expected, but you also need to test like the flow of something went wrong, there is a connection issues, and etc. But testing asynchronous operation, I really recommend of mocking it because it's really hard and challenging.
Great. Thanks for answering. So let's proceed with the next one. Lucas, I guess. What tools or techniques do you use to mock external services or databases during testing?
Well, I usually try to, well, if you're using Jest, for instance, like, or any older test runner, they usually have internal building tools for mocking. Jest has their own building tool. So we usually mock them using the test runner themselves. If you don't have one mocking tool, Xenon is a very good library for mocking. But sometimes, depending on what I'm doing, like usually if the project is very small, I usually mock them by myself. Like it helps if you have like some certain patterns of development, like version of control, that you can actually put in some mocks directly in as a parameter, and then you can just pass on the object that you want, and then you can verify it later on. Then you avoid having another library in your code. But if you have a very complex setup, like database or message queue or something that is external, you can usually use these types of things, these types of libraries to mock. If you're dealing with, like in Klarna, we're dealing like with an external service, let's say another API, another thing, there's usually like request mockers, like Knock. It's one of them that mocks like HTTP requests. Supertest is also another one that you can use to mock integration testing. Basically those are the base tools that we use. But I personally prefer to mock them by myself because I have control over the whole mock, and I don't depend on another library.
Great.
And Sia, I have one comment for it. Also, the question that I would like to address here is either to mock or not to mock things. Like external services is something that we usually want to mock because we don't own it, and we don't want to test it. Maybe there is like rate limits or some sort of things that can break our tests. But usually in databases, if it's my database, I usually don't want to mock it. I usually want like to maybe run it locally, or maybe use some Docker or some sort of things that will not mock it, and my test will cover more, I guess. Yeah.
Great. Thank you. Thank you for sharing your point of view. Now we have the full picture on this question. Thank you, guys. And let's proceed with the next one. It consists of two parts, quite big. JavaScript is asynchronous. So how to test synchronous operations, for example, in API calls, when sending an API request and add the entity and then sending GET request. And the next part, to get the same entity that was just added. if the entity is not found, how do we know if the reason is that maybe entity is not yet created or added when the GAT request was received?
Is it for me or Lucas?
I'm not sure. Anything you would like to say? Feel free.
Oh, I guess we can do both takes, I guess.
Yes.
When we're testing, like probably we're telling about integration testing. If you're doing unit testing on this thing, then probably you won't have these calls because you will mock them and you will, return everything. But if you're doing integration tests, what we do here is it's a bit complex, like, because if you have to spin up both services and then try to communicate themselves, this is usually like more than like beyond your test boundary, like you're testing two things at the same time in two services. So the idea would be to test one service mocking the request of the other service, and then you can test like the GET request, and then you respond with your entity, that the one you want to happen. Because in tests, usually you don't want things that you cannot control. So like, you send a request and then you don't know if that request is going to be successful or not. You always know if something is going to succeed. You always know if something is going to fail. So you can control the output. If you're doing these kinds of integration tests, like black box testing, when you just like send one thing to an API and then expect them to come together, you can just, my personal preference is just like to code it as you would code an app. So you code for the usual request, do a usual assertion, and then you do a catch clause for the rest of the things that you don't want to happen. So you can control both of the sides, but it's not very usual, and I wouldn't recommend. But Gadi probably has something to say about it as well.
Yeah, I agree. Totally agree with you, Lucas. And also, like, there could be a problematic thing in like doing an API of create and then doing like the API of get. I also mentioned it in my talk. Like, you want to focus on one thing, because if you're doing the create and then wait for the response and then doing the get and something breaks there, you are not 100% positive if my get request is wrong or my create request is wrong, and it's really hard to trace where your test breaks. So I really recommend on focusing in one thing. If you need to focus on testing the create, focus on testing the create. And if you want to focus on the get, focus on testing only the get request. So this is it, yeah.
Great. Thank you. Thank you for making the full picture about this question. And let's dive into the next one. I'm glad the chat is active today. Thank you guys for questions. And can you mention some libraries or tools for TDD in JavaScript or TypeScript?
Yeah, actually, I do practice TDD. We practice it a lot here at Wix. I don't have any libraries of TDD. Maybe Lucas knows, but TDD is like a common practice. I guess you don't need any special lib or tool for it. It's just some like discipline. I always I'm not like the strict TDD guy who always do TDD and focus on only TDD. But usually when I get a new task, I'm starting with writing the test, maybe just running not writing them completely, but like writing the use cases of the test. And it really helps me of designing my code later, and then just like add like a simple test that pass and then iterate over it over and over until I complete the test and I complete the code implementation. I really love it because it really structures your code. It helps you design and think of use cases that you won't think if you're not doing those tests. And the main reason that I like TDD is I found it a lot that developers are focusing on the task and completing the task and then saying, yeah, I will write the test later, but then comes new tasks and they focus on the new task and never write tests. So TDD is very good at enforcing that your project will have tests.
Yeah, like he said, I think TDD is not a technology. It's more like a common set of patterns. So like the idea of TDD is that you do the test before you do the code. So if you just, let's say you don't have any tools, you can just use the native test runner, just write the code before you do the tests. There you go, you have TDD. And then there is no libraries like to help you doing TDD. I don't know, maybe Pomodoro tasks or something like this that you can do before, and then you can just use that test to steer your coding when creating it. But in general, there's no like libraries or tools for TDD. Any test libraries are the same libraries for TDD as well. It's just the order that you use it. Like if you use Jest after you code, then it's not a TDD library. But if you use Jest before you do the code, then it becomes a TDD library because you're doing TDD. So the idea is that you just write the code before you do the actual write the test before you do the actual code, so you can actually steer the way you're going to code the interfaces, the inputs and the outputs, the way you expect them to work in the test. Because sometimes what you want in the test, let's say you have an ideal API in your mind, and then you code it in the test, everything's going to obviously fail because you don't have anything written. And then you write the API and then you discover that these kinds of inputs and outputs are not possible, or maybe it needs to be different, and then you have to change the tests because of the code. Or sometimes you write the tests and then you can write the code exactly like the tests, and then you even discover a better way of creating an input or an output during like this kind of test. So you start by the end and then go towards the beginning.
Great, thanks for answering. And just one more message popped up in the chat. Someone wanted to clarify his question, I guess. That's exactly the question. For example, I want to test creating an order with several products in, and the test needs to verify the products are all added in the order and persisted.
Yeah, so for this kind of test, I will usually have a DB, a real DB, using Docker or something for the test. In Wix, we call it test kit. So I will have a DB test kit for it, and I will insert the. So you want to create to verify the products are all added at the order they persist. Okay. So yeah. So I will persist them in the order that I expect to, using the DB test kit and not the create endpoint. And basically, I will test the get here. So I will call the get endpoint and assert that the order they are persist is the order that I'm getting. I'm not sure what you want to test here, but you can tweak with it and add it to your test.
Great. Thank you for clarifying this point. And one more long question consists of two parts as well. How do you handle tests that depend on the result of other tests? And there's an example. Test 1, post API for creating a product. Test 2, get API for retrieving all products should include the product created before.
Yeah, I think it's very similar to the previous question. So basically, I avoid it. I don't want any side effect in my test. So yeah, just like I said, focusing on one thing. If I have post, I will test the post. If I have get, I will test the get. And like I mentioned, I use the DB test kit to order to have a fixture before the test. So that way, I will focus only on testing the get. And in the create, yes, it's I need to test that my create is saving the data, returning 2 or 4 created, and maybe assert that all the data exists in the DB.
Great, thanks for answering. And that's all from the chat. Thank you for joining the Q&A session, guys. It was a pleasure to meet you on the stage. Thank you for sharing your presentations. I'm glad to talk to you today. And I guess Lucas is staying with us for the panel discussion, yes?
Yes, I'm staying here for the panel discussion.
Great.
Thanks
so
a lot.
thank you, guys. Thank you, Gadi, for joining. And now we're starting the break. We will be back in live stream in 13 minutes with panel discussion. Bye-bye.
Yeah.
Hi, and we are back. We are ready to start the panel discussion about trends and predictions. We have Ed Nadin with us. Hi, Ed. And he will be
Yo.
Hi. And let me invite our panelists to the stage.
Thank you, Sue.
Lucas Santos. Hi, Lucas.
Yeah.
Hello, long time no see.
Hi.
Yeah, Roberto.
Hi.
Luca.
Hi, guys.
Hey,
So the stage
Nairi.
is all yours. I'm going backstage and do your magic.
All right,
Hello.
my dear people. Hello. I'm so happy to see you all again. You are kind of, my friends now because we've been for a long time together. Some of you are like from very first Node.js conference from Geekle. I still remember. I guess Nader, you are from first conference. Maybe Lucas Santos also, right? On 2020 kind of first or whatever. Yeah, and and the rest maybe I don't remember from the first, but still, thank you for joining. It's a pleasure. It's a joy for us to have you here and discuss what's going on. What's your thoughts on the future? Because this is a panel discussion on trends and predictions. I will be kind of this like LLM model that makes some predictions, right? Or AI model but we're humans, just humans. Thank you for joining. Quick introductions or quick, like, I don't think you need to introduce yourself to this community because like everybody knows you. On this event, we have 1,100 registration, a little more. Most of people watch these sessions after that recordings, so that's what we work and talk for today. So who want to start sharing overall ideas, what's going on with the development world and especially Node.js world? Who wants to be first?
I guess it should. It's better if you just appoint someone.
All right, then Nairi, you are like I don't know why
sure.
you have this microphone, fancy microphone. Then you start.
Yeah, thanks for that. So first of all, thanks for the amazing conference. I really enjoy every time when I participate and I am being part of that conference. So regarding the question, I think over time there are like many native libraries introduced in Node.js ecosystem, which push out the other libraries. For example, I started to use native this testing library. Previously, I was using Mocha or Jest, but right now, no need to install any external library for testing. Well, they have some advantage compared to Node.js native testing library, but still, I don't like to download many libraries. And same thing happened lately when Node.js team introduced this env thing, which helps us to read environment variables using Node.js. So no need to install the .env and any other tool. So I think the prediction that we can make here that over time, Node.js team may introduce many similar like native libraries, and we will push out the other like external dependencies. That's a great idea, I think. And yeah, and any thoughts about it?
Yeah, thank you very much. So we're talking about native tools versus external libraries.
Yes.
This kind of trend. Who's next? Maybe Lucas.
I have. Yeah, my talk was about Node.js test runners. I think like in Klarna today we use Jest like every day, and we have a huge code base. So in this case, when you have huge code bases, it's natural that problems are going to arise. Like libraries are meant to be used in a certain way, and then if you have like super big code, eventually they're going to like fall short in some aspects. Jest goes pretty well in most of the cases. The only thing is that we struggle to configure it most of the times. But once you have it configured, it's quite working okay-ish for some time. But in my opinion, I think the Node.js test runner is walking to be like, it's going to be one of the, slowly transitioning the test environment from like any JavaScript. If you see a cat or multiple cats, I have some. Okay, so don't be ashamed for that. But I think the what Node.js is trying to achieve, what I hope for Node.js to achieve, is the same that Dino achieved. We have, like in Dino environments, we have the Dino test library. So there's no test runners. So in general, when you want to test, you just run the native runtime testing. And then I think for me, that's the ideal world, because like 90, I don't like to install a lot of libraries to do testing. And I think testing should be something very deep within the runtime, because you can have like everything that the runtime offers out of the box, and it's going to work, and it's going to continue to work. That's the most important. So if something comes up and breaks the previous versions, like let's say Jest breaks, and then wow, world is going to go into chaos. But then if you have like a native runtime for running the tests, you can actually run it without this fear of happening, things breaking in the future, because it's going to be from the native runners and the runtimes. So my hopes is that in the future, especially when the test runner becomes something more, widespread, I think it will be amazing to have the kind of downfall of the test runners in general, and the overall shift for people to going into this native testing ability. And hopefully this will make people test more their code, especially because you don't have to install anything. It's going to be like out of the box, right? So the barrier is lower as well.
All right. Maybe more native tools coming up and replacing external libraries you guys have nice experience with, or expectations about. Luca, probably your turn.
Yeah.
Are you okay with that?
Yep. To add some opinion about the test runner, I think is one of the best probably idea that had the Node team, because there are a lot of test framework in the JavaScript ecosystem, and sometimes people struggle to understand which is the right one. And maybe have a native one can help also the newbie to start to use the best or the right one. And the other part, for me, in my opinion, another important part for the Node environment is the introduction of TypeScript. Basically, one of the feature that probably will appear in the next release is the possibility to add the TS config, and out of the box Node build transpile your code, and basically you don't have to use other bundler to convert your TypeScript project in Node in a JavaScript project code base. And this is another small step that maybe help the people to move also to TypeScript, and to have a better type check code base that is sometimes a mess in some code base, because maybe you have a big a really big and old code base with a lot of assumption that the developer had done during the development, and the team in that moment had lost the idea of the code, and maybe there are no tests, and maybe have some idea of the shape of the type can help the people, and also introduce this in the node, in the native node, can help also the adaptation of this. I don't know the thought of the other people in this meeting, but.
All right, growing role of TypeScript. Yeah, you cannot overpass it. Yes, and what else, Roberto? What do you think?
Yeah, I totally agree. Also with the other people, I think that a Node.js project should have things usually used by different companies or projects. Like as we said before, tests is something basic. So I totally agree with the idea that there should be a nice Node test runner inside the engine, because I mean, nowadays you cannot create a new project without tests. Same thing for other libraries, like the security libraries regarding cryptography things. You need to, in most of projects, handle authorization headers, decoding, encoding stuff. So this is something extremely important to have. And same for, as Luca said, the TypeScript adoption. Nowadays, most of the most important projects use TypeScript as a basic tool because it allows the developer experience to be so high. We are using it in Spendesk right now. We were using it, and I think we are they're still using it in Klarna, where I worked before. So yeah, I totally agree that ideally the Node.js ecosystem should have some kind of basic tools that are used nowadays by most of the tech projects in the world. Yeah.
Thank you very much. And yes, what I hear is lots of changes in testing, probably, or it's just test runner. What's going on there? Maybe any additional words here to give our audience more context on that.
Yeah, I have a few comments on these ones. Like, I think what happens is that Node was the sole runtime for JavaScript for a long time, like over 10 years. So there was no incentives, I would say, to create a new, not even talking about like the core team or anything. I'm just talking about like there were no other people to look to, or other runtimes that were doing the same thing. So for a long time, we thought, okay, let's just have the JavaScript runtime inside the server, and that's it. And then we are going to write out userland libraries that's going to deal with everything else. And then we ended up with I don't know who talked about it. I think it was Luca, about the amazing, the massive amount of libraries of testing we have today. So Jest is one. We have Jasmine, we have Mocha, we have Ava, VTest. That's 5 in, I don't know, 3 seconds. Probably there is more. So the thing is, it's becoming very difficult to handle everything. And I think when we started having this massive flood of other runtimes like Dino, Dun, now Amazon with their, I don't remember the name, but we have this this idea of like competition where the developer experience of other runtimes is getting far more superior than the one that Node had to offer. So we had to do something, had to steer in front. So one of the things that greatly improves this developer experience is testing. So you can just have it inside your runtime, and that's the whole thing. We already had assertion libraries in Node, but we didn't have a test runner. So you put in a test runner, and then you have an internal assertion library, which kind of, doesn't feel right. And then you had Chai, which is another external assertion library. And what should you use? Should you use the internal? Should you use the external library? So what happens? So standardizing things converging this massive amount of libraries into the runtime makes for like newbies, everyone that's coming up to Node now, to learn a very like pleasant experience, especially because you don't need to choose between any other libraries. You just use Node native test runner and that's it. And you don't have to learn Jest. You don't have to learn VTest. You don't have to learn anything else. You just have to learn the native test and that's it. That's how it works. So I think for the Node test, for the native test, I think that's one of the biggest reasons, and one of the best reasons I think that happens. And regarding to cryptography, I think that's one of the nicest things. It's very difficult to edit, but I have a friend. He has a PR open in Node for Argon 2. Argon 2 is one of the best encryption algorithms for passwords right now. And this is not native in Node yet, so you have to use a library, which actually he maintains. That's why he's trying to add into Node. But as the cryptography part in Node grows, I think we would have even better security in developer applications, especially because you don't have to go outside to learn about what is cryptography. And if you already did it once, you know how difficult this is. It's not something it's just not a walk in the park. You have like several different concepts that you have to learn. So if you have this native in Node, that's going to be like amazing, because it's not going to just push security, but it's also going to make people use security even more. The same with the test, like it's going to make you use tests even more. If something is built in, you don't have to do anything. It's just there. And well, I think that's my take. Like the more native stuff we have, the best for the ecosystem in general.
Yeah.
Wow, thank you. Go.
Yeah, I kind of agree with Lucas. So that having native libraries such as this testing makes developer experience better. But I was like thinking, have you heard about this news that Node.js wants to remove the npm installer from the Node.js ecosystem? I was like wondering why, because with the same approach, if we try to keep something, just a single like tool, let's say it's for testing, okay, we have the testing in Node.js runtime, but what about like installing the libraries? There are again many other like Yarn or npm or any other like package installer. There are many, so there's a difficulty like which one we need to choose. In that case, like any idea why Node.js team wants to remove the npm from the runtime? So that's a question that I can't answer.
Well, there's a question, maybe some thoughts on that.
I have some thought if you want, and some idea.
Sure.
Okay. Basically, what I understood is there are different point of view in the TSCs, in the Node TSCs. Basically, there are people that want to remove npm and people that want to keep npm, because npm and Node basically run in the same path. Basically, the npm is npm because Node is Node. Together, they had grown together, basically. And I think the idea is that they want to create their own npm package, and they have to understand if they want to continue to have npm or not. But now I want to say that basically I think all of you know Matteo Collina, and Matteo is one of the people that doesn't want to remove npm. I remember one post on LinkedIn and one Twitter where he said we can add our native npm bundler or what you want to call it, but we need to maintain npm in this moment, because npm is the bucket where there are a lot of package. There are so many stuff in npm that it's required also for Node. So basically, this is some thought, some idea. Is the same idea that I have in mind. You can decide if you want to use npm, yarn, pnpm, or wherever you want, but in this moment, npm is probably the most used, and you cannot decide to kill it in, I don't know, from version 21 or 22. It's stupid also for the rest of the community, in my opinion. And I think it's what they are thinking.
Yes, I think.
Yeah.
Go on.
Yeah, Nairi, it's your question,
okay.
your comments also.
Yeah, actually, have you noticed that this registry and this package installers become really flexible now? Like there are like many registries. Recently, for example, GitHub introduced these GitHub packages. Many people use GitHub package, but as the registry they use GitHub, but they install the packages through npm. Same thing we can do with Yarn, with any other registries. I think at some point maybe Node.js will introduce a new package installer, but I think we will use the npm registry because lots of libraries are stored in npm and it can't be removed. It can be replaced like this, as Luca mentioned. But yeah, I always get that feeling that Node.js tries to make everything like official, like part of Node.js runtime engine, because whenever I open the documentation, every time I like notice something new in the menu. Because, for example, 5 years ago, if you saw the Node.js documentation, there wasn't so much like subtopics, let's say some bindings, cryptography, testing, and whatever. But now when you open the documentation, you see so many things, and I'm not sure that there's someone that he's aware of all of those. What which native tools do you usually use? Because there are so many tools. I want to discuss about it if you would like to.
Yeah, ChatGPT knows, I think. All of them, I mean.
Yeah, that's true. But I wanted to bring up something related to NPM. There is a very, very nice talk about NPM called The Economics of Open Source in YouTube. It's from, I think, NPM's previous CTO. She explains why NPM is NPM and why Node came up with NPM. Ryan Dahl, Node.js creator, also did another talk when he announced Dino of why one of the 10 mistakes he put in Node, and one of them was to ship NPM together with the package man. I personally think it was not like such a big problem, to be honest. I agree with Matteo and I agree with Luca as well that if you remove NPM the way it is now, there's one thing that you're going to create, which is a hard time for people that are coming in, because you already have to go in with Corpec. Corpec is basically the idea that you're going to just unite every package manager into the same runtime, so you can just use whatever you want. But the API is not very, very good yet. It's still being worked on. And it's very confusing. Like, why were you going to use Yarn? Yarn also has a mirror of the NPM package registry. So if you're using Yarn, you're using the same package register, but just somewhere else. If you're using PNPM, what is the difference? If you're using Bun, that's a completely different thing. Now there's JSR, so it's completely other different things. So we're getting into the same topic of the libraries and the test runners. So just a bunch of libraries coming up. But I think the reason why they want to remove NPM from the Node environment now is to decouple this idea that Node and NPM are the same thing. Because most people say that NPM is Node package manager, which is not true. Like NPM doesn't have like a thing. It probably was in the beginning, I would say. But I think if we remove now NPM, we're just going to create like chaos, because it's going to be very difficult for people to just have to install Node and NPM and have to install Node and a package manager. So it's not going to be very interesting. Even after like 10 years, we're going to remove it now. It's not going to be the same idea. But I really suggest the people that are watching to get into this talk that's called The Economics of Open Source. It's very well explained how NPM became NPM and how it becomes that things go in the future. So just wanted to highlight this.
Yeah, thank you very much, Roberto, Luca. Maybe any other ideas on here?
Yeah, totally agree with that. My 2 cents on it is that until there is no real standard alternative to NPM that will not cause breaking changes to existing projects, it will be very hard to migrate. That's the same reason why it's hard to migrate to something new, like to migrate also the test from a technology to another one. For NPM, I think it's something bigger. So yeah. And regarding the topic of reducing instead the number of dependencies, I totally agree on that. As we said before, it's really important to have standard tools inside the Node.js core to solve common issues, because otherwise we have seen how much burden it adds to have so many dependencies that has inner dependencies, and if there is a security vulnerability, or if you need to do if there is a bug fix, an upgrade, and the problem is inside the dependency of a dependency, it's really complex to solve. So yeah, the way I see Node.js in the future, especially as a trend, is that developers would like to see more and more standard tools inside the Node.js core, and of course for things that are not maybe standard, or that are solving a use case that is specific to a product or something else, it's completely fine to use external dependencies. But ideally, it would be nice to
cliffhanger.
I'm not sure. Am I freezing or is
No?
on the
No, he froze too. Left a cliffhanger over there.
Yeah. Okay.
Oops.
All right. Yeah.
Yeah, sorry.
Yeah. Would you finish your thought, or?
Yeah, I was just saying. Sorry for the connection drop. I was just saying that probably the reason why other engines like Dino or Van are becoming famous is because they include things like natively things like tests inside, or TypeScript support. This is something that probably would be nice to see in the future also in Node.js. Also, if we have a look at the topics and talks we've seen in these Node.js summits, lots of them are with a focus on test, TypeScript adoption, having native features for security. So I think it will be a hot topic in the future for the Node.js ecosystem.
All right. Okay. Okay. Cool. So, what do we got here? Tests, TypeScript, cryptography, and I guess Lucas, it was you who mentioned the system design. What did you mean about changes or trends in system design regarding to Node.js and like future, or I'm mistaken?
I think in general, those I think these actually converge very nicely to how people are going to design software in the future, because we've seen Klarna, for instance. We have several systems that are like 5, 6, 7 years old. Klarna, the company, is like 18, I think, 18 or 19 years old. So we have several systems, legacy systems. And we've seen in those previous systems, we have like Express APIs that still used what we used to have back in, like, 2013, 2014, which was like this middleware pattern where everything was a middleware thing. But then we've seen other services that are like newer, becoming more focused on composability instead of just using like a huge pipeline of middlewares. So in the future, with these new native technologies, let's say TypeScript by default, or even native TypeScript support from like Dino does or Bun has as well, you can change the way people develop code, because like in TypeScript, you can do some design patterns that are not possible in JavaScript natively because you don't have types. So in TypeScript, you can enforce some of these design patterns in an easy way. It's not possible, but in an easy way. So I think people are going to be more mindful about how they design their systems and how they, instead of composing things in thousands of millions of really, really, really small functions, some of them are going to be bigger ones. Some of them are going to be using like inversion of control. Some of them will have other patterns that we're not very used to see in the common development today. So I think people, like, one example with this is like with a native test runner, people are going to be testing more. So if you test more things, one thing that you usually does is like inversion of control and dependency injection. So we're going to see more of these patterns in the development of new applications in the future, probably because people are going to be using the native test runner more than they use now. So I expect to see like a shift for a more mindful design decisions focus on these parts.
All right, cool.
What do you think? Like, will they completely replace the Jest, Mocha, the native ones? I mean,
I think it's going to take a while, but yeah, eventually I would like to see that, to be honest. I've been using Jest and Mocha and Jasmine. Like Jasmine was one thing that died like a long time ago, but still people using it. So I would definitely like to see people only using the native test runner. Today, it's not possible because Jest has way more features than the native test runner has. But eventually, these features are going to come in the native test runner as well. So there's going to be no reason for people to use Jest or Ava or vtest anymore. So maybe that's one thing that's going to be in the future, but probably it's going to take a long time. I would say like 7 to 10 years to people, definitely lose the mechanical npm install Jest in the terminal that people do already. And the same thing goes for cryptography. A lot of people still use like bcrypt and other external cryptography libraries when Node.js alone is capable of handling most of the cryptography cases that we need for web right now. So I think that's something that's going to come up with time, and people knowing that there is something there.
Yes, I think the same thing we can say also about the Lodash and underscore. We all know that Lodash is the top one installed library in npm. There are like so many like developers using Lodash underscore and similar utils library. But I think even if Node.js introduces like full version of Lodash methods in the utils native library, then still it will take lots of time until it will be completely replaced. Yeah. Same, I think.
To be honest, I don't see Lodash in specifically or underscore or Ramda for this case coming up. I think the Lodash case is more a TC39 case than a Node thing. Like I think people like Node already has a few things that Lodash was implemented. Let's say array group by, for instance, is one of the things that the TC39 committee is implementing in JavaScript, specifically the engine, to be able to use group bys. So one of the things that I would love to see is array chunks in native Node, but I am a serious advocate for not using Lodash because I think most of those things that people use in Lodash can be done in Node. Like there is a method in Lodash called head, which returns the first element of an array. So I'm like, well, why? And yeah, so I don't see this in Node specifically, but I would love to see it in JavaScript. Like it would be amazing.
All right. I like this conversation. Yeah, go.
Yep, I think one of the stuff that can help to use the Node test runner is the adoption of the native test runner also in the open source project. Because if people look into the, I don't know, Fastify, whatever you want, in every open source project, and they see that there is the Node test runner, maybe they have an idea, oh, maybe can I use it also in my project? But if you open now GitHub and you go in the test folder, probably you find Jest, Vitest, Java, or whatever you want, and it's also a stuff to make a decision. Why I have to use the native test runner if the measure of the package in npm use I don't know, Jest or Java or Vitest, and maybe I think also the maintainer of the open source project have to design the path to follow. Basically, is one of the idea that I have in mind. And another problem or topic could be also what happened now on Express that is changed the TC member. Maybe we can have a new measure release. I don't know, but we will see.
Oh, something happened there. Yeah. So, it's a lot of interesting stuff. I'm not sure if we have any. Just to mention, on April 9th, we will have this TypeScript summit. And if you're guys interested in it, go to our website, Geekle.js, and secure your spot for free part or for advanced part, because we see how TypeScript gets more and more kind of influence in different technologies, not just Node.js. If you use different technologies, you can see it almost everywhere. I mean, in JavaScript ecosystem, so join us there. And the last probably question for today about AI, of course, this is the buzzword we cannot forget about. So what, quick question, what AI tools do you personally use today? Is the first part of question, and second, what is promising for you? I mean, what tools or class of tools is kind of promising for you in regarding to the software development, especially maybe Node.js development? Okay, smiles on Luca's face probably leads me to invite him first. What do you think, Lucas? Sorry.
Luca
or Lucas?
Luca or Lucas, yeah.
Yeah. Luca.
Me? Or him?
Luca.
Okay.
Okay, Luca.
Okay. Okay. What I use basically Copilot. I use Copilot every day, and he tried to help me. Sometimes he understood what I want to do, and maybe help me to reduce the time to type a lot of characters from my keyboard. Sometimes the result is a mess. So yes, it's work, but depend on the scenario and on the stuff that you are doing, basically. The second question, I don't remember. The second question is
what looks promising for you? What probably we could use in future?
About the development part, right? Okay. I think now we have. I think Copilot has the market now and has also the money to reduce the time of the developer to, in reality, to remove the boring stuff. Maybe you can write a comment and it create the structure of your code, and then you have just to fix the stuff, because sometimes it's not perfect, but just to align the code with your project. I think for the development perspective is the best one in this moment.
Okay, and it's always the question: are you at the break point, and have you already past this break-even point where your time invest the explanation to this tool is then or you still like have to spend lots of time to explain actually what you want, and then you get that code and you are not sure if it's worth.
Basically, in this moment, I'm working in a big project, and I think Copilot understand very well the context, and the result is good enough in this moment.
All right. So, if you say good enough, it means it makes sense to use.
Yeah, exactly. I think I don't lose my job because there is Copilot, but maybe I can improve.
Not you, Luca, not you.
But probably I can improve my productivity.
All right, cool. I would love to hear some opposite opinion about all these code assistants who hate it and don't use and whatever. Do you guys have something like that? No, or everybody's using someone. Nairi,
I use it.
Okay.
I use it a while. Like I was against it in the first initial when it came up. So a bit of a story that we were using this like when I was working at Microsoft, like in 2019, we had some of the first usages of this Copilot Alpha for the internal employees. It was cool, it worked, but obviously not as good as it is today. But I am with Luca in this one. Like sometimes you just write something and then it completely hallucinates and it gets something completely wrong. One recent example, like last week, I was doing an article about cryptography, about RSA cryptography. And the whole point of the article that I was writing was for me to understand RSA and also teach people how to create an RSA key manually. So there is a bunch of math involved in this. So you have to, work on the mathematical side and stuff and figure out how to put things in the code. And I was like, okay, let me just use Copilot to do it. And I said, like, commented, write me a function that does the extended Euclidean algorithm, blah, 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 blah. And then he wrote a function. But I was like, is this correct? And then I request a second opinion to ChatGPT. So I was like, okay, I'm going to use an AI to analyze an AI's code and then see if something is actually right or wrong. And then ChatGPT found an error in the Copilot's code. And then I put it in, and both were completely wrong. So I was like, yeah, not yet the thing that we are expecting, but it's getting there, I would say. Like today, those are the two biggest ones that I use. They help me a lot, especially writing tests. Like they are really good in writing tests. So if you want to do like Copilot testing, that's awesome. You can just like, write me a test for this function. It completely writes every single case of code. And it's amazing because you have the working code and writing the test is actually the easy part for them. When you have the opposite, that's a bit complex because usually they mess up in logic and especially mathematical functions and stuff, because there's just so many places where they look at to, there's like math. There is a bunch of places that has the same implementations of the algorithm, but in different ways. So they don't know which one to use. And usually they take parts of each and they assemble something that is completely inaccurate. So my advice, do not trust the code generated by either ChatGPT or Copilot blindly, okay? They won't, like 90% of the cases, they will work somehow, but there's gonna be quirks. And I've seen people doing this in important applications. And please don't try to look at and review it as you would do with someone else's code.
Okay, but it's still useful for you.
It is. Yeah, I wouldn't say it's not like useless. It's very, very good. It helps. I think every tool, like AI tool, helps a lot. It, like Luca said, it works. It's something that it's good enough, but it's not perfect. I doubt it's going to be perfect one day, but it's good.
Okay. I thought. All right. And any other tools? Maybe Roberto. Maybe who else? Yeah, Roberto. It's maybe your turn. Yeah.
Yeah. So in my case, I need to be honest. I'm not using it a lot because.
Oh yeah. Hello. Thank you.
No, especially because I'm working on a very customized code used by my company or new tools. And I tried, of course, to use, for instance, ChatGPT for some time, but then I had to invest more time to understand if the response was correct and to fix it and to improve it and to ask another feedback than to actually write the code or think about it. So in my specific case, it wasn't so useful, but probably for some, when you have to handle like low to low average complex scenarios in code, probably in this case it's quite useful. For instance, if I need to do a summary of a documentation, like what does these specific commands for this specific language does, it's very useful because at the end it's just a language model that predicts the probability of a next words. And so in this case, I found it useful to do some summaries. But yeah, to be honest, overall, for what I need to do every day, it's not so useful, at least for me. Sometimes I find I'm more productive to just write the code and maybe to leave ChatGPT things like, okay, please find a nice description for this PR or this comment in the code, or maybe, yeah, write some code for a test. Again, I find it more precise with Jest tests because, of course, there is more Jest code in the open source world. When I need to write some more complex Node.js tests, it wasn't so precise, so I prefer to do that by myself because sometimes maybe it's correct, sometimes not, but you are wasting your time. So yeah, that's my experience. To be fair.
Thank you very much. And Nairi, I'm sure.
Yeah, and yeah, actually, yeah, definitely it makes me faster, productive, and definitely it's useful. But there is of course some disadvantage. Usually, I use the ChatGPT whenever I want to fix some grammar issues or find some better variable function namings. In that terms, it works really great. Also, let's say if there's some manual work that I want to do because it will take some time. Let's say I know I need to create a Postgres table. It should has these columns, these types. I just type it in ChatGPT and I say, hey, generate the SQL, and it provides it. In that terms, it's really great. It helps to do faster this manual tasks, manual work. But whenever I say something that it needs to provide some proper results, it may have some bugs inside, it may have some issues, and I don't like to use much ChatGPT if there is something that I should trust it. Because let's say in case of transformation my text into the SQL, I can immediately notice that it's wrong. But in case of something that I'm not aware, I will just trust and maybe it will be wrong. Also, lately, I noticed that people are posting lots of things, and sometimes I find some keywords that makes me feel that this post is generated by ChatGPT, because whenever, for example, I say, hey, ChatGPT, generate a text regarding XYZ, it generates, but there are some keywords that are constantly repeated. And sometimes when I read that kind of article or post, I don't feel like confident with that post or whatever it is. I just keep it. So we need to understand where we use that. But overall, it's pretty productive tool.
Yeah, you read this article and then you like starting feeling something, and then you say no good, man, no good, and you leave not even reading until the end because you like, oh, some machine generated. I want to feel like your thoughts and everything. Yeah, I totally follow. Thank you for your experience and sharing that. I just want to mention that we just starting, we're launching our AI laboratory where we're trying to research and test various tools. Lots of tools that use AI for software developers. Right now we have more than 200. We found more than 200 tools. Most of them are something not useful, just something connected to OpenAI API or something. But some of them are real promising and brilliant, and I would love to share with the community, with you guys, some interesting findings. And tomorrow we're wrapping up this panel because our next speaker is ready and agenda is like still exists. But I'm super excited to talk with you guys here, and I would love to spend more time here. But we're gonna move on. And tomorrow we'll have this panel discussion again, but about AI, especially AI. And key question will be when or at what conditions AI will be kind of nice and really helpful assistant, and maybe will took some part of work from our shoulders, giving us more space for creativity, for engineering, for problem solving, and more interesting part than just creating another code base. Guys, thank you very much for joining, for spending this time with us, for your energy, for your cats, for your microphones, for your like deep like insights. Thank you very much. I'm so happy to see you all again, and hope to see you more and more times. Okay, I see Sia on our backstage, and she's already here. Sia, we did it, and I think we did it real great. So the stage is yours, guys. Again, thank you very much. I'm leaving, and I'm leaving the stage to you, Sia.
Thank you. The panel was great. Thank you very much for sharing your insights. So let's start the next block. We took the whole break, but I guess it was worth it. It was really insightful to hear you guys. So we have our next speaker with us on the backstage. It's Alex Korzhikov, Senior Software Engineer at ServiceNow. Hi, Alex.
Hi. Hello. Hi, Sia.
Hi, nice to meet you.
Yeah, thanks for having me. Nice to meet you too.
Thanks for joining us. So are you sharing the slide screen?
Yeah, but I decided since I'm here, I decided to jump in and say personally, hello, how are you?
Hi, yeah, very good, very good. I'm recently in Austria. I just had a ski vacation here, and it's actually amazing land. So I cannot be more happier, let's say.
Absolutely, I totally understand you because we have like in 2 hours skiing resort here. But did you hear this previous conversation, this panel? Like I'm super excited. It moves so fast.
Just a bit, unfortunately. I probably will rewatch some recordings, but it was nice to see some of the folks that I, happy to know. So yeah, I'm looking forward to watch some recordings. Was it about ChatGPT in the future, right?
It was only the last question. We talked about like tests, TypeScript, and everything, and like what's trends in Node.js. But okay, bring us what you have for our community. I'm sure you have this brilliant talk.
Absolutely. Yeah, just a quick question. Thanks, Seth. How much time do we have actually?
So it was 30 minutes, but I guess, yeah, we can do the full 30 minutes speaking slot. We can do it again.
I see. Yeah. Yeah, probably you should be, we should able to see my screen now.
Yes.
Right. Yep. Right. And the slides as well. Nice. Let me
so the
start.
stage is yours. Going past stage.
Thank you. Thank you. Yeah, interesting. Actually, maybe I should reshare it with. Yeah, let's do it like that. It's also fine. Hello, guys. I hope you're doing great. I'm Alex. I have half an hour. And yeah, that's an interesting challenge. I think originally this isn't a talk. Actually, it's more like a masterclass. But yeah, let's try to squeeze it in one short talk, and maybe that's even for better, because with how fast all the tooling around different technologies in Node.js and in JavaScript changes, you never know if your demo works or not, even after half an hour. So let's see. Welcome again, everyone, to my talk, Ways to Make a gRPC Microservice in Node.js. I'm Alex, and I've been working with Node.js for quite some time. Yeah, I last 2.5 years I spent in investigating and exploring gRPC technology. So I'd like to share some of the basics, I would say, of this technology with you, to show you some examples. But that's I'm gonna demonstrate in a bit. Yeah, so I hope you're having a good time here in the conference. And if you have any questions left, of course, you can contact me and ping me afterwards in social media, in your favorite social media like LinkedIn or GitHub. Anyways, so what we're gonna do today, it's not gonna be a lot, but I will try to show some of the basics, the fundamentals for the gRPC technology. I will first explain what is a gRPC itself, and it is based on protocol buffers. So we'll also explore a bit of protocol buffers, what it consists of, and so on. And last bit, I will try to show the Nest.js example. So how it's structured and what can you achieve from it. So I would suppose that we will cut a bit some of the demos, but I will try to show at least the sources that we can have and what these sources mean in terms of gRPC. So hopefully you will get an idea what the gRPC is and what the protocol buffers intended to do and how they bind to each other world. What are the applications? What is the use cases for these technologies? And yeah, let's try to also compare. We don't have that much time, but let's try to compare a little bit alternatives for gRPC, which is there are many alternatives, of course, but I think it's good to compare with very well-known technologies like REST API and, of course, GraphQL. Yeah, and as I said, a few demos will come, so let's see how much we can do in it. So let's begin with gRPC itself. Well, what is the gRPC? And I have a website here with a more resources, let's say, on gRPC. And for this slide, I had this of course, gRPC stands for remote procedure calls, of course. But not only that, gRPC is well, first of all, it's a framework. It's a framework for microservices communication, and I think the most important there is still RPC, remote procedure calls. Yeah, I have a graph here on the right. As you can see, this is I think this is from a survey that Postman did last year. You can see that the rest is yeah, how different technologies compare in terms of usage in different microservices. What the developers choose actually between between these technologies, and you can see that REST is yeah, for sure the number one, the most popular tool, and then the slightly in order you see the webhooks, SOAP, GraphQL, and only there on the sixth place you can see gRPC. So, however, it's yeah, actually it's top 5 or top 6, so it's actually still quite popular. But the main idea is that gRPC is still a lot of it's much applicable, but for concrete use cases. And the main use case for gRPC is a case when you need to be really fast in transferring your data across multiple huge ecosystem of microservices. If that's the case, gRPC is something for you to consider. And I myself worked in a big enterprise company, in a financial company, and of course, we had our own platform to develop like how microservices communicate to each other. And yeah, that's interesting that our platform back in the day was built on top of REST API. But now I see that they slowly, different companies have to choose between these technologies. And even if you make a choice for example, REST API, you need to introduce lots of tools which in fact can be already implemented in worlds like gRPC. So let's explore a bit what I mean by these tools and by these capabilities. Well, a little bit of history of what gRPC is and where it appeared, where it first started. It's not that old technology. It's started from 2015. Well, you can say that it's still young. And it first appeared in a company, Google. Yeah, in a company which of course owns this huge infrastructure of microservices. And for big companies like Google or Microsoft or yeah, you can name it, Amazon, whatever, you have tons of teams who own and develop different services. And as a this scale company of this scale, this big company, you cannot say that yeah, let's all choose I don't know, Java technology, let's all build on JVM stack. That just won't happen. Because yeah, basically there are so many needs for all these technologies. Like if you build yeah, we all know what the JavaScript is good for. One of the use cases for JavaScript and Node.js is to build something for front end, right? Is something that you can be really good at when you're serving data or serving I don't know, logic for your front end. And it's really allows you to move fast if you use the same language on a back end and front end. So sometimes it's the case when a team decides to choose JavaScript technology. And yeah, and in big companies like Google, it would be really impossible to deny it and say, yeah, you have to write everything in Java. So yeah, you basically end up with an infrastructure where all the teams use their own technologies. So how would you still unite them and make their communication efficient? And that's where they decided to invent some additional protocol and to support this protocol between teams. So it was in 2015 or 2015, actually, somewhere around this time. And later, maybe a year or 2 years back, after they first developed it internally in Google, they open sourced it, and it was really taken good by the community. And it's now clearly a technology that is driven by community a lot. And basically, the goal for these technologies is to standardize architecture around microservices, to build some tools to help with this communication, to support it, and to do different validations. So yeah, there are different tooling that the teams can use between. Yeah, in the slide you can see that is built on top of, or originally it was built on top of other nice open source tools that Google introduced a while back, like Speedy or Quick or Stubby. Yeah, I don't know if you heard about them. So right now we are we probably don't remember them that much, but at the time it was an experiment that ended up with a HTTP 3 version or 2 version. So yeah, Google continuously working on improving their communication capabilities of their services, and that's why it's actually quite interesting to see the gRPC as well. So right now it's a part of Cloud Native Computing Foundation. It's a supported umbrella for it. And what I like about the documentation, it's very, very nice and a tiny website that you can read specifically for your use case. It has different supported use cases, and it has yeah, you basically can go through one of these tutorials and it would work. However, maybe for Node.js, it would be a bit different than for other languages. Probably we'll talk a bit about it later on. But anyways, highly recommend the nice documentation of it. So let's talk a bit about what is gRPC, and let's start with the RPC. So the rest part of this fixed part of gRPC. So remote procedure calls is some design pattern for software, and in this pattern, like in all communication patterns, you have client and server, and they need to communicate to each other. And it's interesting actually that the client can be a server itself, and the server can be a client itself. So you know, in these terms, your microservices can play two roles, and they still need to send or receive a data from different microservices. So in the RPC world, how it looks like as a client, you want to get some data from other service. In this case, you run some local procedural service, and this will give you. This will actually execute the remote API, a remote procedure that probably will return you some data back if it's designed to do so. And the client continues to run. You can compare it with HTTP calls. In HTTP calls, it's slightly different, right? You have to describe where you go, and you have to put the verb, HTTP verb, get, post, put, and so on. And then you have to hold a bit when the data comes back, but the interface is going through HTTP. So comparing with the RPC, you act as you would have this service on your local, and you don't mind too much if it's a local or external. In fact, you don't care if you need to go through the network to get your data. You operate as if this service would be local for you, but that needs some toolings on your local. And in this picture, you see that this is a generated code stub on both sides, on server and client, and it's capable to do some things for you. Like first, it needs to zip or let's say store the message somehow. So you need to encrypt this message, then you need to decrypt that message on the other side, and also what is important, you need to transfer this data through the network, and that's what the gRPC is doing for you. So let's go on and try to compare it. So if you look at other alternatives regarding the gRPC, I mentioned HTTP calls, so that we can actually see as a REST call, for example, or GraphQL call. And in this case, I have this table here. So let's try to compare REST, RPC, and GraphQL. And the focus for them is quite quite so. Like the REST and GraphQL, you can see that they are focused more on resources, and RPC, they basically describe some functions that you can call instead. So it doesn't need to belong to some specific resource. So it's a bit different approach here. Semantics, yeah, like how do you call it from RPC or even from GraphQL? You do describe your calls in a program. However, in a REST API, you communicate to HTTP endpoint, and that's what you have to describe in your program. Yeah, this is, by the way, my judgment on how coupling is, like loose or tighter in RPC, how resources are coupled to the implementation. So in my opinion, RPC is a bit tighter compared to GraphQL and REST. And I think more cleaner view on that is a format. Like when we talk about REST or GraphQL, we can see actually in Chrome DevTools, for example, that communication is over HTTP in most cases, and therefore it's mostly text-based format. So you can see even in a body of request what exactly you get out of the resource. And in gRPC, it's not the case. You basically have the marshaled message, which is a lot of binary symbols there. So you probably won't understand the message straight away. All right. So yeah, some of the features. So what the gRPC supports, the gRPC. Well, first of all, compared to other alternatives, it defines the types for your communication. In gRPC, you have to describe what endpoint you communicate to and what resources does it support. And how it does it, it is actually based on protocol buffers. So let's quickly look at what protocol buffers are in a second. As I just show, the gRPC itself contains a lot of languages out of the box, so it supports a lot of environments already, including Node.js, but I think originally for Google infrastructure, more important were probably Go or Java or yeah, I don't know, you name it. Yeah, so lots of languages and environments already supported. In fact, even including web, so you have a library that can do a call for gRPC service from web. That's also possible. And maybe also a key point that it's quite extendable protocol. So you can, for example, you can decide to switch from HTTP2 version. I think this is the default for gRPC to what you want, to HTTP1 or even some experimental version of HTTP4 or 5 if you want. So there are lots of extension points, and you can write your own plugin, and then your ecosystem of microservices will switch smoothly to that network communication protocol if needed. Yeah, many things already supported by default, like serialization, the message ordering compared to HTTP, streams. We know Node.js streams, so actually we can easily do streaming over gRPC as well. And more things like authentication or sync-async, which is not always applicable, let's say, in our environment. Let's quickly have a look at what the protocol for your service might look like. So this is a simple hello service. It's actually your real world services might be not much more difficult than this one. So what we see here, we define one service, hello service, and it has 4 methods. So it has a keyword for a method RPC, and then as it's strongly typed, you can see that after the name, it gets the type of request, hello request it is, and what it returns, hello response. And sometimes you can see, like in the second one, there is a stream hello response, that meaning that will return a straight stream. So you have to look at that. Or you can send a stream as well, a client stream here, or you can do both as well. And that's what it is. And after that, you can see the message definition. So the message is what your that data would look like. In this example, it's a really simple one. You have just an object which contains one string property greeting, and one for response reply one. you might be wondering what this one on the right means and what it means. Let's quickly look at the protocol buffers for that. So protocol buffers is also a technology that was built in Google originally, already a bit older than gRPC, like that one exists from 2008. And it also was open source, and right now I think is one of the most popular communication protocols to work on. And the reason why it became so popular is because it's actually quite efficient, and you can use it for fast communication between microservices. So it's supported by many tools. I can mention Kafka, for example. It definitely supports protocol buffers to convert messages and then transfer these messages through the network. And after 2015, obviously they added a services description for gRPC. So what we've seen previously, what we've seen before in this service definition is actually the protocol buffers service definition. So these technologies is basically gRPC is based on protocol buffers definition in here. So in a message person here, we have 4 fields: name 1, int ID 2, some boolean, and repeated values. So this is an array supported here. So the number on the right, it basically means the number of the order in which your fields will appear in a message. So the data format is binary, and because these protocol buffers are known for both client and server, you can spend less resources and less size for your messages. But in this case, to encode your message, you will rely on the order of how these fields are defined, and that's why we need these numbers to be. And that's actually that brings us to the point for the demo. I will quickly switch to my VS Code, and I think I will just quickly show some of the steps that I have here. So I will not show you that much because we don't have no much time left. But you can find, of course, more details in this presentation, for example, later on. So I have here a small package JSON, some project. It actually does 5 steps. It has a few dependencies. First dependency, gRPC.js, then protoloader and Google protobuf. All 3 are quite important libraries in terms of gRPC. So first, we gonna do something simple. We actually download some prices. So let's go to the index.js. In here, I just reach some endpoint and I write it to the prices.json. I'm not sure if that would work or not. Let's just try. npm run, and then 1. Okay, don't have it here, but that's all right. I just want to show you this data. I'm interested to know if that would be executed or not. If not, nothing wrong with that. But we got it. So that's just some JSON data that we got from internet. And then let's see on step 2. This one, let's try to define first the interface for the prices data. So for that, let's open already prepared file for prices data and compare it to the JSON that we receive. As again, on the right, you see the protocol buffer format for the data. And it's very straightforward how it's read, right? Like if we compare the lines here, we have a data type price. And then we have to define a few fields for it, like date. You can see that this is a string, actually. And then some of them are just numbers, price, open and high. So we put the float data type here, as well as change percentage from last month. So again, this is a float. And the last one was a volume. So it's also a string. First, when I was doing this demo, I actually made a mistake and I put a date as a date. I think we have this type of data in protocol buffers as well. But clearly, this is just a string, so we had to switch it back to strings. And then we define a service with three methods like a get from date, and that will return a price, list all the prices, so that will return an array of prices, clear, and here small definition of prices data type, which is an array of price objects, which is clear here. Last one, just to show the streaming capability. So that's our RPC definition, the protocol buffer definition. And then what we can do is to convert this protocol buffer to, the second step is actually we need to build the protocol buffer to this file into something that our server or client will be able to use. For that, we will run a tool called Protoc. This is Protocol Buffer Compiler. It's an official tool by Protocol Buffers. And you can see here it defines some plugins formatters. Like in this case, I need to define the output for JavaScript, in which style I outputted, and which one I take for the input. So this is my prices proton. So that will output the JavaScript library that can be used in our code. And then third step is to show quickly the Protoc.js. So this is when we use the generated file prices PB. Again, I will leave it for you to generate yourself. But to show you how it would look like when you generate it. So after you compiled your protocol buffer file, you have prices data type here, and then you can go through your real data, so through your prices JSON, and convert these objects into the protocol buffers format. Like, okay, I will define a new object, and then I will set some volumes there. Later on, I will just transform it to arrays as well. Serialize and put it to the prices binary. I have a prices binary here, and that's how it looks like. So you still can see that strings, for example, are recognizable, but the numbers are, at least in this encoding, not readable at all. But the more important is that the gRPC libraries will able to recognize it, and actually we can compare quickly the size of these prices binary comparing to JSON, and you can see it's almost four times more efficient stored. And it's a long discussion, but you can see that if you investigate it, you can see that zipping and unzipping wouldn't be necessary in case of prices, in case of binary message sent, and it would be much more efficient to use this encoding instead of zipping and unzipping, both in terms of how small are the messages and how efficient they encoded and decoded. Last two steps really quickly is about to show the server and the client. So the server and the client, that's where we start our microservice and basically start another microservice that will send a message there. So in this case, I will use. You can see that here I don't use the generated file prices PB, and that's because the official library protoloader can actually read the proto format and generate on the runtime the service or the definitions for us. So the same steps that we did upfront, like before starting, we can do on runtime. That's perfectly fine. So we just load this definition, then we have to initialize it, and after that we need to implement our service. So we remember we had this prices proto. And now, if we look here, we have to define these methods, right? Get, list, and list stream. So that's what we have here. With the list, it's really, really easy. With the list, we just return all the prices, and we have this callback communication available for us. Then list stream, in this case, it's Node.js supported stream format. So we write some data and then we end the stream here. And we get, I get some date out of it, I try to find it, and then I return a message back. So 3 methods, like we promised, we define here, and then we start a server. Yeah, that's also very easy. From a library, start a server, we define a service available there, and we just start it on a specific port. We can specify more parameters, like is it secure or not. We can also introduce our certificate if it's needed. And yeah, it just starts after that. And so our client would be very alike. It also it also uses protoloader to do everything on runtime. And then instead of starting a server, because we don't need it, actually, we just first we define a client that will connect to our server, and then we use this client to with these methods, right? Like we execute it not with defining HTTP calls anymore. We just say, yeah, client get or client list or client list stream, and in here I use the sync iterators, so which is very cool. And that makes our the simple microservice there. I think we don't have any time left, if that's correct. But if we have a bit, if we have just a bit, I want to quickly show what else can we do. Maybe 1 more minute is, of course, that's very low-level server, low-level example that I showed, but you can do much more efficient, much more things with it. You can use a Nest.js framework. They support gRPC nicely for you. I have here like a long list of commands that you need to do to start simple gRPC services. But then the idea would be basically the same. You define these services yourself, and then you can do these calls in with a gRPC format. Yeah, I have here a code. Maybe it's worth to just show it like that. So in Nest.js, you attach some specific plugins. You basically define that your gRPC service will run based on this proto, the URL which you want to run your gRPC service. And you can use the predefined methods, of course. And then you, with the decorator usage, you say that, yeah, this is my method of a hero service, which is called find1. And with it, and that's the simple notation for the methods, like return items find, and that will do the same for you. So yeah, I definitely recommend to use this strong tooling like Nest.js when you build your microservices. That makes your code much more cleaner. So feel free to explore these packages and more resources, like official websites of gRPC and protocol buffers. They're all awesome, and I definitely recommend to dive into this technology if something new for you. And that's it. Thanks for watching, and if there are any questions, happy to answer.
Thank you, Alex, for the presentation, for taking the time to educate us. Thank you for delivering it. So we have a Q&A session at the end of the block, according to the agenda.
Yeah. All right.
See you later.
See you.
And next, move to the next presentation, which is by Roberto Bianchi, who was already introduced to us during the panel discussion, senior software engineer from Spendesk. Welcome, Roberto. You have the microphone. Spotlight is on you.
Hi everyone, I'm Roberto and I work for Spendesk, which is a European fintech platform. Specifically, I work for the new public API project, and today we will talk a lot about code quality. So, something about something important about quality is that it's a continuous process. It requires a lot of work to be done regularly. Why? Well, because it's not easy to achieve quality, especially in the fintech space. And this is something extremely important. One of the reasons is that you need to deal with complexity, as we can see on this slide. So every project with time by time will become even more complex. So code bases, tests, software architectures, by time will require more things. And so, as we all know by the law of entropy in the universe, everything tends to disorder if there is no direct action. And so in this sense, you will need to deal with complexity in your code bases. Another key point is security. So again, especially in the fintech platforms, you need to have really high security standards in place. For instance, to be sure that every calls is properly authenticated and authorized. There are no vulnerabilities. Your dependencies are up to date and secure. So a lot of things also that should be done properly on this area. Another important one is communication, because teams cannot rely on communicate directly, or cannot only rely on communicating between different teams regarding changes, but there should be for sure some automation in place to, for instance, document service-to-service communication, definitions of endpoints, and this kind of stuff. Otherwise, if you keep doing that manually, the problem is that it will be probably out of date. People will forget to update things. And so communication will not reflect what is currently happening in the company, but it will be something that is essentially wrong and out of date. And last but not least, something extremely important are tests, because with tests you can keep the quality of your project higher and higher, especially if you keep your code coverage quite high without compromising, of course, the pipeline and the CI/CD. Because, of course, if you write a lot of tests that are checking especially the most important parts of your logic, speed and reliability of your pipeline can be affected by that. So it's also a matter of finding the right tools to write tests that can actually make your code of a higher quality, but without compromising on your pipeline. So since those are not very easy challenge to take, it's important to analyze what it's available in the open source world, because something great about open source is that you can use something that solves maybe an issue that you also have, but you can also contribute, understand, study, and improve existing solutions. And by this community effort, the nice result is that very interesting tools are available on the market that can solve the issues we just mentioned before in order to achieve very high quality in your code bases. One interesting tools that we are currently using in Spendesk is Fastify, which in a few words is a web framework for Node.js. Some of the key pillars about Fastify are that, first of all, it's schema based. So as we will see in the next slide, everything that happens in Fastify has a schema attached to it. So for instance, a new request to an endpoint, well, when you define an endpoint, you will need to define what are the query parameters or headers, body, everything that comes inside the endpoint. You need to define what is the output to this endpoint. And Fastify relies on this concept, which gives you not only up-to-date documentation, like with OpenAPI definitions, but also it improves the security because you know for sure that the input is validated and serialized. Performances are great. You can see there are a lot of benchmarks you can find on the internet about it. And compared to other web frameworks, Fastify is definitely faster, as the name suggests. The plugin system is also another interesting feature of Fastify because it allows you to write isolated and encapsulated part of code that can be fairly easily shared, not only across your company, but they can also be quite easily open sourced. This is also the reason why there is a great community upon Fastify, and we will see more about it later. Testing is also Fastify has very nice features for testing, especially the fact that you can basically check all of your code, but avoiding to run up an actual server in your test, because you can do fake HTTP injection. So you will be able to test your code and the code you write without actually run up a server in your test. And finally, logging. Logging has two great features, since Fastify is based upon another open source tool, which is Pino. And you have a lot of configuration you can write. You can also define some parts completely customized for your logging. And also it's, again, very fast, since logging is used a lot, especially in huge projects and in APIs that are used across the world. It's very important that this is fast, because it happens basically for almost all of your endpoints. Talking about the community for Fastify, and consider that this is not an up-to-date screenshot, the numbers are increasing since when I started to create this presentation. As you can see, it's the number of people contributing to Fastify is growing, and the reason is that Fastify is being created with the concept of being open source and with the extensibility feature in place, because as we said before, thanks to the plugin structure of Fastify, it's very easy to create code that change and customize the Fastify code as you may need. As we said before, also testing is another nice part. You can see here a code snippet where we instantiate a Fastify instance that we store in the app variable. Then we call it asynchronously. And then instead of actually doing a real fetch to a URL, we're calling app.inject. The benefits, as we said before, is that you can check all of your code, so the plugins you load, hooks, decorators, this kind of stuff, avoiding to running a real HTTP server in your test. And when you need to run, for instance, multiple test jobs runner, and you need to listen on different ports, trust me, it's not easy to set up. So thanks to this feature, you can simplify a lot and make your test also faster. Also, the point regarding schema, as we said before, looking at some code example, like in this case, and we will see later what we can generate from the schema. One of the feature about the schema based for Fastify is that you can use different schema validators. Like the default one used by Fastify is AGV, but you can use other one. Like in this example, we are using Zod. Then, as we can see on the schema property, what you define affects the validation and serialization of your endpoints. In this case, we validate that the query string parameters are correct and are actually an object containing an ID and a name as a string, and that the result is actually a number. So in case you send something wrong, basically you will not, TypeScript will complain to you, because you will also have type inference. And so you will not be able to build it. But even though you're not using TypeScript, also Fastify, if you're sent a wrong result, like a result that is not a number but a Boolean, for instance, Fastify will send a schema error to you saying that what you're sending is not what you defined in the schema. This is actually very good because you can be completely, you can trust your code, you can trust also the code of other endpoints written with this schema-based feature in mind, because the endpoints will affect what the schema actually say. And as we said before, this is the result. So on the right side, we can see that we have the definition in the OpenAPI JSON schema, where we have the endpoints we defined with the query parameters, and then also the response. And on the left side, you can see the result of using the Swagger UI plugin for Fastify. The Swagger UI plugin will take the definitions generated from your endpoints and will generate a nice UI interface that will allow also you to actually send requests to your API. Another very nice feature that we talked before is the service-to-service communication. This is not something easy to achieve if you want to automate that and to avoid mistakes and breaking changes, especially when you have multiple APIs that interact between them, even backend to backend, frontend to backend, and many more. And one open source solution that solves this issue is Platformatic. Just to mention very quickly, Platformatic is based upon OpenAPI as a standard and Fastify. It's also type safe, so what you generate can be reflected into TypeScript. And so you will have the benefits of having the TypeScript wheel failing, for instance, if you're doing something wrong. And finally, the auth is easy to set up for your service. So you can define it just in one place, and then all of the people using the client generated by Platformatic will not need to define the authentication because it will be already in place. Let's see how it works. So first of all, you need to generate a client. So imagine that the client.json is what we have seen before. So the output of some endpoints generated in a Fastify application. As we said before, Fastify does that for us. So what we can do is that we can take this OpenAPI definition and run the client CLI from Platformatic upon it. The results will be that we will have a type definition for our endpoints. So basically, it's like the generation of TypeScript from an OpenAPI schema. An idea that is extremely simple but effective, because as you can see, we will have everything. So the kind of response that we expect, the inputs, and everything you need to be set up to call your clients in a safe way, and also with types from TypeScript. And now, since we generated the client and the client types, we can actually call it. And to call it, we call a slightly different module, which is client. So previously you used the CLI client. Now we are using the client. By using the client, what we need to define? Well, of course, the URL of our API and the path to the JSON schema, because the JSON schema, as we remember again, is like the source of truth for our API. We can define an OpenAPI definition, but even a GraphQL one if we want. Here we have the name that we need to use later when we call the client. Some additional options, and something extremely interesting, which is the getHeaders function. With the getHeaders function, basically, you can generate, calculate, and then add some headers that are for your authorization. Like in this example, where we are logging something, then we generate the headers starting from some options, and the options are that we receive from Platformatic client can be everything like the URL that we are calling, the body, the additional headers, query parameters, everything that you will call in a second. And then, so what we do is that we have this this function that, of course, here we don't have the source code because we don't care, but it's like getting those options that we are gonna call and generating an authorization on that. For instance, a signature that you wanna send. Then every time that you will call this client, those headers will be already set up. So you need to do that just once and just in one place. And then the client has also other options. For instance, a new one is to parse query parameters if you need. So yeah, it's highly customizable. Then as we can see, we call the request, which is the Fastify request, .client, which is the name we defined for the Platformatic client, .get, which is the endpoint that we have, and it's a get endpoint. And then we need to pass the right parameters. So here, if we miss something, so we don't pass the name, TypeScript will complain. If we pass a number instead of a string, if we pass a number instead of a string, it will complain again. So we will have type safety here. And then we have the result, and the result will be of the right type. So in this case, will be a number because we defined it initially in our OpenAPI definition. And now let's talk about tests, because tests are an extremely important part if you want to create a successful product that you want to improve time by time, you want to add features and this kind of stuff without breaking existing stuff. So it's extremely important that you have tests in place. Otherwise, if you need to do a refactor, if you need to add an important features, how can you be completely sure that you will not break existing code? Tests are a fundamental piece for engineering products. And it's important that you choose the right test runner, because if you use the wrong one, you can have a lot of troubles. The first one is performances, because of course, especially if you have a repo with a lot of code and a lot of tests, performances are extremely important. Otherwise, all of the developers in the company will need to wait a lot of time for their tests to run in the pipeline, which is not a very good developer experience. And also you are waiting and you're wasting money, because every minute and every hour that the developer waits is an hour that maybe can be used to work on something cool. Instead, the developer needs to wait for the test to be run. Another nice feature of Node.js is that the way it mocks things is that you mock things specifically. There are no global overrides like in other frameworks. And finally, it's included in the core of Node.js. So you will not need to install and maintain and look for security vulnerabilities of external dependency. But as soon as you have a Node.js project, well, you don't need to install anything else. You can just use the Node.js test runner. And here we have an example of the test code. As you can see, there are fairly slight differences in the syntax, like we need to import, especially if you're using TypeScript, you need to import the right functions from Node. So here we can see an example in Jest, and here with Node.js test runner. But overall, as you can see, the syntax is fairly similar. And those are the results. And especially for lots of files, as you can see on the last example, so we're talking about 10,000 tests, the difference is huge. So it's more than a 10x improvement. This is something you need to consider, especially, as we said before, if you have a lot of tests in place. This is another example made on a more complex setup, where we had in our case and in our company, we had this repository with integration tests, so tests that are checking things also on the database. We had service tests, so tests doing real HTTP calls that are checking that the HTTP endpoints are returning proper things, mocks of internal library. So a more complex setup. And again, as you can see, the difference is extremely important, because we're going from around 100 milliseconds to 20 milliseconds per test. If you multiply that to a lot of numbers, this change is huge. So in this specific case, we went from 6 seconds to 1 second, but you need to understand that this was a fairly small repository. Of course, if you have way more tests, the difference can be huge. Also about memory consumption and heap profiling. So we wanted to double check what was the memory consumption in an existing code base with existing tests. The setup for these specific repositories was using Jest and SWC. And we've seen that the memory consumption was around 1.5 gigabytes. By using the Node test runner, running directly the test in TypeScript, we went down to 200 megabytes, and in this case using TS Node. And then we also tried the TSX executable for TypeScript, and we ran directly the test using TSX, and we arrived to 40 kilobytes. So that's a huge improvement that we find by just switching the test runner. So we're not doing anything else. We just switched the test runner and the way to write mocks, and this was the result, which is amazing, I would say. So to recap, we've seen 4 different pillars that together generate a strong quality in your code base and are extremely important to keep in mind while you write code. The first one is security. So in order to have security in place, you can rely on tools like Fastify that are schema based. So you base everything on a schema that is validated and serialized for both what you receive and what you send back to the user. And then on other tools like Platformatic Client that can allow you to define in just one place the headers, the authorization headers that you need to pass between service. So once you have service-to-service communication or front-end to service, and maybe the front-end needs to send a JWT or the back-end to back-end needs to send a signature header, well, you can define that very easily in a Platformatic client, and that every time you will use this client, you will not need to take care about security, but it will be already set it up. Then complexity, as we have said initially, it's normal, as we see in the universe, that disorder tends to grow over time. So if you do nothing about it, after some time you will have a lot of disorder also in your tech projects. How you can deal with that? Well, as we said, you can automate service-to-service communication, and you can do that also in a type-safe environment. And you can leverage tools like the Platformatic client CLI to automatically create types from your OpenAPI definition. Third point, communication. So you cannot rely just on people communicating to each other. You need some standards for doing that. And you can leverage OpenAPI, which is a standard to define API endpoints. And you can auto-generate OpenAPI by just using Fastify and other plugins like the Swagger UI plugins. Additionally, you can be immediately aware of the updates between services because, for instance, you can have a command that generates a client CLI, and then by default, if something is wrong, your TypeScript build will complain because the generated types associated with the OpenAPI definition and TypeScript will complain about a change that is breaking the contract. Finally, test. Test is extremely important to keep quality high in your project. So you need to find the right tool. And in our case, we successfully used and we are currently using in different projects Node.js and the Node.js test runner. So in a few words, consider to reduce the time to execute a single test, because if you multiply that by all of the tests you need to write also in the future, this will be a huge improvement. And to rely on something that Instead of other frameworks like Jest that does some monkey patching and global mocks override for Node.js, rely on something that gives to you the decision to define what to mock and when. So Node.js Test Runner is definitely a nice tool to check it out. Thank you for this talk, and feel free to connect with me. I'm using a bit more LinkedIn, and yeah, of course, GitHub. On GitHub you can see my projects, my open source contributions. Also, there's some small repositories I created, and yeah, feel free to check it out. Also, if you have more questions, if you want to discuss the things we have seen today, feel free to drop me a message. And thank you. See you there.
Thank you, Roberto, for your talk, for delivering to us. And let's proceed with the next one, which is by Liz Parodi, who is head developer advocate at RunMe. She will tell us about using TypeScript without TypeScript. Really intriguing topic. So welcome to the stage, Liz.
Hello everyone, my name is Liz Parodi and I'm head developer advocate at RunMe, a very cool company that focuses on building infrastructure automation with Markdown. Go and check it out, and trust me, you'll thank me later. This is the agenda for today. First, we're going to talk a little bit about TypeScript history. Then we're going to check what are types and why do we need them. Then types and modeling, then testing and safety, JavaScript and TypeScript, the difference between them, and TypeScript benefits and drawbacks. Finally, we're going to do a demo showing how we can use TypeScript without TypeScript, and finally, a conclusion. Let's talk a little bit about TypeScript history. According to Stack Developer Survey 2023, TypeScript is the third most loved language, and it has been for a few years already. TypeScript is a popular and trending language. It's also the fifth most used language. In JavaScript, there is various static code checkers that have emerged over the years, each catering to different needs and preferences within the developer community. The first one is JSLint in 2002. Douglas Clutford pioneered static code analysis in JavaScript with the introduction of JSLint in 2002. It focuses on enhancing code quality, and JSLint enforces stringent coding conventions to promote a disciplined approach to coding standards. Then it came Google Closure Compiler in 2010, where primarily recognized as a minification and optimization tool. Google Closure Compiler, introduced in 2010, also incorporates statistical analysis during the compilation process. Through unconventional as linter, it aids in error detection and provides warning, contributing to improved code quality. It's important to note that now is deprecated. In 2011 was introduced Jest, building upon the foundation laid by JSLint and as a more flexible and configurable alternative, while maintaining the essence of statistic code analysis. Jest provides developers with greater control over its rules, offering a less opinionated approach compared to its predecessor. Despite its capabilities, Jest doesn't have a widespread popularity in the developer community. Then it came TypeScript in 2012. TypeScript entered in the scene, revolutionizing the JavaScript development. While it's not a traditional static code checker, TypeScript introduced static typing, allowing developers to catch and prevent type-related errors during the development process. Its adoption has grown steadily, providing a robust foundation for large-scale applications. Then, in 2013, was introduced ESLint, and it quickly became a frontrunner in the static code analysis landscape. It appeals last in its high configurability, extensive plugin support, and a comprehensive rule set that facilitates the identification and resolution of common coding issues. With over 20 million weekly downloads on NPM, ESLint has emerged as one of the most popular and powerful tools in the JavaScript ecosystem. Flow was introduced in 2014 by Facebook and is a static type checker for JavaScript. Flow empowers developers by enabling the addition of statistic type annotations, offering a proactive approach to detecting and preventing type-related errors during the development phase. So each of these tools has played a significant role in the shaping of JavaScript development landscape, offering developers a spectrum of choice based on preferences, project requirements, and code philosophies. So, what are types and why do we need them? Basically, to tell the computer how to read and write data. Types are fundamental in programming, guiding how computers interpret and manipulate data. They categorize data, specifying the values and variables can hold, and allowable operations. Types enhance code productivity and safety. In every programming language, types are crucial for effectively managing data in memory. Types refer to the classification of data into different categories, specifying the kind of values a variable can hold and the operations that can be performed on those values. The main purpose of using types is to add a layer of productivity and safety to the code. In statistically typed language like TypeScript, developers must explicitly declare variable types, providing clear documentation and catching issues at compile time. In the contrary, in weakly typed language like JavaScript, types are deduced dynamically during runtime, and this is a design choice instead of a problem. It offers flexibility, but potentially leading to errors. In TypeScript, explicit typing promotes code reliability, aids on early error detection, and ensures robust development practices. While it might seem more verbose, the benefits in maintainability and reliability become evident. So, why do we want explicit types? There are several reasons why types are crucial in programming. The first one is to avoid unexpected results. Explicit types prevent unexpected behaviors, such as summing a number and a string in JavaScript, which can lead to unwanted results. Specifying types helps ensure the desired outcome of operations, because summing the number 1 and the string 2 is the string 12, so this is not desirable. The second one is object structure clarity, because we want to see what's inside objects. When dealing with objects, explicit types provides insight into the properties and structure. This is especially important when working with events or core library components like the event emitter in Node, because we want to know what are the properties of the event, and also we don't want our object to change the structure on the runtime, or even worse, our variables to change types at runtime, because JavaScript allows to do that. So having explicit types helps to prevent runtime changes and object structure of variable types, enhancing code stability. The third one is function signature understanding. Explicit types allow developers to understand function signatures without referring to external documentation or going all the way to the source code if there is no documentation. This enhances code readability and promotes a clearer understanding of the code base. The number 4 is to catch errors early, of course. Types enable the early detection of type-related errors by compilers or interpreters before the code is executed. This approach helps to catch issues during development, minimizing runtime errors. The fifth one is to improve code quality, because types act as documentation within the code, making it self-explanatory and easier to understand. This documentation enhances code quality by providing clarity on variable usage, function expectations, and data structure. Number 6, enhance code understanding. Type information serves as the documentation for developers and development tools. It helps developers to understand the intended use of variables, functions, and objects. Integrated development environments, or IDEs, leverage type information for better code suggestions, auto-completions, and error highlighting, improving code understanding. Number 7 is refactoring confidence. With a well-defined type system, developers can confidently refactor code, knowing that changes align with the expected types. This increases confidence in maintaining and evolving the codebase. The next one is tooling and development support. Types enable the use of powerful development tools such as static analyzers, linters, and IDEs. These tools catch potential issues, suggest improvements, and offer intelligent code completion, contributing to a more efficient development process. The next one is collaboration facilitation. Types provide a common language for communication among team members. It ensures that everyone understands the expected input and output of functions and the structure of data. In summary, explicit types plays an important role in creating a robust, readable, and maintainable code. They contribute to software quality by catching errors early, enhancing development tooling, and facilitating effective collaboration among developers. Types and modeling. Types are also used with modeling. They allow you to define and represent structured data, such as objects, array, and custom data types. This structured representation helps organize and model complex data structures in a clear and understandable way. In the following example, you have the person with the properties like ID, name, address, birth, and they're all strings. But even though they're all strings, they all have different values and formats. But doing this with types is not recommended. The most effective way is to do an input validation. Input validation is a good practice to ensure the data quality, data integrity, and reduce the possibility of attacks like DOS and injection. Without the validation, we might get the correct type but still wrong values. Think of input validations as your application vigilant bouncer. Not only does it ensure that the data comes with the right types, but it also kicks out the troublemaking values at the door, whether it's user input on the front end or API entry points or function parameters in your libraries. Now let's talk a little bit about testing. Of course, we need a test. Testing is a critical aspect of software development, ensuring the reliability and correctness of code. In dynamically typed language like JavaScript, where types are determined at runtime, testing becomes even more crucial to catch potential issues that might arise due to the inflexibility of data types. As we see in the famous test trophy, the statistics testing is introduced as the foundation of all the testing activities. This level covers the use of statistic tools like linters to catch problems like typos and statistical errors, but we still need all the other testing layers in order to get a robust application. The testing trophy approach assigns the most important to integration testing. The reason is that you generally need fewer integration tests to identify problems in the application, and they're not as dependent on the details of the implementation, yet can be written and run relatively fast. Also, unit tests need to be maintained and adapt as the implementation changes. Integration tests, however, require less effort as development evolves. Unit testing allows us to validate the correct functionality of the individual components, the smallest building blocks, within our application. On the other hand, integration testing enables us to assess the cohesion and interaction of various components, including the business logic. Moreover, by conducting feature tests, we can ensure the comprehensive validation of our application functionalities. The test suite operates not only on statistic code, but also on the running application, making it adept at identifying issues. Additionally, it aids in pinpointing potential gaps in type declarations, contributing to a more robust and reliable code base. In the development community, TypeScript is often celebrated for its association with safety. Remember, safety first. However, it's essential to understand that type checking primarily tackles issues at the surface level. It's like to wear a helmet while engaging in a high-impact sport. Safeguarding against head injuries might not necessarily prevent every conceivable risk. When constructing an application, my concern extends beyond just mere type errors. I worry about security vulnerabilities, scalability challenges, and potential mistakes in critical areas like business logic, especially when handling sensitive user data. While type errors offer valuable layers of protection, addressing the broader spectrum of concerns require a comprehensive approach to ensure the overall robustness and reliability of the application. And also, let's take into account that TypeScript is not JavaScript plus types. It's a very common assumption that TypeScript is just like JavaScript, but with types, and that's not entirely true. That assertion oversimplifies the profound distinction and unique characteristic that TypeScript brings to the table. It's crucial to dispel the misconception that TypeScript is just a superficial layer at type annotations up top of JavaScript. Instead, TypeScript is a distinct language that extends and enhances JavaScript, introducing features that significantly impact the development experience. TypeScript introduces statistic typing, type annotation, advanced ECMAScript features. It also supports interface for abstraction, compiles to JavaScript, and offers robust tooling with IDE support. Its incremental adoption allows for seamless integration with existing JavaScript projects. TypeScript stands as a versatile language with its own feature and ecosystem, providing developers with improved predictability and robustness in the code. Now let's talk about the main TypeScript benefits. The first one is preventing runtime type errors. TypeScript's expressive syntax and static type checking enables developers to identify and address type errors before runtime, preventing issues like accessing properties of undefined or calling functions of incompatible types, eliminating annoying errors like undefined is not a function, cannot read X or undefined, and others. The second one is incremental adoption for reduced cognitive load. Developers can gradually introduce TypeScript to existing projects, enjoying the benefits of static typing without the need for a complete rewrite. It is still JavaScript? Of course, TypeScript is a superset of JavaScript, allowing developers to seamlessly incorporate existing JavaScript code into TypeScript projects. This backward compatibility ensures a smooth transition and flexibility in adopting TypeScript in projects already built with JavaScript. The fourth one is modern ECMAScript features. TypeScript supports the latest ECMAScript features, allowing developers to leverage modern JavaScript capabilities. The last one is robust tooling. TypeScript statistic typing is complemented by powerful tooling, offering advanced intelligence, auto-completion, and error checkings in IDE. IDEs can do error highlighting and auto-completion, as we can see in this following image, which it auto-completes itself. Some TypeScript drawbacks include required compilation. One argument against TypeScript is that it requires compilation while JavaScript doesn't. But let's be honest, most of JavaScript applications these days require build step, like Webpack, Babel, or Closure. A build step is necessary and nothing really prevents you from expanding it. Another disadvantage of TypeScript is that it brings you a false sense of security. Yes, it's a huge benefit that the language can check types for us and warn us when there is something wrong with our code. However, relying on this too heavily comes with a significant risk. Some developers tend to think that anything they write on TypeScript is 100% bulletproof, but it's not. TypeScript performs type checks only during compilation. Afterwards, we're dealing with pure JavaScript that doesn't do that. This means we may still encounter some bugs that the compiler didn't find. But to be honest, there is going to be far fewer of them than if we hadn't used TypeScript. Another drawback is compatibility with dynamic libraries. TypeScript static typing might pose challenges when integrated with JavaScript libraries that heavily rely on dynamic parameters. Ensuring compatibility with such libraries might require additional effort or workarounds. The next one is tooling integration. While TypeScript has a strong tooling support, integrating with certain tools like IDEs or continuous integration systems might require additional configuration. This overhead can be concerned for developers seeking a more straightforward setup. And finally, there are many forms of TypeScript. TypeScript offers a variety of compiler options that can influence the behavior of the language. Depending on these options, the TypeScript compiler can enforce or relax certain type checking rules, leading to different behaviors in terms of type safety and error handling. For example, compiler options like strict null checks, and strict function types can impact how TypeScript handles nulls and undefined values. When developers work on different projects with distinct TypeScript configurations, it can indeed lead to varying levels of strictness in type checking. So how we can get all the benefits of TypeScript and reduce the cost on the drawbacks? One excellent option is JSDoc. JSDoc annotations in TypeScript provide a flexible way to introduce type information incrementally, making it easier to adopt TypeScript features gradually. They can reduce verbosity, offer compatibility with dynamic patterns, integrate with existing projects, and provide configurability. While not a full replacement for TypeScript static typing, JSDoc annotations offer a balance between type checking and flexibility in certain scenarios. JSDocs help us with type checking, sign functions, define types, achieve IDE support, and it has no JS feature loss. So let's see in action. Now I am on a readme.md file and I'm going to use runme to run all our commands. First, I'm going to click here to run npm init, which will initialize our project. Then I will install JSDoc running this, and it will install everything I need for my project. Perfect. Then I will create the file tsconfig.json, and I will do this. The compiler options would be, it will allow JavaScript. This is true. Then it's going strict mode. It's going to be true as well. It will have check JS, true. Declaration, and the declaration directory will be types. Then I will include everything, all the JavaScript files, and I will exclude the Node modules, of course. So with this ready, I will go to my package.json, and we only have to write 2 lines of code. The first one is check tsc no emit true. What this does is that I can check the code without producing the transpile code. And the other line of code is just export. That will be tsc emit declaration only true, and no emit error. What this does is we want to export the types, but we don't want to do it if there isn't any errors in it. So this is ready. And finally, we'll create the main.js file. First, we'll use strict. And I will create a function called main. And let's say I want to create a very basic application to subscribe a new user to a newsletter. So first, I will create a constant name, which will be process.arg. We'll get it from the arguments, and the same with the email. Process.arg. And I'm going to check my types. So this will be strings, so I will be type string, and will be the same for this one. Then I'm going to create a function to subscribe the user, but we have to define the user first. So here it would be the user. Now let's define the user. So it would be type def user, and one property, it will be the email is going to be string, and another property is also a string, which is the name. Now I will use my subscribe function here with the email and name. Now, if I say that the name is equal to 1, it will show me that the number is not assignable to the type of string because it's expecting a string. So our TypeScript is already working. Now let's save this to storage. And we send the welcome email function to an user.email. Now I will have to create my send welcome email function. Which will have the email, and we just print it to the console. Email send to email. But because it's TypeScript, we need to specify what the type of the email is. So we say that the email is a string. Now, if we go here, we can get the constant user with the name and email. Now, if we go here and we delete the email, we can see that it has autocompletion, email, or name. But in this case, it will be email. Autocompletion, awesome. But let's say we want to return a Boolean. Return Boolean. And I will have here return true. And I forgot to call my main function here. So let's test this. If I do npm run check, it will run all the checks and there's no issues, which is great. And for example, if instead of returning a Boolean, it returns 1, we can still run the checks. Finally, if I do node main list and then my email, I said email sent to list@email.com. So this is how it works. So with this approach, we get type checking only using type annotation with JSDoc. No TypeScript required. I hope you enjoyed this talk and start experimenting with JSDoc. This is my Twitter in case you have any questions or want to chat, and make sure to check out runme.dev. Enjoy the rest of the conference. Thanks!
Thank you, Liz, for this talk. It was pretty good, really insightful for us. And let's dive right into the Q&A session. We have Roberto and Alex with us. Hi.
Hi. Hello.
Hi. Hello. So let's start with the first question for Roberto. Which of the presented open source projects is the easiest to contribute with new code and ideas?
Yeah, for sure, I would say I would suggest to start with a project that is a bit easier to understand. And so, for instance, we discussed about, during my presentation, we discussed about Node.js, Fastify, and Platformatic. For sure, the latest one, which is also newest, it's easier to contribute, especially with new ideas about it, because it's like an abstraction, a code abstraction over Fastify plus other open source libraries like Pino. Also, the fact that it's new allows to more easily contribute to the code, because of course the community around it's eager to see new contributions. Other projects like Node.js are of course more complex due to the lots of files in the code base, and also the setup that is harder. Then you need to know C++, internal low-level libraries like libuv or the V8 engine, so it's not easy. So I would suggest Platformatic, and it will also allow you to better understand how Fastify works under the hood. And maybe lately, when you have a clear picture about Fastify, you can also start to contribute to the Fastify repo.
Great. Thanks for answering. And I guess Alex is joining us soon. Next question is also for you, I guess. Does it only work for Node.js/Platformatic, run on other JavaScript runtimes like Bun or Dino?
I have an article that I can maybe share in the chat about it, because as I said before, Platformatic is highly based upon Fastify. And right now, for instance, as of my latest knowledge, Fastify is not supported by Bun. So of course there is the need before to support Bun. Regarding Dino, I'm not completely sure. It should support Fastify, but yeah, overall, I would maybe suggest to directly open an issue in the Platformatic open source repo and maybe ask directly to that. Or even later, there will be Matteo Collina on stage, and since it's the maintainer of the Platformatic repo, you can also try to ask directly to him. Meanwhile, maybe I can share the link about the article from Matteo Collina about the topic in the chat.
Great. It would be nice. Thank you. And another question for you. There will be a tool to convert Jest test to Node test runner. I think that many companies will complain about wasting time to the mitigation process.
Yeah, that's a very good question indeed, because also in Spendesk we have a similar issue, because we wanted to convert some repositories from Jest to the new Node test runner. So what we started to develop internally, it's a code mod tool that will help us to do a refactor and to migrate the code from one library to Node. And it's not completely ready yet, but probably we can think about to make it open source in the future, so that also other people can benefit from it. And of course, it will work for, I would say, 80 to 90% of the code. For more complex setup, especially regarding mock external libraries, you will still need to do some manual work, but at least it will help you with a lot of repetitive tasks to do. So yeah, that's also a very nice feedback indeed. So we will maybe think about make it open source when it will be ready.
Great. Thanks for answering. And we have one question for Alex. He cannot adjust the camera, but maybe the audio is good. Alex?
Yeah. Hey guys. Yeah. Hopefully I'm audible.
Great. Yeah, it works. Great. So how does gRPC support authentication and authorization, and what are the recommended practices?
Great question. Yeah, it has a full support for it. I think the easiest option that is mentioned in their docs a lot is you can use your organization certificates for microservices. So you can make a chain of certificates, so they will be checked automatically out of the box for you. Beside that, I think for authorization, you don't have that much out of the box, but maybe you can use some of the third-party tools, like I would say Open Policy Agent is a great tool to use. One of those is used by Kubernetes, for example, and it's a lot of configurations you can add there. So yeah, it should be very easy to add one.
Great, thanks for answering. And also another question for Alex. It consists of two parts. So the first one, there are a lot of challenges when we want to test gRPC services in Node.js. Some of them are due to company, a complexity of remote calls, buffers, serialization, async nature of Node. So the question would be how you monitor and analyze the performance of gRPC services in prod. What did you use and how can we optimize them?
Oh wow, that's an interesting, detailed question. Yeah, I would I would recommend just the same tooling as you always can have for your microservices. So yeah, any of the elk stack that your organization is already using, yeah, it's perfectly fine, and open telemetry for details on tracing. That yeah, but basically it's all external tools, so you don't have much out of the box, but it's I think nothing stops you from using well-known tools that the organization already adopted.
Great. Great, thanks for answering, and thank you both for joining the Q&A session, bringing us more clarity to the aspects you shared during your presentations. It was a pleasure to cooperate with you both, and I think we can start the break. Thank you.
Thank you. See you.
Thank you.
Bye.
See you. Bye-bye.
Bye-bye. Thank you. So we will be back in the stream in 20 minutes with next block of presentations. And let's start the next block of Global Summit for Node.js 24 with well-known speaker recognized within our community, Matteo Collina, who is CTO at Platformatic. He will tell us how he combined Node test with TypeScript. Welcome to the stage, Matteo.
Hi everyone, I'm Matteo Collina, Platformatic co-founder and CTO. And today we are going to talk about how I combined Node tests with TypeScript. So let's see. So before we start, who I am I'm Matteo Collina, part of the Node.js Technical Steering Committee, and also a board member of the OpenJS Foundation. However, all of these are my opinion and my own, as the lawyers will say. I'm also part. I have also created two libraries called Fastify and Pino, and there's many others that are all available on npm. This is probably more very famous, so you probably are using them or heard about them. And I have a past as a consultant. Then I decided to do my startup, but we'll talk a little bit about that later. And you can subscribe to my newsletter at nodeland.dev. So I gathered a lot of downloads on npm over the years. I've been part of this community since the very early days, and in fact, I have very close to 5 million downloads per week or something like that, and these accumulated to 22 billion downloads in 2024, which in 2023, which is essentially an impressive amount. Okay. And it's unbelievable. So it's totally unbelievable. So you all are using my software, so I'm very grateful. But I have a confession to make, and it's that before 2022, I never used TypeScript, and I stayed away from it big time. So, and now I'm doing talks about TypeScript. So what happened? Well, in 2022, I decided to, with my co-founder, to do a startup. And the problem that we were focusing on is backend development and how the time of backend developers is spent, and how much time is spent on valuable features versus the platform infrastructure that they need to get set up. So reality is that you need to do API clients, boilerplate update, local development, monitoring, documentation, log out, authentication, and so on and so forth. Is actually a lot. So we try to simplify all of that and provide easy to go solutions that are developer friendly. In fact, Platformatic is a set of tools that allows you to move from A to B very quickly, essentially get your product shipped. But the way it does, it allows you to essentially have a very, very fast, high-speed train to get to some intermediate point that will get you, I don't know, a lot of 80% of what you need to do. And then after you got with your 80%, we give you a nice electric SUV to go for the last few miles, which is also very fast. So anyway, without further ado, why does it matter for TypeScript and tests? Well, because it's a DevTools company, and if you're doing DevTools and not doing TypeScript, well, you're doing it wrong. So I got to learn and start doing TypeScript, and then a problem emerged. And the fact that, when Node.js shipped the Node test framework, I wanted to use it, and I wanted people using Platformatic to use Node test to test their applications. But there was a problem, how to integrate it with TypeScript. So we'll talk a little bit about that later and the challenges that I have. But let's talk a little bit about Node test. What is Node test first? So Node tests is a new test framework for Node.js that shipped last year or the year before, and it's stable now. It's really great. It supports both synchronous and asynchronous tests, but the asynchronous test does not support callbacks. It only supports promises. It's great. We also have our own assertion library called Node Assert. I think it's really nice to work with this because it's really, really fast, especially with JavaScript. It's with JavaScript is as snippy as you can imagine. You just take just a few milliseconds to run your tests. Great, we love it. Now, what's the problem though? Okay, or where are we? Well, we'll talk a little bit about the TypeScript problem in a moment, but you can use your tests, you can have nice assertions, nice output, multiple stuff. You can run your tests one at a time, which it's great. And you can see that you can specify only in the test, and then you need to use the node -- only in the command line to match. So, and to tell the node to actually look for that option. If you want to run a suite of tests, not just one file, you can use the node -- test flag. It's phenomenal, but especially on Node 18 or Node 20, it's the patterns that you look for are not that great. So we'll talk a little bit about that in the next couple of slides. But it looks for a test folder, for example, or a file called test.js, and it runs them. And in fact, Node.js as a test runner is phenomenal. Let's recap. So if you do node test, you can use all node options to debug your program, including, for example, -- inspect. I love this. Like, this is phenomenal. I don't need to configure various hard options to have my tests run with the inspector. Wow. I can also do inspect break. So I could actually break my tests, break at the beginning of the execution of my node process before even the test framework is loaded, so I can debug all the things and I can investigate what's happening. I can use node debug, I can use debug, I can pass anything environment variables that I want, because it's just node. It's just I don't have a wrapper command to do it. It just works. I can also use profilers. Okay, so if I want to profile my software, I can actually do that. This is really important. All of this is really important for the individual test file, so that I don't need to have any what you see is what you get type of thing. What you code is what you run. Okay, and this was great for JavaScript files. Okay, so again, the problem, keep it in your hair. What do we do with TypeScript? So in fact, there's the node -- test that runs all the test file according to a predetermined glob pattern in the file system in parallel. Wow. And if you test, we talked about test only, and we need to talk about test concurrency, which limits the number of parallel tests. Why you want to set it to 1, for example? Because if you're talking to a database or another system that has state, you don't want your tests to conflict with each other. However, that will slow down your tests significantly. So be careful. Also, there is watch mode, so you can actually reload your tests when it changes. Lots of people like this. I don't use it, but a lot of people really like this feature. In Node 21, so it will be in 22, you will also get the glob pattern support. Wow, finally, okay. We can also use node test to create test suites, so you can use the scribe to create a test suite, and then you can still call test to in turn inside the suite to do the things. Loving it. It's pretty cool, right? And you can see that running this thing on my laptop, it takes, I don't know, 5 milliseconds overall. Okay, it's pretty neat, I would say. Well, you need to add the time that it takes to start Node and whatever, but it's pretty neat. Okay, so you can also do the same kind of thing with using subtests. So, and that generate the same output, but this allows you to use a weight, for example. And in this way, you can even align them with some other commands inside the suite. Useful. I've used this in the past when there was state between the tests. There is the phenomenal thing, which is called reporters, which allows you to change the output. Very easily, you can use the reporter tab, dot, or any node modules that implement the same pattern. We love it. We use it. We have support for mocks, and mocks are great. Don't rely on them too much, but they can help you test certain kind of error conditions or certain conditions that are harder to reproduce. So you can create your mocks. Note that the mocks are attached to the text context. What is the text context? Is the parameter of the test function, the test callback that you have passed in, and so that the mocks are reset after they finish. It's a very good pattern, and it's provided as in the system. You can also use the same pattern to mock timers. Now, mocking timers is hard. And yeah, we support it. It's done. It's there. Great. And we also have embedded code coverage in the system. It's still experimental for various reasons, whatever. And I personally still use C8, but this is available. Okay, C8 is another test, is another code coverage analysis, and so on and so forth. And I actually prefer it, but right now, at least. But the real magic happens with the run function from Node test. Run function takes an array, a group of files, and you can use it returns a stream, which you can use to call to compose with the reporters and pipe to the output. Wow. How does it work with all the things? So you take your reporter, which is tap and spec, for example, and then you take the run function from Node test, and then you get glob, which is a module on npm that we need to use. And if it's is TTY, if it's a TTY, which is if there's a human, we use the spec. If not, we use tap as an output, and we compute our globs, and then yay, pretty cool, right? But how do we use it with TypeScript? Does it work with TypeScript? Well, let's try. Let's do a few tries. So first, well, no, it doesn't. Well, not necessarily true. If you're running one file, it does work out of the box because you can do node -- import tsx, for example, and the single file will run. Why? Because we load tsx, and then the default pattern, we don't do any globbing, so we just run the file, and with tsx register as a loader, we can run them. These are still super fast. Like tsx is blazing fast, and therefore everything is fast. However, if we try to run the -- test flag, which means the suite, we get nothing. Absolutely frigging nothing. So, ouch. Well, if we use a Node 21 plus, we can use the glob pattern to tweak it. Maybe it will improve in the future. Right now, not good. And if you need to support the old versions of Node, you are a little bit stuck. Okay. But, well, actually, it is possible. Okay. And in fact, you could, for example, set configure a loader, for example, TS Node. And if you use TS Node, which runs the full TypeScript compilation and so on and so forth, it's great. It can detect problems. You can load, you can set it to Node options, and then run your program. You run your test suite with your globbing for .ts. Now, this is great because, so what this does is alter the current process Node options. But because the environment variables are inherited to children, we are essentially, those will be passed through the child tests. And therefore, you will get the loader set up. And in fact, all of that works perfectly. However, it's slow. Why it's slow? Well, because there is the main process running, and you have each one of the test files is run as its own child process. And each one of them has its own loader. And each one of those loaders run TS Node. And it needs to compile the TypeScript, do all the things. So it's very slow. Okay. This approach is an approach that, unfortunately, it does not scale. So what do we do? Well, one option could be to use TSX but these will skip type checking because TSX only uses ESBuild. So is it something that we want or not? This is, to be honest, part of your development workflow. So who am I to say? Okay. I generically prefer to have my tests type checked before running them, right? I don't know. This is what I would do. If I use TypeScript, I want type checking. So anyway, however, what we can do is, the question is, do we need a loader at all? Well, we don't. Okay, what we could do, we could run the TSC, the compilation in the main process, and then just spawn one targeting the the JavaScript files. So it's fantastic. Also, because TypeScript can have incremental mode on, so we could actually recompile it faster in case of larger things system. Now, going back to our system, to our tool, I have written a tool to set it up for you, which is called Borp, which is a test runner on top of Node test. So how does it work? Well, you can just use npm install it, and then you can run it with -- coverage, for example, to have the coverage set up and integrated. And in fact, Borp just use TSC, okay? And it provides full type checking before running your tests, okay? And look, I love this this meme because it's we said we'd introduce this faster, and everybody said write it in Rust, write it in Vig, and the person that's used basic caching or skipping was thrown away. And this system is actually what it does. Okay, it said, you know, we are just running the JavaScript files. Okay, we are not running the TypeScripts anymore, so it's great. So yes, so to recap, Borp do automatic TS detection and compilation using TSC, run TS test directly, so you don't need to worry. It supports globbing and coverage, and multiple reporters out of the box. Also, it has, you know, I tend to recommend this kind of directory structure for TypeScript. I will talk a little bit about that in a second, but this allows this allows a nice symmetry between your SRC and dist, so you have actually good resolution for all the other files in the main directory. So, bonus tools. I thought I would talk about Node tests. Bonus tools. The first one is an utility called TSPL. TSPL stands for test plan, and its test planning is very important, especially if you're testing any kind of events-based system. So you want to verify that a function was called or an event was triggered. It's very important. It's not part of Node test yet, and therefore I had created this utility to do it. I use it all the time, so you can you can too. Okay. Also, I also created this utility called Snap. Snap is a tool that lets you do snapshot testing, and it just works. It's you pass in the object, and if it's not there, it stores the snapshot. If not, it returns the actual thing, and that's it. Last but not least, there are a full set of reporters that are available from Moshe, Molo, or Molo on GitHub. Molo is part of the Node.js TSC and one of the maintainers of the test runner, and he created a huge set of reporters. My favorite one is called @reporters/GitHub, and basically, when you run your code on GitHub Actions, you get inlined, you get the errors inlined in the code when you are actually reviewing the PR. This is unbelievably good. Okay, to be honest, it's a killer feature for GitHub Actions, essentially. So I absolutely love it. So now it's time for the demo gods. Let's put Borp into action. So first of all, we are in an empty folder with a tsconfig file. So I'm going to create an src folder, and then src lib, and make the src test. Okay, so we have our test stuff. And here we have those two things. Okay, so let's start writing a little bit of an app.ts, which is a Fastify app. So let's do import Fastify from Fastify. Then I can export a sync function, create app. Okay, let's call it build because I prefer to call it build, but this is me. And this create a Fastify app, and then it returns it. Now I also need to import a type. So type Fastify Fastify server options. Okay. Here we go. So here opts, yes, and opts. Okay, so we can pass them through. And now in our tests, let's test this. Okay, how do we do this test? Let's call it app.test.ts, and we can do import test from node test, and then import assert from node assert test. It should work, yeah. So let's call it root endpoint. And this is an async function. Then we can create our app. Oh, we need to import it. Import build from libapp.js. So we do await build, and then we inject. We use the injection from Fastify status code, and we verify everything works. So if I've done my job correctly, I can do npx burp, and it's failing. Oh yeah, because I made a mistake, a typo, and now it's working. And in fact, you can see it's failing because I use strict equal and not strict deep or deep strict equal. Here we go. So now we run it again, and you can see it's running very quickly, and we can do even code coverage. You know, everything's done, set up. So seems pretty great. Okay, so why do we? And you can see now that we have created our dist folder, and we have our tsbuild.info, which is needed for incremental mode, and we have our files in here, and so on and so forth. Note that this structure more or less is the same structure that you will have for your production environment. You might not want to compile tests, but that's kind of the same thing. So I think this works very well for to have a one-to-one system between development and production. So then what other features are very useful with this? It's we can, for example, add Fastify static. Okay, so we want, let's say that we want to create a static test.ts, and I'm going to copy this. Okay, let's say that there is public folder here that include a file.txt, which can be generically your CSS file, to be honest, and it contains a string called hello. So here I can do test serve static files. Okay, and now here I can say, for example, I want to public file.txt. Okay, and here is a strict equal and response.payload, and we call it hello, and these, let's see, this should be it, right? Oh, wait, I didn't configure, it's failing. Why? Well, I didn't configure anything. So I actually need to import Fastify static. Well, this used to be correct, but I need to change it. And then we need to use root, and I need also join. Okay, and now I don't need to do any of this shenanigan, which seems very odd. I can do just import meta dir name. Thank God. Oops. And then I need this dot public. So, and you see this is right because this was code, this type of path will work if we're both inside SRC and inside Jest because it's the same structure. So, hey. And now it's failing, still failing. Why? Let's take a look. Oh, of course, it's failing because I haven't set the prefix. So I need to set the prefix and call it public. And running it again. Oh, wow, it's passing, but it's missing a /n. Huh, cool. Here we go. Editors are fun. Yay, okay, we have made it. Pretty nice, okay? And we can, we can really go on for quite a while with this pattern. It's work from my point of view super well, and so on. I want to show you a couple more things that are very useful. So for example, we could implement a snapshot testing. So we could do, let's so go back here. Let's say, well, this is fine. And so we could implement snap from @Matteo Collina. Oh, snap. Okay. And here we need to create a snap function, which is snap and passing in import meta URL. And now let's say that we can do, for example, snap. Oh no, sorry, I made a mistake. Okay. So instead of doing this, instead of specifying what we want, we can do snap and response payload and await this. So what this will do, it will, on the first run, it's basically a true equals true scenario. But after that, the file gets stored on disk, and each subsequent one will actually have the file stored on disk. So seems pretty cool. And this still works, but if we go and change our file, for example, now it will fail. You see, it now failing. Cool. Very useful. I think snapshot testing is a very, very useful feature. Let's see, for example, instead how you do the test planning with this set of utilities. So let's say that we can add another route here. So let's say let's call it target, okay? And we want to get the result from a fetch endpoint. So, and we need to do, we need to pass a URL here. How do we get a URL? Well, I need to do is fastify server options. So app opts, and I need a target URL string. Cool. And here I want to be app opts. Great. So now I can do app. So opts dot target URL. Cool. And this is not needed. Everything will be forwarded correctly afterwards. So in my tests, I can target endpoint. Here we go. Target URL. Well, I don't want that. So I can do just target. And it's a Fastify app. And let's add a route. Yeah, that's great. However, we want a test plan. So we want to verify that function is called. So we can do import TSPL actually, yeah, from Collina TSPL. And we do const plan. And we say plan one. This is great because then we can do plan pass target called, and at the end plan dot complete await plan dot completed. And we need something that needs to be done because it will be listening this function at this server. So it's t after target.close because they are calling it to call listen here, and await target listen. Here we go, port. Like it can get very quickly complicated, and then we can do target.listen in origin. Sorry, why? It's origin. Okay, here we go. Okay, so we've done that. Okay, now let's try running it. Oh, it's expression is not callable. Okay, so let's try with npm-tsc. Probably gives me a little bit. Oh yeah, made a mistake here. This is likely I need to do this. Okay. Cool. And oh, let's do this. Here we go. Okay. And it's not there. Made a mistake. It's okay, I think. Yep. Then I am import type plan, because I don't know why we can't have good things. Here we go. Now it's compiling, so I can actually do borp coverage. And now it's passing. It's even detecting that we are a little bit of something that's not being covered, which is in fact the hack that I've done to have it forcefully casted. Cool. It's amazing. And you can see that we have a snapshot file over there, which is our snap. And that's it. Thank you for watching. And it's been fantastic. Please check out platformatic.dev. And, thank you and see you next time. Bye.
Thank you, Matteo, for the presentation. It was great to hear from you. And let's start the next one, which is by Jean Borrellier, who is tech lead at Sanofi. With passion for reshaping processes and being able to produce more by doing less, Jean works mainly as domain-specific reference on the JavaScript and Node.js ecosystem within platform and transferable teams. He's not directly building features for the business. Jean finds solutions to improve the global developer experience by enhancing the collaboration between teams, bringing suggestions on how to succeed together, bring more efficiency to all of them, and focus on the technical skills. So Jean will tell us how to go from libraries to core, exploring the future of Node.js development. Welcome to the stage.
Hello, everyone, and welcome to my talk about exploring the future of Node.js development and basically how we can remove a lot of libraries that we are used to have and import in our project, and how it was moved, like a lot of the solutions were moved to core and that you can use directly, basically. So the main idea is we have all been building Node.js and JavaScript application with a lot of library. Like if you start a new React application, for example, with React React app, you will have maybe 1,500 different kind of packages or dependency, which is like huge. You definitely don't use all of them, but that's how the Node.js ecosystem is built. And you all know the meme about what's everything in the universe, and it's not even a black hole, it's a node module like folder. So that's also an idea on how can we remove some of the library to have maybe less packages, less library, but also for security reason. That way we can just say, at least your project will maybe have less risk of importing a library that you should not, or just to improve the security as a whole. So that's the main idea of why it's great, at least for me, it's great to remove library and to use core feature and core solution if it's feature need, basically. So, but quickly, who am I? So I'm Jean Borrellier. I'm a tech lead and I'm working at Sanofi leading the platform team there. And I'm doing a lot of open source across different ecosystems, mostly still JavaScript, ecosystem, Rust, and a bit of cloud provider, mostly AWS related topic. I'm a Node.js community member. You can find me in some working group, for example, the Next 10, and also the Web Server Framework group. And since a few days, I'm also an Express technical committee member. So the main idea is to bring and help Express expand and continue to evolve in 2024. You can find me on multiple social networks, so Twitter, GitHub, LinkedIn. Feel free to connect if you have any question, any feedback. Like you can ping me without any issue. And just before going into like the pure topic of Node.js, everything I will be presenting in link to Node.js and core let's say, core solutions that are now included. So if you test them and find way to improve how you work with them, or new solution, or if you just also find a bug, please feel free to report everything or on a Node.js repository, open an issue. But you can also join us during our working group session that are public. So just join us and help us improve Node.js. So what we will be discussing today. So mostly I want to discuss a bit about Node.js 20. We are in February 2024. I think it's great to know about which version you should use today in production for Node.js. Then a good focus on the talk will be about the new feature, every new feature that are part of Node 20, basically test runner, watcher, and loader, and how you can help you remove some specific library part of the ecosystem. And finally, just what's really new, what was released part in a new branch, main branch, in the last couple of weeks. That's always great to know and be aware. So I think it's quite nice to check that also. So Node 20, I won't take a lot of time for that, but just as it's quite important. So Node.js 20 was released in April 2023, so almost a year ago, and it became the official LTS in October, so 6 months ago, approximately. At that time, you had basically 2 LTS releases, Node 16, but now the full support ended in September, so please don't use it and upgrade to at least Node 18. Node 18 support will continue up to April 2025. But today, Node 20 the official, so if you can update to Node 20, you should definitely do it. There is only advantages to be up to date, like from performance perspective, new feature, experimental feature, and everything. And the next version that will become a current version, so it will stay before this third version become an active LTS version, would be available in April 2024, so in 2 months, something like that, and stay for a few years there. So if you want to have the full map, this is a slide. So just the main idea here, don't use Node 16 or below. We do not provide security update or anything. You should at least be on Node.js 18. And one of the good stuff is Node.js 18 and even 20 are available since a long time on Docker, on everything. So you just need to use a good image, and it can be using Alpine, the Alpine Docker image, or the Debian-based Slim or not. Feel free to use whatever you want. And also, if you are using Node.js on some managed ecosystem, for example, AWS Lambda, you can update to 18 or 20. 20 is available across the full ecosystem from Azure, AWS, or GCP. So there is no good reason to not use Node 20 today, especially if you start a new project. So please update your version. It's also for your safety and security of your application. And I think that's quite important. And also on a quick note, if you want to know a bit more about big changes of the Node.js ecosystem and also part of the new change that came in the past year and are coming in the next year, you should check our video. And it was a recording from another conference with Michael and myself just to discuss about that and what the core big point and big feature part of the Node.js ecosystem. So feel free to follow that. I think it's great. And now it's time to go back to what we want to do, like removing libraries for our ecosystem. And basically all started with a tweet from Ethan that is involved in a Node.js project and a lot of JavaScript project. And basically did a simple tweet that you can see in the screen saying, hey, you can now with Node 20, you can do a lot of stuff without library. And it just drives me to write this talk and to display how you can do that also without being involved on a day-to-day, and just to be aware about the new feature part of Node.js 20. So first part is what's new. The watcher. So we all are used to use a specific watcher. NodeMon or NodeMon, depending how you say it, is one of the most used tools. If you are using specific, every project, maybe you have some Webpack, HTML based tool, maybe you use TS Node Dev or any kind of other plugin or solution. It's working fine. And the main idea is just to be able to provide a watch mode to restart a process when you import a new file. When you import or load a file and then said file is being updated, changed, and saved. So that's the main idea. And if we want to check that quite easily, let's say if I have a simple project there. So if you use NodeMon, I don't even know if it's installed on my side, but let's say if I do index.js, okay, let's install it. It's already installed on the project, I think. Well, sorry, up. Okay, I will need the -j, but I think I have it in my cat packages.json. I do have a command because it's still installed. Okay, yeah, so run nodemon, so npm run nodemon. Okay, so it's running like that, nothing really fancy. And if I update, for example, my index.js file to say hello, not Node.js, and I saved, great, it just restarted, and that's all. So basically, that's what nodemon is being used for, just being able to restart every time you save or update your project. Basically, that's the main point and use case. But now we implemented our part of Node.js core. Now you have the --watch like solution that allow you to basically the --watch give you the same result on nodemon to be able to watch something and it restart your process every time you will save or add something. So if we remove and clean that screen here, if I'm doing like not just node index.js, this one would work, it would display something, but I want to add a --watch flag. And then you have a small warning, so it's still experimental, it may change, but I think it won't change a lot. And here you have an hello world with the Node.js. And if I go back to my code and just change, finally, I want to say hello to Node.js people, and I'm saving here. Great. You can see now it's saying that and it's being restarted. You can also see that my full terminal was cleaned also. Like if I just go above, you can see everything, but that's the main idea. So great. So we have the same result as nodemon, or almost, because we are not keeping track of everything. But if you want to do that, you also have the preserve output with the flag --watch -preserve -output, which basically say to Node.js, hey, don't clear the console when the watch mode restart, basically to keep track of everything. And if you want to check that up, we keep the watch. We want to watch preserve output, same file, same command. And now if I update and I go back to Node.js and JavaScript, and I could zoom a bit more here, and I'm saving and I'm keeping here. You can say like everything that was before run and continue to run. So if I say and JavaScript and I remove and Bob, I don't know, maybe a Bob is listening to me, and now it's saying hello Node.js and Bob. So congratulations, Bob, you are on the screen. So that's quite easy to do. Like the main idea with this watch is to be able to replace something like nodemon or HMR or stuff like that, or maybe not completely HMR, but be able at least to reload your project. And if you want to reload something like that is not just one file being linked, so also just in parentheses, like here I'm just importing, like checking my file index.js. So if I have files that are being imported or imported, it will be able also to restart if subfile or file imported in the index.js are being changed, which is pretty interesting. But I can also like use watch path to be able to define if there is a change on one specific file or in any type on any file in a specific folder, then you restart your full process. So what I will do with the command, so let's keep the watch preserve output, and I will add watch path equal, and I have a folder that is src folder, and I just need double dash there. Okay, great. Hello Bob, Node.js and Bob. So now interestingly, if I change and remove here to just say hello to Node.js people, you can see it doesn't restart, because with the --watch path flag, it's ready to say, hey, you only update if there is a change in this folder. So in my case, the src folder. So if I do some change in my src folder, hello, not Node.js, let's say hello JavaScript, and I saved, then in that case, it's being restarted. We had hello Node.js and Bob before, and now we have hello Node.js. So that's just a way to say, and it could be great, for example, if you have a project, like, I'm not sure it would make sense to run that in production, but it could be used, for example, to simulate some kind of event-driven application or something like that, and to say, hey, if I receive a new file is being changed or stored in a specific folder, I want to rerun the application or to do something. That would be one way to use it, I guess, just from the top of my head. So yeah, this is the full way on how to use Watch, and pretty good. Like, it's easy to implement, not a lot of big change. It's just full only flag, command line, no other specific configuration, new configuration file, so quite easy to do. And with that, we removed one dependency. Great. So what's a new one? A new part, that's something that was added. So loader, which is quite important now that we all use TypeScript or a lot of stuff. So loader is really one solution that helps you to customize a default module resolution. And the main idea is to allow you or people using Node.js to pass a specific file to change one behavior of Node.js. And I will be speaking about loader because it's a big name, but the command itself is -- import, even if in some previous version or discussion, it was also called -- loader. So you may find -- loader being used on some project or some documentation or some tutorial or stuff like that. So that's why I'm keeping that here. And basically, the main idea when hooks are used, so one thing to know is they only apply to ECMAScript module for loading them, and it won't work with CommonJS module. So you have to remember that if your project is built using only CommonJS, you will have an issue, it won't work. So it's only for ES module kind of resolution. So how does it work? Great, that's a big question. So here, for example, I do have a simple index.ts file, which is just, I have a company, some typing, a main function that return just a variable, so a string in that case, and just hello world and main. The main issue is today with Node.js, I want to load this file, I will have an issue saying, hey, that's not the right format, I'm not able to understand that or work with that. So how can I do that? One main idea, and the main idea would be to use the -- import. So with that, and if you install, so TS6 is already installed part of the project, the main idea with Node -- import TS6 index.ts, it's able to use and hook TS6 into the Node.js process to run my index.ts file and to be able to like override some definition or to make it work. And here we can say that it's working fine. So no issue, hello world, sign off here, and that's great. And technically I could also say, hey, I want a -- watch. I want to watch something. So if now I'm changing to my Sanofi and let's say the company is Node.js and I save it, great. I have Node.js here and not Sanofi. And if I go back and rewrite Sanofi, great, it's working fine. So that way you can use that hook, that loader to work with TypeScript almost completely seamlessly without having to load and configure a lot of other part of the project with specific configuration file and everything, which is, I think, pretty good. And just to display just for a quick display, if you use a loader, it's almost the same way. So for example, here I do a -- loader, and in that case, I use ts-node ESM mode for that, and basically I will have the same result. So it's working fine here. Small part, you will have a warning here for experimental loader, as it may be removed in the future because the new official name would be with -- import. And without the watch here, we can say that there is no warning on nothing else. So import is really the way to go there. Yeah, so that's quite important. And you have also a programmatic way to use it with a register from Node module, and you can do that in specific case just programmatically. So that's something you can keep in mind. That could be great. And the last part I really want to discuss is test. Test, we have been writing tests using different library from Jest, from Mocha, from Chai, from like Karma and other stuff, Jasmine. We all had a lot of different ways to write tests. And it's always hard for newcomer and new people that want to write tests to say, hey, what should I use? And you search on Google, how do I write tests on Node.js? And you have multiple tutorials using multiple technology with different, almost the same, but sometimes different keywords. So it's not the easiest way for newcomer to say, hey, that's how you do tests. So one big part was to bring test part of Node.js core in Node 20. And that's really, for me, really great. And it's already like working fine with a runner, watcher, assertion, and reporter, and also coverage. So pretty much everything you need for when you work with tests. So like I said, just something as simple as adding a test runner and every core feature for a test runner in Node.js. So I think it's pretty great, and that's easy to use because just before we saw that --watch allow you to have a watcher, --import, or historically --load to load and to use hooks. And for test, let's keep it simple. So we have --test, and the big issue, like not issue, but big command here, just to be able to define a test folder, for example. So let's say we have a --test. I will remove that part of the command. We'll see that later. And just to define that my test folder is part of the, like my test folder is named test with an S, and everything inside is a test. So for example, here I do have one file with test. I have one describe, one test. We do have some stuff like that. And one thing that is really important is on top level, you can see that I'm not importing something from an external library. Everything is part of Node.js core. So you have node.assert for the assertion library. And from node test directly, you have a keyword that we most of the time use, for example, describe it, test, or stuff like that. So this is quite important. Everything is part to node, and I really want to push that. It's all part to node. And how do you write test? Great. You can define, I will just comment this one for a quick moment there. But basically, okay, so I'm described, I have a test called stub test that handle one test here that do an assert a db equal for 1 equal to 1. I could have a basic equal also there. So let's keep it simple with a basic equal. If I want to run my test, great. I just have to run the same command again. And we can see that we have a result. One test was run from one through, one is passing, no fail, no cancel, no skip, no to do, with a duration of 52 ms. Great. Nothing really special there. But if I want to create a new test, or let's say add some other test, okay, great. I want to create a test 2. And this time I want to check that 2 is equal to 2. Not really great test, but it worked. And here we can see that basically it say which describe. So I do have only one big describe running 2 tests. So the first test is passing in 0.14 milliseconds, the second one in 0.04 milliseconds, great. And everything working fine. I do have my result. Okay, great. Tests are passing, that's great, that's easy. What happens if I do expect that 2 equal 1, which it's not the case, right? So this time, if I run my test, you can have the full feedback and information about the test. So when the tests are being run, in each category, you will have the error. So here, you have an assertion error, 2 is not equal to 1. You have the full trace on the error, generating message and everything. And at the end, you will have a full summary of every test that failed. So that way, if you read only that, you can find them and just run with that. And you have basically all information, like the actual value that was given to the test runner is 2, and it's expected to have 1. Great. So it's not right. It's not correct. So this is an easy way to write some tests there. And you have a lot more command. For example, you can also say, hey, I don't want, maybe you are working on the first test and you want this test, for example, to be skipped. So you can just say, hey, skipped equal true, great. And if you run everything again, you can see that the second test is skipped. And same way as before, if you want your test to be watched, great, you can run that. And that way, every time you will update something, let's remove the skip true here, and you save, the test will run again. And if I fix the issue, so 1 equal 1, great, now it's passing and everything is great. So that's just to show you like how quickly it is to write some tests, like nothing really new to learn, like it's still almost the same keyword. It's an assertion library, so not really hard to implement and to work. But also if you are used to use different reporter, you can have different output depending on what you like. So with that, you can use a --test reporter. By default, it's a spec value that is being used. So let's remove the --watch and let's pass --test-reports. Like, let's pass nothing first. Okay, great. This is a way, and you have everything here. If you do the same command with --test-reporter equal spec, perhaps wrong way. Let's put it here. --test-reporter equal spec. Like I said, Great, no change, same way to display the information. Now, if you want to, for example, use something else, maybe you use dot. Great, I have some dots, and that's the only thing. And if it fails, you can just to display the change here. Great, I'm saying that there is some fails, which is just showing with an X. For people using, for example, Carmine Jasmine for front-end application, that was something we had before. But you can also use, if you are used to Java style, you can use JUnit and basically export that as a JSON, like a XML file. So that's another way. And if you want something less, let's say, verbose, you can use tap here. And it's basically outputting as a tap version and tap way to work there. So just some stuff quite easily, quite quickly on that. So you have multiple ways to report information. The spec is the default one, like I said. Great. But you have also other commands, like I only have like a few minutes to discuss about that, but you can work and find that, like I said, you have way to skip here. You can pass multiple options. So I display the skip, but for example, yeah, like you have the skip. Which one can you have? Yeah, like skip will be, I guess, the main one to use, and maybe also only. So that way you can only say, hey, I just want this test to be used. For that, for example, if I go back and I remove like the reporter and everything, I still have an error there because it say only and run only requires a -- test only command line option. Because if you don't provide that, it won't work. So -- test only. And then we can see that here on my test, like the only option was not really set for that. So if we go back there, it's because I only put it into the subcategory and I will need to pass that also here. Great. And now if I do that, so I have two tests, we can see that only the first one is being run. The second one is not being run because there is no only. If, for example, I add the only option there, so up, in that case, we should have great. And I'm running that again. And then it should run both of them, and the second one failing. So if I'm fixing like the issue here, it will be way better to see that both tests have been run. So great. And the last one, quite quickly, I just have a few minutes, is we are all using configuration, for example, to store database setup, URL for API, specific tokens, and please no secret. Good to remember. And just we use configuration file a lot for example between production, test, dev, and other account. And the biggest library that I use for that are .env and config in the Node.js ecosystem. So that's also something quite important to have and to be able to use. And like a few weeks ago, it was completely released by Yagi, that is a core maintainer of Node.js. Like he released a solution to support the .env way of working with configuration file, and it's now being part of Node.js. So it's not yet backported to Node 20, but it's part of here Node.js, the future release that will become 22. So for example, if I'm running Node version here, it's a 22 pre-version. And how do we do that? And how do we use that? So basically, I do have an env file here with two variables, a port URL, and a basic index file with process load env file, which file I want to load, and basically then it's being pushed into process.env as a value. And if I run, for example, my file here with a version 20, we can see that it's not backported, there is an error. But if I run the same code using the latest, so my specific build, like based on the main branch, and I'm running my index.js file, great, I do have my value directly. So that's the last one I wanted to show. Basically, just you can define and use a .env way to work and import configuration file to be used across your project, which is pretty neat and pretty great, like another library that we don't need. And just for the last word, and I think it's the last minute I have, is basically in 30 minutes, we saw how to remove no daemon and replace that with a watcher to use also the loader to simplify how we use TypeScript or any other way to hook specific functionality and change some behavior on our application. Then we saw also how to work with tests, which is great because like tests are nice, but just having the choice between 10 or 20 different libraries could be hard. And that way it's also directly part to core. It's also like on most benchmark, it's also more efficient. So it's also always like, it's also and always a performance issue, which is great, especially if you are working with like large projects. So this one remove like 2 to 3 libraries depending what you are using, and the last one is removing .env. So it's basically removing 5 libraries, I think, in 30 minutes. Pretty good, pretty neat, not a lot of changes, like it's quite easy to do. So yeah, if you have any question, don't hesitate to ping me somewhere on my social or in a few minutes during Q&A. So great. And see you, thank you so much. Have a good day.
Thank you for the talk, June. And we have actually our speaker backstage with us for a Q&A session. Hi.
Hi, how are you doing?
Great. How are you? Nice to meet you.
Pretty good, thanks.
Glad to hear that. So we have a couple of questions from the community. How will Node.js shift to core-driven development affect performance, scalability, and developer experience?
That's a really good question. So I will like answer in multiple parts. And I think during my talk, I already answered a bit about the developer experience. Like most of us, like people that have been working with the ecosystem for the past 5-10 years, we are used to have testing, for example, with Mocha or Jest, depending if you are doing front-end or back-end. But it's always also a discussion about is the tool or the library maintained correctly and efficiently? And it's always hard. Being able to move that into core, like give a lot more security in the term of you have most of the time a bigger team, like a lot of people maintaining everything. So it should be, I guess, like it's still new, but it's, for me, I think for the developer experience and the scalability, it should be better. And also we have to think also about newcomers. Today, if you are looking on Google how to write tests on Node.js, it will be huge, and you will have people, hey, this is a way to use Jest, this is a way to use Mocha, to use every part of the ecosystem, which can really be overwhelming for everyone. And for the performance, today, the testing solution part, like that is included in Node, is, at least on my part, on my end, on every benchmark I did, is faster than everything. So performance to run tests would increase. So we are not speaking about a 10x improvement, but like for me, it's showing on my CI.
Great, thanks for answering. And one more as well for you. Can you give examples on how new code functionalities like native test, watch mode, and loader improve developer productivity and streamline application?
Yes, so on this one, like it's quite simple, I guess. For me, for the developer productivity, not having to explain and to give multiple tutorials that are maybe up to date or not up to date and follow with a lot of change by the community. And I know those kind of modules are stable, and this is great. But having something part to core for me, it's also showing that it will continue to evolve and to stay compatible across the year. So it's also like, for me, it's removing some question about scalability and security and update and everything. So that's two of the main way. And globally, for the developer productivity, like it's almost the same keyword that we are used when writing tests with other technology. So it's not a big change. It's just, for me, a change on removing specific dependency. Fair warning though, there is still a non-support. So if you're writing with tests with TypeScript and everything is TypeScript rated, it's not currently handled directly in the core because of everything that is linked to map file and everything. But Matteo Collina, that is a member of the Node.js ecosystem, TSC, Fastify, a lot of things, and he's also talking just after me, I think. He built, and he does have a library called Borp, I think, that is built to handle that. So we'll also watch how it evolves in the future and maybe bring that to core. And if someone wants to open a pull request to fix that and import that to core, it would be amazing also.
Great. Thanks for answering. And I guess that's all.
Thank you so much.
Chat. Thank you for taking your time for joining us for the Q&A, and thank you for delivering your presentation. It was an absolute pleasure to collaborate with you.
Cool.
Hope to see you next time.
Yeah, thank you so much. Have a good day.
Have a good day. Bye. And now we can start the break, and we will be back with next block soon. And it's time to start the final block of our junior track of Global Summit for Node.js 24. And I'm happy to invite to the stage our next speaker, Marianne Villa. She is the head of the community at Pioneers Dev, award-winning community builder, a recipient of IBM Open Source Community Grant in 2020, Google Launchpad Panther, Google Developer Expert in Web Technologies, and Women Tech Makers Ambassador. Passionate developer and designer with crack of combining technology and community development. Welcome, Marianne. The stage is yours.
Hi everyone, my name is Marianne. I'm going to tell you about TensorFlow from the ground, then TensorFlow.js, and finally, how to explore applications of machine learning for web developers and creatives. We'll delve into the realms of TensorFlow, Node.js, and JavaScript, uncovering how these powerful tools come together to reimagine the web as we imagine, as an immersive playground for creativity. So today we embark on that exploration of the digital canvas where creativity and technology intersect in fascinating ways. But first we need to set up the baseline. Before delving into the intricacies of our discussion, it's essential to establish a foundational understanding. We'll explore the convergence of technologies as Google is actively advancing. So there are different teams. They have Google Brain, DeepMind, Google AI, and the focus of these teams varies. So, for example, for Google Brain, we will have developed new AI algorithms, and the key projects are TensorFlow and AlphaGo. So, our spotlight today shines in the realm of technologies for machine learning and numerical computing. And in our journey through the landscape of machine learning and numerical computing, we encounter powerful tools that shape the future of technology. Among them are TensorFlow, Keras, and JAX, and each offering unique capabilities in the realm of modeling and computation. So TensorFlow stands as a robust framework for building machine learning models, while Keras provides a high-level interface for simplifying the process of model creation and experimentation. Meanwhile, JAX, with its focus on composable function transformations, offers a pathway to scalable and efficient numerical computing. We'll dive deeper into the capabilities of TensorFlow and explore how it's revolutionizing web development and machine learning integration. But before we proceed, let's take a moment to explore TensorFlow itself. What's TensorFlow and its capabilities? So, TensorFlow Framework Overview. This talk is designed for people who know the basics of machine learning but need an overview of the basics of TensorFlow. We're not going to do a lot of math or a lot of code, but we will do a code explanations. So be ready. Machine learning usually, in this case, probably doing machine learning, if you're doing machine learning, there are other things you can do with TensorFlow, but we'll be sticking to machine learning. So machine learning usually is associated with Python, and you probably heard that machine learning primarily uses Python, so later on you will discover why you don't always need Python to utilize TensorFlow. Most often you write models and conduct training using Python, but in this case you will see JavaScript in action. So the arc of machine learning. So we're doing machine learning, we think about the arc of the workflow. So first we have group or collect some data, then represent weights of parameters, then we will build a model outside the weights, train those weights with math, and accelerate that training to the end. But TensorFlow has a lot going on. So we have a lot of methods, classes, and functions, thousands. We have currents and Sonnet if you need high-level APIs. And we have a lot of packages, probability, TFX, light, GS, agents, privacy, and lots more. So even we have TF NumPy. So, but how do you get your head around the design of the entire system? So TensorFlow, from the middle up, we have TF graphics, we have eager, and we have compilation. So TensorFlow has a lot of different layers, even though this talk is from the ground. The part we are talking about today is some Python part that fits above the runtime, but below high-level APIs like Keras and Sonnet. So if you're doing applied machine learning, you may want a higher levels API than this, but those higher levels API are using these fundamental parts. So what are these parts? We have 5 easy P's because TensorFlow has a multitude of layers, each contributing to its robust functionality, and it's crucial to acknowledge that these higher APIs are built up on these fundamental components. So we have tensors, we have variables, we have models, we have gradients, and we have TF function. And these 5 features to remember. So we have tensors that representing some data, we have variables that representing weights, we have gradient types that are training those weights, and we have models that do building a model. And finally, the TF function to accelerate that training or interference. So let's start with tensors. Tensors are a static numerical representation, and tensors and multidimensional arrays are strongly typed, called a D-type. And if you're familiar with NumPy, tensors are kind of like empty arrays. Everything you see here is a tensor. Tensors are strongly typed with ints and complex and strings and exotic styles. So all tensors are immutable, like Python numbers and strings. You can never update the contents of a tensor, only create a new one. So why do we need tensors? So we see this, and computer sees that. So here we have an image covered into a float tensor. Each pixel value turns into a floating pointing a number in a big matrix. So we use tensors to represent whatever it is what we are trying to operate on. Images turn to tensors, sounds turn to tensor, text turn to tensors. Tensors are also fast, and they can be vectorized, and they can use accelerators. So tensors are all inspectable and have a lot of different features. So the biggest one here, which you will see a lot, is shape, which describe the number of elements along each of the axes. Fundamentally, though, you are allocating a block of memory and some metadata around some brick of numbers. We have shape, rank, axis or dimensions, size. And also we have variables where you store the changes. So tensors are great because they are immutable, which make optimizations and refactoring possible, including letting the graph optimizer, fault constant, and so forth. However, every machine learning model is made out of changeable parameters. So you can just store these in variables and it will be really slow. So TensorFlow has a special data type for this. So we have a checkpoint here. We have tensors, we have variables, you can do the forward pass of a network, you can do the backward pass to calculate gradients. What about building whole models? So what about building this whole model instead of just one layer of a little math? So models is collecting all your stuff. Since TensorFlow lets you define your models in Python, models are Pythonic ways of carrying all this functionality together. So we have tensor, we have variables, you can do the forward pass of network, you can do the backward pass to calculate gradients, we can train a model, and we can make graphs and save everything. We're done. So there's so much more. So you can have high-level APIs, have idiomatic coding you want to learn. Low-level stuff might just be TF NumPy, which is coming soon, and right now. So distributed strategies, TPU pods, all that, getting data in your models with TF data, and of course, putting your models in production is a whole field of study unto itself. So remember this, what to do. So first, you need to define data in terms of tensors, then you define trainable values in terms of variables, track gradients with gradient types, define models in terms of models, and make your model run fast with TF functions. But what about TensorFlow.js? So, TensorFlow.js allows seamless integrations of pre-trained models into web applications, enable tasks such as image recognition, object detection, and natural language processing to be performed directly in the browser without the need of server-side processing. This capability opens up a world of possibilities for creating interactive and intelligent web experience. So open source machine learning library that runs anywhere JavaScript can. That's TensorFlow.js. And TensorFlow.js, it's a library for machine learning JS that can run in the browser on the client side. This enables lower latency, interference, high privacy, and lower serving costs for our users. We can support Node.js for server-side and, of course, IoT. They support Node.js and server-side and, of course, IoT devices too. So machine learning on the browser client side means lower latency, high privacy, lower cost of service, and it also supports Node.js and IoT services. They provide 3 layers of API, so you have top layers like TF.js for training models, ready-to-use JS classes, layers API to easily build and train models using high-level building blocks, and ops core API, so fine control of models architecture for a linear algebra calculation. On the client side, we have TensorFlow.js that supports several backends for the browser. All 3 are supported. For other environments like Jest, React Native ones may not be available, depending on device and implementation. On server side, they support TF CPU via C bindings and CUDA acceleration for GPU, and same server side backends as Python. But write once, use everywhere with the rich and scalable of the web. That's the magic of TensorFlow.js. Simply convert your machine model to run in JS on device and unlock the rich and scalable of the web, which can bring many benefits. For example, series install. So use any of our demos, of these demos of TensorFlow.js in just one click of a link. You can reach an audience of billions instantly with non-complex environments set up in a way people can share with this. This can lead to some great visibility in your research or product. So here are the environments TensorFlow currently supports. So you have browser, you have server side via Node. They have native mobile via React Native or progressive web apps, native desktop via Electron, and even IoT, for example, on Raspberry Pi, which is possible via Node. So with TensorFlow, you can run, retrain via transfer learning, or write your own models completely from scratch, just like you may already be doing in Python, but in JS. And by creating the model, I want to remind like a first concept that is classification. So half of time a monkey is by humans. So our first task, for example, if we are creating a model, is classifying the group of monkey in 2 classes. So class 1 will be the monkey that bites, and class 2 monkeys that do not bite. So an example of classification will be what rule determines which class the monkey belongs to. So if the monkey that bites show all his mouth, and the monkey that does not bite is easy, quiet, closed mouth. So that will be the class 1 and the class 2. So that will be the model, the set of rules and steps to make a prediction. And about the classification. In that monkey example, as humans, probably you could infer the model, the set of rules. But in most machine learning classification problems, we don't know the rules of the model. So we humans only obtain the result, the assigned classes. So that would be the second concept, important concept to have in mind, that would be conditional declarations. So in JavaScript syntaxes, we would use if, else. With more than one condition, it is used else if. And probably you don't need to remember the syntax to find documentation, include the language JS, and what you are trying to do. For example, JavaScript, if then statement, or use an assistant. So software engineers put an input, a rule, and you get an output. So there are intelligent humans who write the rules and algorithms that we are using. But in machine learning realm, we'll have computers write the rules and algorithms for the output. So machine learning is the process that allows computers to determine new set of rules called models. And we will have pre-made models in this example, because with pre-made models, they have like pre-made models that are continually expanding or optimizing these models in the TensorFlow.js team, and they have vision, human body, text, sound, and others. For example, in vision, you have image classification, object detection. For human body, they have body segmentation, poses estimation, facial landmark detection, and hand postures estimation. For text toxicity, sentence encoding, BERT as a Q&A, and conversation intent detection. They have sound, that is voice command recognition, and others that we key and classificator. So if you want to try them, you can go to tensorflow.org models and explore them. So basically, you have TensorFlow.js for everything you want to imagine, and by using pre-made models or creating your own, if you wish, it allows you to create pretty much anything you might dream up. So let's take a look at what people have been making. So here is an example. So in space is a client-side toxicity filters in a web conferencing app. So you can see that when a user types something bad, it's flagged before it's even seen to the server for processing, and it alerts the user they might want to reconsider that they are about to send. So creating a more pleasant conversational experience on the platform directly. This is another example. This is include health. So they are using TensorFlow.js for health. So they collaborate to refine our pose estimation, the pose estimation model. So they specifically for use case within physiotherapy at scale, or for sports, for training in your house. So using off-the-shelf technologies such as standard webcam, many people can access this full body squat, etc. So this is another example for pose animator. So give life to a character. This is some cool project that I really like. So you can even bring a character to life by combining multiple pre-made models. They have pose estimation, they have face mesh detection simultaneously. So creating animation is a hard program, but with pose animation, this is a partner innovation with Google. Allows you to draw any SVG character you like and then use your body to control it in real time, giving animators a motion capture solution to drive 2D character animations that anyone can use with just a webcam. And yes, all of this is running entirely in a web browser. And this is, for example, for musicians. So you have also tone transfer, so you can turn your voice into an instrument. And they have they use Magenta tone transfer model that runs entirely in browser using TensorFlow.js. So you can simply sing any song or tune you wish and hear, and it will be played by an instrument of your choice, allowing anyone the ability to now play an instrument with their voice and with this generative model. This is one that I really love. So Shuwa make the words more accessible. So they have TensorFlow.js to understand sign language gestures. So this project is built using a combination of machine learning model outputs for face, hands, and body to account for the fact that sign language is communicated not only with the signer's hands, but also with their facial expressions and overall body position and posture. So the demo is training on JSL and HKSL phrases, but could scale to any sign language dialect. So this library can be used for any sort of gesture recognition, even beyond sign language, and it's generalized to any human-computer interaction use case. So this opens a lot of possibilities for web-based creative experience, fitness, health, and even HCI research. Face Mesh has iris support and more robust tracking for the face itself, as you can see from the animation on this slide. So in the left is the old version, which you see is a struggle at more extreme angles, versus the improved version of the right that can also track with higher fidelity around the eyes areas. And MoveNet Finally, it's an ultra-fast and accurate model to track 17 key points optimized for diverse poses and actions. The second one is MediaPipe. A place pose gives off 33 key points and is also tailored for a diverse set of poses, and has extra granularity, such as tracking both hands, could enable gesture-based applications that may be used for certain projects. And for higher accuracy and performance, they have Postmate implementations, so you can try both for see which work best for your intended use case. So pre-made benefits. So when you use a pre-made model, you don't need to gather training data yourself. You could rapid prototyping with lower cost. You use state-of-the-art research, and it's easier to use and good documentation. So you can transfer learning for some models. If you want to look for more machine learning projects with JavaScript, you could just search coding train. I'll go to the link. I will provide the slides at the end. And finally, but now I want to explain my approach to exploring a pre-trained model that makes face mesh and hand recognition. So this project, which is based on TensorFlow.js, is an open source project that allows you to explore the canvas as an open blank canvas for creativity and also for implementation, even on a commercial scale. So let me share a story reminiscent of my photography classes, where we delved into the mesmering world of light painting. Light painting is a unique art form that involves crafting images using log exposure times on a camera and employing dynamic light source to paint the scene. So picture this: a light painting photographer triggers camera shutter, allowing to remain open while skillfully maneuver a light source through the air to create stunning ethereal compositions. This is how I discovered this project, which allows me to shoot this demo in real time. So the imagination is there to shoot on this blank canvas. And I will show you like this demo. So I will move my hand to change the position of the cursor. I need to allow this time the privacy settings, and I perform a pinch pose with my hands to draw. And if I like to clear the canvas, I will use my fist. So everything is done client side in the browser. So thus your video stream is not shared with anybody. Depending on your setup, it makes sense to move closer to or further away from your camera. The lighting in your room, the better it works. Is MIT licensed GitHub projects, and for question, comments, requests, etc., you could go to GitHub issues directly in the project and contact them through benjamin.handtracking.io. Okay. Finally, if you are looking for inspiration, there are many ways to get. So here we can see how people are using TensorFlow.js in many delightful ways with just a little bit of creativity. Things like the one you see on the screen. And you can join the community with the hashtag made with TensorFlow.js. Things like learning size estimator on fashion websites, invisible clocks for creative activations, or how about webcam privacy for video calls, or even lip syncing to your favorite song. So you can even teleport ourselves anywhere in the world using newer web technologies combined with TensorFlow.js. So you can see projects like this as the TensorFlow.js Show and Tell live on the TensorFlow YouTube channel every quarter. And if you have questions now, the question will be, what would be you make? So it's really up to you, but if you are looking for inspiration, check out the Made with TensorFlow.js hashtag on Twitter or on LinkedIn to see even more amazing work as it made. And with that, thank you for listening, and we hope to see you taking your first steps in immersive web with TensorFlow.js. Machine learning is no longer just for academics and research engineers. With TensorFlow.js, we are seeing artists, creatives, even musicians take their first steps too. So no matter what your background may be, feel free to connect with me on Twitter or LinkedIn if you have further questions, and remember to use the hashtag made with TensorFlow.js if you make something that uses TensorFlow.js. Thank you for listening.
Thank you, Marian, for the presentation. And now I'm happy to introduce our next speaker, Alexandra Sikora, who is an open source developer at the Guild based in Warsaw, Poland. Previously a tech leader for Hazura Console and lead maintainer of Blitz.js. Passionate about open source, TypeScript, and dedicated to stay up to date with the JavaScript ecosystem. We have Alexandra live with us today. Hi, Alexandra.
Hi. Thank you for the introduction and welcome everyone. Thank you for being here and joining the conference.
Here's your slides.
Okay, perfect.
The stage is yours. I'm going backstage.
Yes. So again, thank you very much for having me and thank you for putting this conference together. So, yes, my name is Alexandra, and before I start talking to you about APIs, let me just say a few more words about me. So I currently work at HDB. It's a database company as developer experience lead, and I'm also organizing a TypeScript meetup in Wrocław. And you can find me, and after this talk, you can reach out to me on Twitter. Alexandra says my DMs are open, or at least should be. Or you can check out my personal website alexandra.codes. So as you might have guessed, I will be talking about APIs, not mostly about REST, but not only. And before I start, I wanted to also mention, why are we talking about APIs? So a typical scenario when you're building a full stack application is that you have a client and a database that you have to access. But even if your database was publicly accessible, you can't call it or you can't access it from the client because that would expose all the database credentials. So we usually have servers that are responsible for talking to the database. But that means having this server that handles the connection to the database, it means that we need an API. We need this kind of bridge that connects one part to another. But whenever you have to make two separate entities talk to each other and understand each other, that's when things get complicated. So even if the services, even if your client and server are in the same repository, written in the same language, you still have to deal with the network layer. So we very often face problems like, a lot of boilerplate, we are losing type safety between client and server, and we also deal with repetitive error handling. So, over time, there were multiple solutions that tried to solve it. But one thing that is particularly painful, at least for me, is losing the type safety, because we are at a Node.js conference, so we probably write your backend in TypeScript, and you also probably have your frontend in TypeScript. So if you have this perfectly type-safe backend and perfectly type-safe frontend, it's kind of a shame to lose it on this API layer. So what can we do about it? Well, before I dive into different solutions and before I dive into FETS itself, I wanted to talk to you. I wanted to not only talk to you, but also I wanted to take you through a little bit of history and mention how we got there. So firstly, let's go back to the 80s, the beginning of web services. So what was the beginning? It was a remote procedure call. And that was the simplest and least constrained form of an API. So let's start by explaining what it means. So look at this example of a local procedure. You have this function hello, and you also have, you call it in possibly the same process. But now, what if your function welcome or any other function is on a different process, on a different server? This is the common scenario when building full stack applications. And now you need a server to call it. So for example, if gRPC API is using HTTP, but by the way, it's not constrained by that, but I'm just explaining it in the context of HTTP. we could send a post request or a get request to an endpoint with a procedure name, and like that endpoint would have the procedure name. Here we have this welcome, and we would send the parameters as body or a query if we were sending a get request. So the idea behind RPC was to be able to call remote procedures as if they were local. But there were a bunch of problems that was working fine, but then like the problem of what if we want to have multiple clients? What if we want to have our server being accessible by different kind of client applications? Maybe we have a mobile application and a desktop application. Maybe you want to have a public API. Then that's something that is a little bit difficult with RPC, because RPC meant that client and server were tightly coupled. So in other words, it wasn't agnostic. And the next thing that developers were looking for was something agnostic. So early 90s, we have Corba, and this is a language agnostic standard. So in Corba, we have the notion of server, and it's something that contains objects, and then we also have a client, which is a process that requests those objects, and there's also this thing as object request broker that is responsible for the communication. So in order to be like language and platform agnostic, Corba introduced interface definition language, which was also a huge milestone for the like programming in general. So what it does, it's mapping. You can declare a mapping between different languages, and one of the most popular IDLs that you might have heard about is protobuf. But the problem that used to be in Corba, I said used to be because it's like no one uses it anymore. Like the problem was that being platform and language agnostic introduced a lot of complexity, and Corba was very difficult to learn and to use. So if this was complex, then the next thing that developers were looking for was something simple. So here we go, a simple object access protocol in late 90s. So using SOAP, the request to the API by default is an HTTP post with an XML body, and the request body, I won't go into very details, but basically you can see that there's this envelope, and you have different SOAP wrappers that help identify the request. So you have all of that basically to be able to send a GET request, like to get a user with ID 123. And what's worth mentioning is that SOAP was a significant improvement over Corba, and it's still being used today, particularly in older systems where security is crucial, for example, like airline systems. But SOAP was XML only, which makes requests heavier, and they, because of that, require more bandwidth. Excuse me. Another thing is that it's tightly coupled with the server by having this strict communication contract. So we are kind of with the same problem as with RPC. And then again, if you are using HTTP, then we are using POST, which is considered non-independent by the HTTP standard. So we can't leverage the caching mechanism. So all of that, and the fact that SOAP was quite verbose and inflexible, so changing one thing on the server meant having to change it on the client and vice versa, meant that SOAP was not only not as simple as it could have been, but also it was heavy. So the next thing that programmers were looking for was something light. So around 2000s, the web started changing. The work over HTTP was progressing, and Roy Fielding from the same working group as the same HTTP working group created Rest. And in fact, HTTP 1.1 is the first API that strictly follows Rest principles. So firstly, it's not a protocol like SOAP. It's rather a set of architectural constraints. It's intended by default to be consumed by many clients, and it makes the server-side data available, representing it in JSON or XML. In Rest, the idea is that server and client are completely independent and they don't care about each other internals. They can go over many changes and it won't affect the communication as long as Rest constraints are not violated. So in other words, in SOAP, you really had to say a lot to get your data, like the request body contain a lot of information. And in Rest, you just don't have to say that much. And in contrast to RPC like APIs, you can think of it as resources versus procedures. So here's a comparison of how a similar API would look like in REST and RPC. In REST, you ask the server, can you give me the state of this resource? Or, hey, here's the state of this resource. Please store it at this location. And in RPC, you are more like, hey, can you call this procedure for me? And then we can argue about and people like to argue about that, what REST really means. And in fact, a lot of REST APIs are just JSON RPC, but still all those constraints, having those strict constraints, means that that REST is not or was not flexible enough. So there were problems like overfetching. So if someone defined a server endpoint that returned a bunch of data, but the client application didn't really need this amount of data, it would still have to it would still go over the network. Then also N+1 problems, so the need to do multiple round trips to the server to fetch data for a single view. So now it was time for something flexible. And in 2012, we have GraphQL. So with GraphQL, it was easy to eliminate the N+1 problem from the client perspective. It may still be there on the server. But from the client perspective, you don't have to send multiple requests to get data for a single view, because you send only one post request with a query that contains the information about what you need from the API. And you can also eliminate problems with overfetching, because GraphQL lets the client decide what it needs. So the server provides it with a schema, which has all the information about what resources are available and what are the relationships between them. So based on it, then the client can decide what it needs and articulate a query. There's something like that. One truth about GraphQL is that it shares some similar concepts to SOAP, which means that it also have some of its problems. But this time we have JSON instead of XML. But what do I mean by that? It's still post request, so we have to deal with not being able to cache the request unless we use a dedicated caching solution, or the client library handles that. Okay, so with GraphQL, we had a significant improvement, but there was also no type safety out of the box. I mean, there was the type safe schema. You could you would know whether your query is correct or not. But from the TypeScript perspective, you have to use like possibly a code generator to generate the typings. So now, like what the natural next step, and that also that was also important because the timing was that TypeScript was becoming more and more popular, and it was becoming a de facto a standard. We wanted type safety for free and out of the box. So let's go back to the concept of RPC. And let's revisit the original promise of RPC. So I've been talking for too long today already. So one thing that also happened around this time was that Prisma happened, and it had a significant impact on the development of new tools and on the developer experience, because suddenly dealing with the database was much easier, and what's most important, it was type safe. So can we have the same thing in the API layer? So if you're looking at this from a full stack TypeScript application, maybe we can minimize the distance between client and the server. Maybe we can like create some tools that kind of like abstract this API layer. And here we go. There were a bunch of tools like that. There was it still is TRPC, query and mutation procedures, Blitz RPC that I also used to work on, Quick City, Remix Loader Pattern, React Server Components, and there were also other variations on RPC like PRPC, for example. So so what all of these tools do is they try to make this API layer as small as possible, so that we as developers writing the full stack application code, we don't have to be bothered by it. And which doesn't mean that it's not there. It's still there. There's still a network call. So we still have to be aware of that there might be network latency or any other network issues along the way. But from just the developer experience perspective, it became much easier. So and there were like a lot of memes also like with the rising popularity of React Server Components that this is something that used to be before, which is not like completely true. It's different and it's improved, and some concepts might look similar, but still at the core we have new tools. So then let's see what happened last year in 2023. So like all of the RPC based solutions were very appealing, but again, like we were talking about full stack monolith applications, but what if we want the same as developers wanted in the 80s? What if you want our servers to be easily accessible by multiple clients, or maybe publicly accessible? Then like we can go back and use REST or GraphQL, but the thing is that the bar is now much higher. Because right now we would like something agnostic, but also type safety is a must. Like especially as I mentioned before, with TypeScript being de facto a standard. So now we can see, or we were able to see in like last year and few months ago, basically, that there is this new trend coming back to APIs, and it's leveraging REST again. So there were tools like Bridge.js, Stainless, or Feds that I'm going to talk about, that like what they did, they were focusing on making REST APIs better. So as promised before, I'm going to show you one of them, which is FETs. And a small disclaimer, this is just a sneak peek. I won't be doing much live coding, but I will leave you all the links to try it out and play with it. So now I'm gonna switch to my code editor and show you a few things. So I have a little demo. The demo is this kind of application. So basically it's, I'll make it slightly bigger. It's using Spotify's API, and I'm displaying random songs based on the mood that I'm currently in. And you can actually do that with Spotify. There's an API that accepts this kind of properties. So now also Spotify has its open API spec public, so you can take a look and you can download it. Here's like I took it from the Spotify's developers website, and I can take a look at all the different endpoints and explore what are the shapes of the responses and what are the required parameters. So with that, let's dive into FETs. So the first thing that you have to do when working with FETs is take this open API spec. If you don't have a JSON, then you can, in the Swagger editor, you can click edit and click convert to JSON, and then copy paste it to your TypeScript file. So I'm exporting it, and another important thing is that I'm adding asconst at the end, so that TypeScript will infer like exactly the type, like it will take a look at the shape of this JSON and infer the type instead of it being just a record or an object. And having this one step done, I can create a client. So I'm importing create client from the FETs library. And then I'm also using this type helper normalize OAS that basically just normalizes some parts of the open API spec. And I'm passing as a generic parameter the type of my open API spec, and I specify the endpoint, like what's the endpoint where this client should send the requests. So we have the client, and now in my app file, here is the part where I'm using this client. So all of this is inferred by TypeScript. So if I try to type something different, I should have an auto-completion, and I see all the endpoints that are available. So if I switch to, I don't know, let's say audio features ID, and then, yes, I can see an error right away that, this endpoint will accept different kinds of parameters than the previous one. Make it slightly bigger. Okay, so what do we have here? Yeah, we have here that the query does not exist in this type. So what does? We can take a look. We have params. Yes, because we have we even have it in the string. And inside, what do we have? We have ID. Thank you, Copilot, for auto-completing this, and then I can comment it out. And another thing is that it also has like the open API spec that I got from the from Spotify, has information about the headers. So I suppose that if I comment this out, I should soon see an error. Yes, and I see an error that the headers property is missing. So, okay, so let me go back to what I had before. And we're getting the recommendations. So yeah. Okay. So then I can narrow down the response because here we have the OAS response from, it's a type from the FETS library. And then once it's done, if I hover on the recommendations, I can see exactly what is the type that Spotify's API returned. And I also wanted to show you another thing related to FETS. So there are a bunch of helpers. Like this is cool that we can deal with this client and we know exactly like what are they, like here if we hover, what are they, what shape is the recommendations property. But we can also use helpers like this this one for output. So for example, I want to see what type is, like what shape is returned from this endpoint, but specifically from if I use method get on this endpoint, and I can see that album has those properties. Or here I have an artist, or maybe I want to see what's the required input from a particular endpoint. So here I can obtain information, like pieces of information of what should I put in my query parameters for the endpoint album / and an album ID, and I have that the like in the query, it accepts a market property, which is also optional. Okay, so this is the FETS client, and I will very, very briefly also show you another part of FETS because, okay, actually, let me go to the browser and open FETS docs. Guild, yes, this one. So this is the documentation. It's under the Guild's organization, and there's a client and a server part. You can use both of them separately. As we've seen in this example, I only use the client, but FETS also lets you use. It also lets you create REST APIs with type safety. So here I have an example. Yeah, so I have a database. It's HDB database because I wanted to try it and play with it, and see how it would work with FETS. So in this from my database, I'm using a query builder to extract title and actors from a movie object, and I use the HDB's client to execute this query. Here I have the result. Those typings are given to me by the HDB TypeScript client. So like this is cool, and I would not want to lose it when communicating with the client. So you can take a look at the shape of this router. So I'm using create router from FETS, and then I'm creating routes. Here I have one with a path movies. So it might be a little bit similar to tRPC. If you're familiar with it, then FETS should also, and like the server part of FETS should also feel very familiar. And yeah, and what now? So as you can see, I haven't provided any special typings. Like I do have this handler that returns stuff. This is all perfectly typed. But now if I try to use FETS client and call it this newly created endpoint. I'm still using this create client from Feds as before, but now instead of passing an open API spec, I directly pass type of this router, because Feds can work both with existing REST APIs by providing it with the open API spec, or with the Feds server. So I'm also specifying the endpoint as before, and now I'm calling this endpoint the movies one. And if I hover this, I still have the same typing as before, without providing any additional type annotations, and it's all because TypeScript, because Feds was able to infer it for me. Okay, so going back to the slides. That was a little demo of Feds, but in summary, what it gives you is type safety out of the box. There's no runtime overhead because those are only types, so it will be stripped in your final build. And you have all the IDE features like auto-completion, go to definition, also out of the box. So in summary, it might kind of feel like we are reinventing the wheel, or like going in circles. But even though it feels that way, maybe we are actually getting closer to the core of the problem that we are trying to solve. And maybe we are just continuing to pursue the best solution while also removing all the layers of complexity and boilerplate. And another thing that here's a tweet that Dylan asked, who's also my ex-colleague. We work together on Blitz.js, and he asked which framework are you choosing? And there were a few options, and then Dax noticed that there were all people replying with different opinions, but no one asked about what's the project. And that's an important takeaway from this talk, is that you shouldn't jump into API solutions because they are currently hyped. You should pick the best tool for the job, and always evaluate the needs of your project and the needs of your team, and what will really work with the current situation. And also, it's quite important to embrace change and be ready to adjust your approach, even when it's trying a new API paradigm. So with that, I thank you very much for listening. If you want to learn more about Feds, you can visit the Guild's website, and then go to the Feds docs. And if you want to see it in action, the demo that I was showing with Spotify and the Mood songs is under my GitHub /Spotify-Feds-demo. And again, you can reach out to me with questions or feedback on Twitter. Thank you.
Thank you, Alexandra, for your talk. It was great. Thanks for joining us today live.
Thank you.
Thank you. It was a pleasure to collaborate with you. And now we are moving to the last presentation of the summit. Bye-bye. Of the junior track of Global Summit for Node.js 24, which will be delivered by Saeed Ali, who's also known as Macspace, software engineer, open source maintainer for GitHub and Asres. He will walk us through Jest essentials, elevating test coverage in Node.js applications.
Hello and welcome everyone. My name is Saeed Ali Mohammadi. You can find me mostly in the open source world under Macspace names. I'm a software engineer and open source maintainer at GitHub, and the CTO of Asres company and researcher at the university. It's my pleasure to be here and be a part of Global Summit for Node.js 2024 events and talk about Jest essential evaluating test coverage in the Node.js applications. You can find me mostly in the GitHub under BaseMath username. My education field is pure mathematics, and I'm programming for more than 10 years. As an open source maintainer, I'm happy and loving to sharing, creating projects, learning by sharing with other developers in the world on the GitHub. As introductions, I want to say all the testing strategy, different testings is here to increase your quality of project applications and detect errors, increase and improve the experience of the end user, and overall project success. And the main thing is about project success, because for making a project success, we need some solutions and methods and follow some way for it to happen. And the first thing is about the tests, because tests can improve the user experience, increase error detection, and improve the project, decrease the probability of problems, error, crash, and other things in the project. And as the main goals in our journey from Jest Essential, we will explore how Jest powerful testing is working, and how we can help you to increase your quality of software, how we can write and using Jest as a test framework to test everything, test component, test functions, test value, test everything. So I can say 5 things about the testing in software development. The first thing is about reliability. The second one, functionality and stability and users satisfactions and cost efficiency, because I want to say test is here to decrease your cost. So it is a bad belief that everyone thinks test is wasting time, test is just extra bill with we are wasting and spending a lot of money in testing, writing tests, testing, automate testings, quality checker, test engineer, and some other different role in the teams. I want to say it is not a waste of time and waste of the money. It is here to help you. It is here to save you. Save your time, save your project, save your brand, and a lot of things. So reliability is about just prevent unacceptable behavior for your user and make sure your project is reliability. And the second one is about functionality. Make sure every function, every component in your project is working as you expect. And the third thing is about stability. It can guarantee and let you have a better feel about your project is stable, and you can have better sleep at night when you want to rest, sleep. You have a better feel about your project when your project is on production and you have a lot of user, you have market, you have end user. And the fourth item is about user experience. So when a project is well tested, it can have a better chance for end user to have a better experience, and it makes sense. And the last item is about the money. As I said, it is not about wasting time and energy and money, and it can save you. Let us skip some steps, and Jest is here as all-in-one solutions because it's supporting everything you maybe think about testing your project. It is a simple framework, simple library, and it can help you parallel test, supporting async promise functionality of the JavaScript. It can snapshot your testing. It can provide some way for marking data, marking value, marking object from outside of the Jest, so you can import data, playing around, and improve your project. So why Jest? Because Jest is simple project built by developer for developer and engineer. The first item about Jest is it is fast and safe. Why safe? Because it's like a global state. When you're running a test, you want to make sure when you're running a test after another test, it should be exactly like when you run second test separately, So suppose we are going to run 5,000 tests, and I just want to make sure the order of the tests don't matter, So it can be one important part about the big project when you are writing 100, 200, 1,000 tests for your project. And the second item is about easy mocking. mocking data, importing data, or value for easily testing. You can use your models and see there are any other things for your project in your test. Just have, I think it has more than 100. Yeah, I think it's more than 100 function for testings to be close to equal, to strict equal, to have property, to match a snapshot, to throw runs. A lot of more. We will take a look on the function and be playing around the except functions. And who is using your Jest? I can say, based on the official Jest website, we can say Facebook, Twitter, New York Times, Spotify, BNB, Instagram, and many more. And we can say in the last month, they have more than 300 million downloads. Let's get a start. The first step is to create your new projects, new Node.js projects, so you can create a new directory and cd into your directory. And the next part is about creating a fresh Node.js project. And then we can install Jest as a development library and dependency. And then you can write a simple function in your project. Let's write, just do it right now, so it's better. Let's create Jest demo online cd. And as I say, the second step is to just initialize the project. npm is creating a fresh project for you. Okay, the project created, and as we can see, we have a package JSON file here. And then it's time to import the Jest library. Save the Jest. Okay, just downloading the Jest package from the internet. And the next step is to creating a file. So we can open the project in editor. But first we need to wait for downloading the package. Okay, let's just save the time and go to the directory, Jest demo online. Okay, we can create a new file like this way. And inside the package, we need to wait for Jest package, because after downloading the Jest package, it should be added to your package JSON. Let's continue and we will be back to this later. For Jest project, we have a directory titled test. I want to say there are several methods and solutions for having tests in your project. You can even have a custom directory for your tests, like test without underline. But the easy and fastest way for having test your project is to have a directory titled underline, underline, test, underline, underline. And inside that directory, you can have several separate files, and inside each file, you can have separate purpose for testings. So there's no limitations. You can have 1 file, 10 file, 100 file, anything you want. And inside the package JSON, you can have some scripts. Inside the script, you can have a test, and inside test command, you can running a Jest. The same is still downloading. And by using the npm test command, you can run the test. Here we are saying more than 10 of matter function in the Jest. For example, to be, to have been called, to have been called times, to have been called with, and a lot of more function. As you can see, Jest is supporting a lot of to be matter functions, so it can help you to easily writing a lot of tests as much as more you want. Yeah, and it's easily supporting the exceptions, error, draw, and promise for async functions and some more. Just including several sub package and modules. For example, Jest gets type. It is a package in Node.js ecosystem, and by using this package, you can easily get the type of a value. For example, it gets type of the array, no value undefined, and number, and some more. Oh, it seems it's just I already created another Jest project here, so let's have a look to that. As you can see here, inside the dev dependency, Jest added, and we just configured Jest to be test environments from Node, and we also added another dependency titled Jest get type. So it is what we said. And inside the script, we have some comment for like all test, which is the default test comment in your fresh Node.js application, and we added a test and watch test, which I will explain more about that. The first thing is about the type.js file. Inside this file, I just require just get type package, and if I go to the terminal and just run it, you can see the output of the program is array null and undefined. For example, let's do I check like this, run it again, and you can see the output is a number. So gets type is a function from just gets type package, which is a sub package. So I want to say this is a big framework, and it includes several sub packages that can help you for working and writing smoke data and so more. And first things about learning Jest is Jest has two main functionality and the comments. The first is about the stripe. The stripe is like a group. You can group your tests. For example, here we have a group titled mass operations, and inside mass operation group we have two tests. By using test functions, we can define a test case. So we call it test case. By having a test function, we have one test case, and we can have a lot of test case inside one Jest file, and inside each Jest file we can have several groups by having describe functions. Okay, let's to have more looks to the project. For example, here is another example. We have a mass operation group, and inside the mass operation group we have one test case. The first one is adds two numbers, and the second one is multiply two numbers. And inside the mass operations group, we have another subgroup titled subtractions, and inside that group we have another test case. So it is how it's working recursive. Okay, let's have a look to the project. Here I'm just created a sum.js file. As you can see, it is a simple files which we have a sum functions which plus a to b and return it, and we have a module export as a default export. And inside test directory, we can have a file, for example, titled test. Here we have a file sum.js. It don't matter the name of the test file. You can put anything you want. But here we just exactly have a main full name here, sum.js. And inside that we are requiring loading the sum function from the parent directory and sum.js file. And then we have directly access to the sum function, and we can define a test case here. Title it adds a to equals to 3, and then inside that test case we are accepting the output of these functions to be exactly equal to 3. Here inside the test directory I have 3 files, and inside each file I have a lot of test case just to show its workings. But let's run it by running npm test. By running npm test, it's navigates to the test directory and it will be run all of the tests for you. As you can see, we have some error in the matcher.js. It is like a warning because your test file cannot be empty and it should have at least one test case. As you can see, it's run it all of my file, and some JS file pass it all the test case. And in the Jest case, we have some magic function. For example, here we have some magic function for before running all the test case, after running all the test case, before each test case, after each test case. By using this, it can help you to easily run a command or print a log before, after each one, or after everything. Run a command. For example, you maybe want to connect your database, import some data once before starting, or maybe after starting, you want to clear your database, your cache, or anything you want. So they four magic functions can help you for easily. And let's to have more look to the Jest test case. For example, this one, it is easy. We accepting 2 + 2 to be equal to 4. Next one, here we are creating the object. Then we want to accept inside the data object, we want to have exactly equal to 1 key, 1, 2 as a key and 2 as a value. And also we can having some mock tests just to show how you can using for each iterate and for loop for easily helping for you. And here I just want to show you can have not just to reverse the equals. So we accepting ends not to be undefined, and n is null, so not to be undefined is a true value and a true test case. Let's delete everything from this file and just run it again just to see how it's working. As you can see, it will be runs 3 files, but I have only test case inside 1 file, so you can see this file is empty, this file is empty, and this file, as you can see, it's before all, before each, after each, and after all. And if I delete our comment days comments, you can see its facets and everything is fine. I just have to warning failed message, which is about the other files. So it can show you how many snapshot, how many times it takes to running everything, how much test cases, and how much facet and total number of the test. Test suite is like test file, and test is number of the test exception. For example, here we have just 1 test case, but we have totally 3 test suites. So we have 2 failed test suite and 1 passed because 2 of the files inside the test directory is empty and everything's commented there. Writing by Jest is nice because you have ability to add more feature to the Jest and extend it. For example, here, as you can see, we are going to create a new test case, a new matcher to the Jest. Yeah, as you can see, we are importing the excepts from Jest global, and then we creating the function which gets some argument value, and at the end we are extending the Jest. We just extending and adding a new matcher function to the Jest to be within range. It is something that maybe missed in the Jest, but it's not a problem. You can easily extend the Jest by writing any functions. For configuration the Jest, there are several different methods. The first one is about Jest config.js files. By having a Jest config.js file, you can write into your custom config for Jest. For example, top is the first example and the bottom is another example, which you can directly define some config for the Jest. For example, if you are enabling the variables to the true. The second solution is having a Jest config JSON file. So it is a JSON file, not a JS file. And inside the JSON, you can have your config for Jest. And the third method is to having a Jest block inside your package JSON. As you can see here, inside the package JSON, we have Jest block, and inside the Jest block, we have test environments as a node. So it is how you can easily configure your projects. But as a standard and best practice, it's better to have a Jest config.js file in your project or JSON file. It can help you to let everyone know you are using Jest in your project and you have a separate config file for your Jest. It is possible for Jest to automatically define or change your max worker inside the package JSON file. You can define how many workers CPU you want to use for running the test, and here it is 4, which is low. I can set it to 8, which is my current system have about 8 core CPU. And there are more features in the Jest. For example, you can keep running your Jest test by having Jest -- watch. Here I have one. If your project don't have Git, you cannot use Jest watch because it cannot easily track your change. But if you want to having Jest in your non-Git project, the first thing is I want to say it is not a good practice to not use version controls. I think it is a must and standard in the world to having a version control or whatever it is, a Git or anything else in your project. But anyway, if you want to running and having the Jest in your project, we don't include any Git. You must use watch all, and watch all will watch everything for you. Here are some more references from the official Jest website, which you can find more examples from Jest documentations. But let's do back here for Matter. I want to take more look to the file. The first thing is about the asyncs. As I said, it's just very good supporting Jest and promise JavaScript. For example, here is just an example. We're running the fetch data and then we're running the test case. So you can use promise and run an API and write test for your API as an end user, not like internal. It can be help you to write unit tests for your API from external practices, and we can help your quality. Next one is we have async function, and we can await keyboard here. So we await for data and then run the test case easily without playing around the promise. And the next one is we assertions ones, and then we have try cache, and inside the cache we are supporting, because it is important, because sometimes we want to make sure we have a standard error, and we can checking error cache and to make sure inside the exception error we have this message, it is a type, and so more. And you can combine it, and it is the before after all magic function, which I mentioned it's about a few minutes ago. And inside the group we can have before each magic function as well, and it can help you to easily define before each, after each, or before after all for a specific group, not your interfile. So it can help you to easily, for example, here we want to playing for matching the city. Before each one, it's better to initialize the database to make sure the database is really fresh before running each test. And in this test case, for example, here we just make sure we have a food inside the OEM and another for another city. So it is how we can combine the matter function in the Jest. Our biggest file, matter.js. I just collect 100, maybe more example and unit tests here for you, so it can help you how Jest is working. For example, you can run a functions and to make sure the output is this value, or maybe reverse, you want to not to be equals to strings. And next one, you can create an object and create a group, and inside the group you have two test cases, and you can check a value of your object to be exactly equal to 12, or maybe names be equal to a string. I have many more examples here. I just want to have a quick look together so we can learn it more about the Jest. It is for mapping, so it can help you to have a map functions. For having tests for property, Jest have some function matcher. For example, to have property. Here we have a house for sales object, which includes that. And I want to make sure best property is included in my object. And also I want to make sure bedroom is equal to 4. This line just check this property exists or not, but the next line just checking to make sure this property exists and the value is equal to 4. And here we are using the nuts to not having a property to make sure we don't have that property in the object. And here we just having to make sure we have a property with the array value. And like this, we want to make sure two different property in the object is equals to and have same value as a value of the property. Or maybe we want to use array for both property array and for exceptions value. And it's how Jest is working. So you can write a lot of tests for your project, and it is not a waste of the time and energy and the money, and it can help you to have a better feel about your project, make a stable project, and help you to sleep better at night. And one important thing is about the float points, float number, because we know floating systems in the computer is not accurate. So when you add two floats or doubles number together, it can create and make error, and error can be very big in big calculation. And it is not everything that we say the error of calculation with float is very, very low. You can search more about the float calculations error and just find real test case to see it can be really, really dangerous for your projects. But here we have a function in the Jest title that's to be close to, just to make sure this value is close to. And here we have a function title that's to define it, just to make sure this value is exists and is not equal to undefined. And here you're running a function and again get errors, and to be false is a function to make sure its value is a kind of the false value. And also we have to be truly or maybe more function like to be greater than, to be greater than or equal to be less than, to be less than or equal to. Also we can get the type of a class inside the OOP in the JavaScript. We can have different stance of classes, so we can check to make sure, for example, this is a stance of the functions, or maybe here it is an object from class and we are just checking to be equals to a time function which is wrong. So if I uncomment this line, it will be stop my test case, and just if you let you know we have an error here and it's failed. Whatever, anyway, we can have this except function inside the test case or inside the group, so it can organize your test and make it better and get in. Here we just make sure the output of this function is equals to null, or maybe here to none, because we know we have none type inside JavaScript. For example, here we have a none number, and here 1 is a number, so we should have not to be none. And here it is a function which return value, and you just want to make sure it's include and contain a value, or maybe to contain equals. I just to make sure this function return an object which includes these two. Also, we can use regular expressions and regex for easy writings, more powerful tests to match object, to match string matching. Maybe you want to make sure it includes two different words, or maybe you want to auto empty a string, so you can easily use different functionality of the regex. You can find more about regular expression as well, because it is really powerful. Let's have a faster look to the project. As I want to say, it also can help you to handling exceptions, error, and just to make sure it is equals to error exceptions, or we can even check the type of the exceptions. Here we have a regex hello world. I just want to make sure it's included and it's equals to this one. Here we have callbacks. For callbacks, we can having and use the Jest async feature. For example, we have a do async function which call two different callbacks, and the first one is accepting data to be true, and then second one is do another things. So you can having this one and accepts to have two assertions, so it can help you to have and define the number of your assertions in your test case. It is the example we talk about. Here we created to be rearrange functions, and we are extending the Jest and adding these functions to the Jest like this. So we're adding these function names and here is the actions and callback of the functions. So as you can see, here we are handling the value just to make sure the type of the argument is number. If the type of the argument is not number, so we can type error. Otherwise, we will just make sure they are in a range or not, in pass or not pass, and then we are returning message, test message warning. So it is the methods Jest is working on the backgrounds. They write a lot of function with some return that include message and pass true, false. So we can say it is about true or false. So we cannot have a test case which is true and which is false. It's not possible. So one test case should be true or false. It can not be together at the same time. So it is how you can run your test case. And here is the matcher. We just take a look. Group, feature extending, config files, setting the worker for your projects, running the watch. Let's do run it in the npm run watch test. If we run the Jest in the watch mode, you can see we have more feature, more functionality here. It's running the test and give you some comment. For example, run only one when failed test, or maybe you want to only run tests related to the changed file. It is good because if you have a big project and you are changing some part of the project, you can only run the test case and the test groups which is related to your recent change. And it is why, as I said, just watch needs gits. But if you don't have a git, you can use just watch all. I mean, inside the package JSON, you can have watch all or watch. It's depending on you. Anyway, you have some functionality. If you want to quick and close the Jest, you can press Q. Otherwise, you can enter to trigger and running the test, or you can see to filter the test case by name. It is like supporting rejects or maybe exactly the test name of the project, so you can help you to exactly run a specific test case or group. Yeah, thank you for your attention. It was my pleasure to be part of this here and just sharing some example from having Jest in your projects. For any kind of the questions in the future, feel free to contact me. Thank you so much. Have a good day.
Thank you, Max, for the presentation. And I'm glad to announce that the junior track of the Global Summit for Node.js 24 is over. Unfortunately, our speakers from last block couldn't manage to join us for the Q&A session, but we will be glad if our audience will join us tomorrow. We have 13 more presentations for a senior audience, and you can still buy a full access ticket to that. So I want to thank all the speakers who joined us to deliver. And here is some information. And I want to say thank you to all the speakers who shared their insight with us today, who spent their time preparing and contributing to our community. Thank you so much. Thank you for the audience for being active in the chat, and see you tomorrow.